It's a privilege to attend this function.
The first day was a huge success.
I really want all of you to come for next day.
Ladies and gentlemen, may I have your kind attention please? We will be commencing the program shortly, so I request everyone to be seated. Before we begin, I have a few important announcements. If you have not yet completed your registration or collected your delegate badge and conference kit, please proceed to the registration desk on the ground floor. Should you require any assistance during the event, our volunteers who can be identified by their volunteer badges will be delighted to assist you. You may also visit information desk on the ground floor for the same. May I request everyone to keep your mobile phones on silent or do not disturb mode throughout the event so that we may all experience an uninterrupted experience. Thank you. I would request all the delegates sitting behind to please come forward and occupy the vacant tables. Good morning, everyone. Once again, I request all the delegates sitting behind to please come forward and occupy the vacant chairs. Good morning, ladies and gentlemen, and a very warm welcome back to Day 2 of the Dostas International Maritime Seminar 2026. We hope you had an enjoyable evening and are refreshed for another day of insightful discussions, knowledge sharing, and meaningful network. Today's program promises another exciting lineup. We begin with a panel discussion on breaking import dependency in shipbuilding, followed by our first technical paper presentation session powered by Mazagon Dock Shipbuilders Limited. After lunch, we return for our fourth panel discussion on AI and automation in ship design and shipbuilding. Before concluding the day with our second technical paper presentation session powered by Dassault Systems and our valedictory ceremony. Before we begin, I would like to announce once again and express our sincere appreciation to the organizations whose generous support has made DIMS 2026 possible. Our platinum sponsor, Aviva, our gold sponsors, Mazagon Dock Shipbuilders Limited and Dassault Systems, our silver sponsors, Cadmatic and Chowgle Shipbuilding Division. Thank you to all our sponsors and partners for their continued support and contribution to the success of DIMS 2026. With that, ladies and gentlemen, let us begin Day 2 with our third panel discussion, Breaking Import Dependency in Shipbuilding. As India continues to strengthen its maritime capabilities, this session will explore how collaboration between shipyards, the Indian Navy, the Coast Guard, classification societies, and research institutions can accelerate indigenization and strengthen India's defense shipbuilding ecosystem. We now move to our first panel discussion. May I now invite our chair for this session, Rear Admiral Sujit Bakshi, Director General, Warship Design Bureau, an accomplished naval architect and alumnus of CUSAT, who has been closely associated with the design, construction, and life cycle management of numerous Indian Navy warship and submarine programs, including 4 aircraft carriers. Ladies and gentlemen, please welcome Rear Admiral Sujit Bakshi. Welcome, sir. May I now invite Commodore Mohit Goel, NM Chief Quality Assurance Officer, Marine Systems, Indian Navy, a distinguished marine engineer, Sena Medal awardee, and maritime strategist whose expertise spans naval engineering, quality assurance, and the future of India's shipbuilding industry. Welcome, sir. Next, may I invite DIG Manoj Pandey, Superintendent Coast Guard Refit and Product. Okay. May I invite Mr. Ishvi Ramesh, Head of Technical and Chief Surveyor, Indian Register of Shipping, a distinguished naval architect with over 3 decades of experience in ship design, classification, and maritime standards, who has represented India at the IMO and currently serves as General Secretary of the Institution of Naval Architects, India. Welcome, sir. Finally, may I invite Ms. Anjana KR, Chief General Manager, Design and Material, Cochin Shipyard Limited, an accomplished naval architect with nearly 3 decades of experience in ship design, production engineering, and defense shipbuilding, currently leading the Design and Engineering and Materials Procurement Department at Cochin Shipyard Limited. Welcome, ma'am. Now, I have the pleasure of handing over the session to our chair, Rear Admiral Sujit Bakshi. Sir, the stage is yours.
Good morning, all. First of all, it's a privilege to be here today. God's own country with all the blessings of the God. A lot of rain is there. Coming from Delhi, it's really good. So we have a extremely experienced panel on the stage. Cumulative, one chair is missing, but cumulative experience of almost 175 years in this ecosystem. So we have the shipbuilder, we have the class, we have the QA, and we'll have the user also. So what we'll do is we'll do 15 minutes each. They'll present their thoughts. Thereafter, we'll have a Q&A with the delegates present here. And then I'll close the session in last 10 minutes. So may I request Anjana ma'am to please.
Warm good morning to everyone. And I would also like to thank the DIMS organizers for giving me an opportunity to present on one of the biggest challenges that the heart of India's shipbuilding is facing today. As of today, if we look, we have made real progress in, I think, hull construction and hull-related systems. However, 60% of the ship's value comprises components and equipments, most of which we import. And this is, over the next few minutes, I'll take you through why this matters, where India stands today, the bottlenecks, and some thoughts on how to mitigate the gaps. So I think this has been highlighted in several forums, but repetition is the key to imbibing in the heart. So the component manufacturing mission lies within this main scheme. That is the National Mission of Maritime Amrit Kal Vision 2047, launched at the Global Maritime Meet 2023 by the Prime Minister of India. India's ambition is quite high. It wants to be the top 5 among the global shipbuilding nations by 2047. And why is this ambition set very high is because our current market share is just 0.6 to 1% of the market value. But the government has this time backed it up with what you call 3 instruments with a 69,725 crore cabinet package under the Shipbuilding Financial Assistance Scheme, the Maritime Development Fund, and the Shipbuilding Development Scheme. But the key takeaway that I want the audience to take from this slide today is that hull construction is matured to a large level in this country. However, what is unfinished is the equipment and system integration. So let's look at why indigenization matters economically. India's shipbuilding market is poised to grow from around 41,000 crores to roughly 96,000 crores by 2036. But the point that we have to look at here is, among this, there is an increase. The component factor comes 24,600, and it grows roughly by 19% to 57,600 crores. And the total cost of the ship value comprises 60 to 70% of this cost is the ship's marine equipment, and that's where is the catch. The share that is import dependent. So even if we get to build a lot of ships, we still import a lot of equipment and components, and so the economic value that we derive goes out of the country eventually. So this is why indigenization of ship components matters and is to be addressed with utmost importance. Beyond the economic benefits in the previous slide, indigenization also carries other benefits under the 4 heads below. The operational benefits avoids force majeure scenarios due to global geopolitical escalations. Our yard has also faced this recently when we were importing equipment due to the West Asia crisis. reduces lead time for material availability. The transit time usually takes 45 to 60 days, even if the shipment is from Europe or Southeast Asia, and additional days for customs clearances at the Indian ports before the material finally reaches the shipyard. And so it also reduces transportation cost if you're able to manufacture this indigenously. The second is economic and industrial growth. It reduces exchequer losses, encourages research and development, innovation and export potential, and creates local employment opportunities. Strategic independence and security. It reduces the import dependence and ensures continuity during disruptions, especially with respect to spares for all the ships that we built in India. Strengthens self-reliance in defense and speeds up maintenance. Sustainability and long-term value. Reduces the carbon footprint through localized production, builds resilient supply chains for future challenges. So before we tackle the problem of component indigenization, let's have a look at what are the systems that come across in building a ship. A vessel contains a vast number of components. So components, first we have tried to group the components into eight major systems. And under these 8 major systems, we have also mapped out 80 subsystems. So these are the 8 subsystems that has been identified. And if you look at the contrast in the slide, it's very obvious. Structural axis and hull systems, they contribute to about 38% of the ship's cost, but our import dependency is lower over there. However, if you come to the propulsion and mobility systems, they contribute 25% of the ship's cost, but 95% is import dependent. The same you can see is applicable for communication systems. This is where the real problem lies. So why this mapping is essential is, this mapping is essential so we can actually focus on, or we can categorize the components which require policy interventions, because it's not the same interventions that are required across the different systems. So we have actually, this chart maps up all the 80 subsystems along the two parameters. That is, if you take our manufacturing capability in India on a scale of 1:5, we have mapped it with capability less than 5 and greater than 5, and value parameter as anything above 1% and less than 1% of the ship's cost. So the first category would be the what you call the strategic manufacturing. And these are the highly critical equipments like the main engines, the gearboxes, the controllable pitch propellers, navigation systems. So these are controlled by IP rights and are mostly with international manufacturers. The challenge is that we really do not have any domestic capability and would require joint ventures or licensed manufacturing with technology transfer. They also call for large capex if factories have to be set up for manufacturing the same, and probably a 7 to 15 year gestation time to materialize. Now, if you go to the second category, we can say that we have capability. India has the manufacturing capability. Value is also slightly about 1% of the ship's cost. And these are the smaller DG sets, the pumps, valves, switchboards, and cables. Capability exists, but the two key things that we can say is that they all would require type approval, and global after-sales support is lacking in these areas. So this is something which can be focused on immediately, and this is an area where indigenization can be taken up faster. Then we come to the category 3, where you have again capability is existing in the country, but value is slightly less. But this can be pushed through, I think, strongly with MSME enablement. The last one is capability is again less, but however, the value is also very small and can be parked aside for the time being since no active interventions, and we will actually monitor it for future opportunity. In this regard, especially with respect to the type 1 category, I would like to say something, draw some parallel from the solar panel manufacturing industry, where they have something called a valley of death concept. So they produce something which is really real and demonstrable in a pilot or a lab, but that dies between the proof of concept and before it is being commercially manufactured. That is because this requires patient capital behind it. That's exactly why this particular thing requires joint ventures and technology transfer rather than a quick certification fix. Some of the other bottlenecks that can be seen in ship component manufacturing is these have come out as part of our discussions with stakeholder consultations with different stakeholders as part of CSL's indigenization committee's efforts. So one is the lack of demand visibility for ship components. This is what most of the manufacturers have come up and told. So they can't plan capacity without a forward order book. The next one is recurring classification charges and higher investment. I've got a subsequent slide on this where I'll explain this in more detail. Raw material quality issues, inability to provide global after-sales support. Limited consideration for defense shipbuilding vendors with proven skills. There are defense shipbuilding vendors actually, because the Indian Navy has gone to great lengths regarding indigenizations, but they have not been actually inducted into the commercial shipbuilding projects, and this is something which can be looked at. Probably this could be because the defense requirements are much higher than what a commercial ship requires, but I think definitive efforts in this direction could prove to be helpful for the commercial market also. Another thing that we've noticed is the basic customs duty levied on imported components used in the manufacture of equipment. So if somebody is manufacturing an equipment in India, he probably would have to import certain components and he has to pay basic customs duty on this. However, if a shipyard imports the same equipment, it is exempt from customs. Duty. So what happens is the person who's actually indigenizing something would have to bear a higher cost, and when the shipyard compares the cost, probably importing would be a better option for the shipyard. The next one would be the technology and IP barriers. This is again for the category which comes under the strategic category. Most of these equipments, they come up with proprietary electronic control units, export control regimes, and other global regulatory practices that block reverse engineering pathways. We also have limited testing facilities in India for equipment qualifications and type approval, especially with regards to EMI, EMC testing. We do have labs, but considering the scenario or the quantum of shipbuilding that is carried out by the country these days, it's actually very less, and there are long waiting lines for equipments to get tested. Then the fire toxicity testing labs are also very scarce in India. Financing constraints, banks still treat marine manufacturing as high risk. The ministry schemes of SBFAs and MDF are aligned towards yards and not the equipment manufacturers. And for shipbuilding to thrive in this country, auxiliary equipment manufacturing needs to be given that required thrust. Again, we do not have integrated maritime clusters. If you go to Korea and Japan or China, this is what helps them the most, that is what I feel. Yards are dispersed across the 7,500 kilometers of coast with no linked supplier ecosystem. Then another thing which is of the utmost concern is the HR and skills deficit. We really do not have industry-ready manufacturing engineers, technicians, and no apprenticeship linkage to equipment firms. In this regard, we can actually look at the German apprenticeship model, which is very good, where it's either a 2 to 3 year course, and the student, he actually spends 60 to 70% of his time in an actual industry and 30 to 40% in the university learning the theory. So it's probably on a weekly basis. So 4 days he would be in the plant, 2 days he would be studying the theory, and he comes fully equipped for the industry to absorb. There's another thing, the curriculum is standardized across the country. So he can be used anywhere within the country. The examinations are also very stringent. So the person who's coming out qualified is really qualified. And so this is something which we can approach where we really face skilled technicians, lack of skilled technicians in the manufacturing sector. Classification society bottleneck. If you talk about import ships, most of the European owners, or they would prefer the global class standards. Now, even if a vendor in India is type approved by the Indian Register of Shipping, it is not recognized internationally. So he would have to go again for type approvals, and which is a recurring cost on this firm. So these are some of the approvals that the classification society requires. One is a type approval. Next is the approval of the manufacturing works. Then probably they also mandate product certification per type batch and annual surveillance renewal of the manufacturing facility. So if an Indian manufacturer is venturing out for marine manufacturing, he has to go through this process. And what we have seen is higher class has standard rates, but most of the international classes operating in India, the rates are somewhere twice and this is probably because of their global rates and specialist surveyor travel. So we can see that manufacturing venturing into this, before even a single certified unit is sold by him, it is a genuine multi-layered capital barrier for him and is something which must be addressed. If you take the oil and gas industry, they go by the API standards, and that is of course recognized by the marine offshore industry also. So why don't we think about something integrated in that sense, so that the burden on a manufacturer venturing out into marine manufacturing is reduced. Some of the way forward that can be thought of under each category is, we could think of some production-linked financial assistance so that people have the incentive to scale up or incentive to entry into marine manufacturing. CapEx subsidy, this is again very important for the strategic equipments like the propulsion engines, the propulsion motors, the steering gears, because this requires complex test beds, complex manufacturing facilities, and a highly CapEx intensive. Classification subsidy is something which we can also think of to unlock this marine market access. Again, testing centers more can be set up with public-private partnerships so that there is shared infrastructure for everybody to go in for testing facilities. Technology transfer, again for the strategic equipments. Classification reforms and regulatory reforms. That is, if I have IRS, we have IRS type approval or any other classification society's type approval, it would be good if they mutually recognized each other's type approval and that the burden is not passed on to the manufacturer. So in turn, the shipbuilder gets the benefit. Then there is this demand assurance framework which we have to really project to the manufacturers out there. We have taken up a series of efforts as part of indigenization. We have planned a series of conclaves, and we have already conducted one for pumps and valves aimed at educating the auxiliary equipment OEMs about the marine sector projects. We have also set up a center for indigenization and self-reliance at Codizia, where we plan to actually keep samples of marine equipments that we need to indigenize with, the requirements for the same. Again, we are also, as part of the ministry's indigenization committee, we are in discussion with formulating something like the ship component manufacturing scheme. And we are also in discussion with classification societies as to how inspection charges can be reduced, especially based on some MSME categorization. So the conclusion, we can come to say that India has the geographic endowment, a growing defense pipeline, engineering talent, and the political will, which is very evident today. What's missing is the policy architecture to activate it to scale. Our pump and valve initiative definitely shows that India's industrial base is readier than commonly assumed. Global shipbuilding is transitioning onto decarbonization and fleet replacement, and India must move before the new supply chain architecture solidified around East Asian leaders. MAKV 2047 gives the narrative. These schemes give the structural roadmap. The window is constrained. Execution must grow. Thank you.
Now I would like to invite DIG Manoj Pandey, Superintendent Coast Guard Refit and Production Team, Goa, Indian Coast Guard, who has led several key ship acquisition and indigenization initiatives for the Indian Coast Guard and brings nearly 3 decades of experience in ship production and defense project. Welcome, sir.
Welcome, DIG Manoj Pandey. Thank you, Anjana ma'am, for bringing out in the details of costing and supply chain challenges. So now I request Mr. Ramesh to present his perspectives.
Yeah, good morning, ladies and gentlemen. Admiral Bakshi, distinguished guests on the dais and on the stage. Okay. After a very late dinner yesterday, being back here to listen to the lectures and the panel discussions, it's heartening to see everybody in the same zeal as yesterday morning. Thanks, Dostas, for giving me this opportunity to speak at this conclave. Most of my points have already been covered by Anjana ma'am, so making my job a lot more easier. I'll have to present this as well as to answer a few of her points as well. Yeah? We have all of us have been hearing about Maritime India Vision 2030. We are talking about Maritime Amrit Kal Vision 2047, where we said that India needs to be one of the shipbuilding nations by among the top 10 by 2030 and among the top 5 by 2047. Towards this, there are many initiatives being taken by the government, which yesterday Shri Shyam Jagannathan, Director General Maritime Affairs, have enumerated. I'll not go into much of the details. One of that would require a very thriving, strong ancillary ecosystem that we have to build in this country. So that one is to reduce import, the other is to increase the manufacturing. For this, we need to have a thriving shipbuilding to happen, for which Government of India is making efforts. And the ancillary industry not only should cater to the domestic demands of the country, but as well as in the future scale up, taking from Ms. Anjana's presentation, with the new supply chain for the new technologies that we have. These are the 4 pillars under which the Government of India is supporting the maritime sector, maritime shipbuilding. We all have heard about the mega clusters that are being built, and these mega clusters are supposed to have integrated facilities with dry docks, slipways, shade testing labs, dedicated logistic corridors, and advanced research and development, as well as the shipbuilding design centers. One of the primary thing of the clusters will also include ancillaries are encouraged to set up within the maritime clusters, ensure easier access to raw materials, equipment, components, and trained workforce. This, because it is inside the cluster, will also reduce the logistics cost, also the timelines of execution. We can also create training centers within the cluster depending on the type of the cluster that we are going to plan. We can have R&D and integrated testing facilities. Additionally, we have the incubation methods. This provides to the ancillary manufacturers the local opportunities to supply to the locally available cluster. At a national level, we can supply the equipment to the various other clusters, interact with various other shipyards, ship repair facilities, and in future should be able to cater to the international shipping market. Here, just taking a little break, the defense shipbuilding is successful due to, we all know, a projected aggregated demand, which attracted not only investments into the shipyards, but also the Indian indigenous ancillary equipment manufacturers, encouraged land-based manufacturers to invest and produce towards the maritime manufacturing. And with the help of the Ministry of Defense, Indian Navy and Coast Guard, we had positive indigenization lists that we have made, initiatives such as IDEX, etc. Today, Indian industry possesses the proven capabilities across a broad spectrum of marine engineering, that's from engines to propulsion systems to DG sets to steering gear systems, valves, heat exchangers, etc. But we have high-powered marine engines we are not manufacturing in this country. Large reduction gearboxes are not manufactured in this country at this stage. This requires further scaling to meet the needs of the merchant fleet. The progress achieved thus far has laid a foundation and given us the confidence that we can achieve much bigger and much beyond this existing things. This transformation has been primarily by the growing opportunities and capabilities of Indian manufacturers who have progressively expanded from fabrication and licensed production to the design, development, and manufacturing of increasingly sophisticated marine equipment. Throughout this journey, IRS has served as a trusted technical partner to the Indian manufacturers by providing independent engineering assurance from the early stages of product development through design appraisals, prototype testing, certification, and shipboard integrations. IRS has helped the manufacturers develop products that are robust, reliable, compliant with internationally recognized standards, thereby facilitating their successful induction into service. This defense shipbuilding is a catalyst in creation of this ecosystem and accelerating whatever is already there existing and bringing in more ancillary manufacturers into this sector, thereby reducing the dependencies of imports. Similarly, what is happening at the moment, the government of India is looking at aggregating the demand for commercial shipbuilding. We have seen yesterday, so far we have got 1 year plan was 62 ships ranging across the sectors from the oil and gas to the shipping, to the dredging, all these sectors have been identified and these orders are being placed. And this, with close to 437 ships, can create a demand for equipment, and this is where we should tap our potential. This is an opportunity that we all should focus on and build up onto this. Added to this, the opportunities are being provided by the Government of India across, as has already been told by Ms. Anjana in her presentation. There are broadly 8 categories that she has already spoken, where she has mentioned about how and what is the percentage of dependency or import that is happening vis-a-vis the cost, and the subsystems and the subsets have been also identified, and the Government of India is working on those. These are some of the low-hanging fruits which we are talking about: valves, piping fittings, gaskets, flanges, firefighting systems, mooring equipments, marine coatings, and many more which are there, which are low-hanging fruits. So we have some of these challenges that we face, and I try to, I've been given, I have 5 more minutes, yeah? This is a slide which I think we should focus on. The traditional thing is, one is bringing awareness across the land-based systems. There are many manufacturers in the automotive sector who are doing this. We are trying to, at IRS, we are trying to speak to them, interact with them. We are also creating, having workshops in all these hubs which are there. Coimbatore, Kolhapur, we did one in Mumbai, and we are also participating in various forums that are there where we can attract this into this country, into the shipbuilding sector. But the second thing is competence and skill. This is where we need to look at. We have a lot of engineering colleges, lot of training institutes which focus primarily on teaching land-based design of machinery and equipment. We require different, in addition to that, we have different methodologies that we need to follow when it comes to shipbuilding, because we need to consider vibrations, accelerations, shock absorption, all these things that we need to look at. So we need to probably have an additional courses trying to train them both practically as well as theoretically, so that they will be brought into this maritime ecosystem. The third we have is encouraging research and development. This research and development can be in multiple levels. It needs to be more application and industry driven. There's a considerable scope for collaborative research and development through joint industry projects with shipyards, equipment manufacturers, ship owners, classification societies, research institutions, and academia. Demonstration projects are particularly important. A product becomes easier to be commercialized when there is a reference vessel and a proven design and a proven experience. Government is supporting the maritime research and development through various schemes. I think we should take advantage of this and we should go forward with that. The other thing is collaborations. While we have our technologies, we should use this and leverage this foreign technology partnerships to accelerate capability development. Instead of simply importing finished equipment, India should encourage technology transfer, joint development, local manufacturing, and localization of critical subsystems. Strategic collaborations can give Indian manufacturers access to proven designs, testing methodologies, certification, and global markets. The end objective should be an Indian company that can eventually design, manufacture, certify, supply indigenously and export the product independently to the world. IRS can help come in here, fill this gap between the Indian manufacturers, which are land-based manufacturers, and try and bring them into the maritime ecosystem. We are by early engagement with manufacturers during the product development to identify applicable marine standards and requirements, guidance on testing, validation, and certification requirements, supporting the manufacturers in converting an existing land-based product into a marine quality and qualified product, creating greater visibility for approved Indian products and marine equipment among shipyards, ship owners, and international customers. In other words, IRS can bridge the industrial capability and maritime acceptance. See, IRS, you've just heard, classification societies deal with type approval of products, unit certifications, with design, at some times we require design approval of this. See, we undertake all this. We provide end-to-end support, including the design review, type approval of marine equipment, through factory inspections and manufacturing quality audits, testing and batch approval process. This is an involved process that requires complete involvement of both the class, the manufacturers, and the equipment designers. So the costing part aside, we can, if we start engaging right from the word go, we can optimize the time that is spent, the time that is being consumed between the initiation of the project to complete certification of the project. So it's always best to start interacting right at the day one, identify the process, and then we complete the process in all. Why India? Why IRS type approval? I didn't want to speak much on this topic, but see, IRS is an IAX member, which is among the 12 IAX societies which are recognized by the global flags administration and the ship owners, the underwriters. So the certification of type approval by IRS, if it is not being accepted, we will have to take it as a special case. We'll find out from where it is, and we'll see and work on that. Mutual recognition, mutually accepting type approval. Type approval by other class societies is generally accepted. There could be some special cases which probably again needs to be looked at, which we will have a separate discussion on. Why obtain IRS type approval? It will provide market access, global visibility, faster acceptance, independent certification, and quality demonstration. What are the stakeholder benefits? Shipyards will get a faster equipment approval with reduced delays. For the ship owners, it's a reliable product and it's an assurance with reduced operational risks. For the designer, the confidence in the equipment compliance. And for the flag administrations, it's an independent technical verification. Creating an ecosystem for indigenous marine equipment, from component manufacturing to complete maritime technology. IRS can support the entire ecosystem, development, certification, deployment, and globalization. Let me tell you, as we speak, in India, we have today manufacturers who have recently got a lifeboat type approved, which is the first in the country. We have type approved fuel cells. We have type approved Indian manufacturers for sewage systems, oily water separators. and fuel cells. We today have type approved battery manufacturers for propulsion in this country. So you should be able to go talk to them and then instead of importing, look at how to leverage this available ecosystem in this country. So coming to develop, we can engage with the OEMs, startups, shipyards, technology developers at the design stage to provide them clarity because they are the land-based people. We need to tell them, guide them how to get into this ecosystem. We can certify, type approval and works approval can be provided by IRS. We deploy, facilitate acceptance of certified equipment for installation of classed vessels, build confidence among the ship owners and shipyards through independent certification, and globalize, align Indian products with international standards, compliance of IMO IX, leverage IRS international presence. Today, IRS is available in all continents across the globe. So come be part of the Indian maritime revolution. Your innovation, our expertise, that is IRS's expertise, government support will take Indian maritime ecosystem of ancillary industries and shipbuilding to be a market leader and achieve our goal of our vision. Thank you.
Thank you, Mr. Ramesh. Very well spoken. I think IRS is doing a lot of work. They also have a lot of information in terms of vendor base and other things. So maybe that can be shared with shipyard. Shipyard should bring all the class together and resolve maybe the issues. So now I request Commodore Mohit Goel, my coursemate, to speak.
Good morning, ladies and gentlemen. I will go into the details of what are the problems today we are facing. I will give you certain examples and I will present a concept of forex camouflage where we are presumably doing indigenization and how the forex is leaking. If one or two slides can make you think further, I think I would have achieved my aim. So there is a huge forex which is leaking in shipbuilding. On top of it, Made in India and Make in India are the slogans which we are following. However, as the previous speakers have brought out, that a huge amount of dependency on foreign imports is there. I will give you certain examples of indigenous equipment where we have paid in Indian rupees and how much percentage of foreign exchange is being spent on these Indian equipment. This is just to give you an idea of how the value chain of a new build is today costed. 30 to 35% is machinery and propulsion, electrical systems are 15 to 20%, engineering design is about 5 to 5%, and hull and structure is about 25%. These things varies, of course, depending on the complexity of the ship and the experience of the building yard. Large two-stroke marine propulsion train, this is one of the most important thing which is missing from Indian ecosystem. If we see the thrust block, the shaft, the stern tube, and the propeller itself is getting imported. Even though these packages are being costed in Indian rupees, about 87 to 90% of these items are purchased in foreign exchange. Let's take an example of an indigenous reverse osmosis plant. This plant was indigenized 15 years back, and about 48% of this plant is still imported. A reverse osmosis plant has got two important components, that is the HP pump and the membranes. Both even today are imported. Marine sewage treatment plant. 10 years back, this plant has been indigenized. We pay in Indian rupees. This plant has got about 95% of imported components. ECDIS system, there are companies in India which are marketing this. We are paying in Indian rupees. This is having roughly about 94% of import components. AGI system, which is used for weather systems, this is like a standard fit on all ships, whether Navy or Merchant Navy. 87% is import component. SATCOM and bridge systems, this is almost 100% import components are there in these systems. And not only that we are losing foreign exchange, there is a high amount of dependence on a foreign satellite for such a system. Motorboats uses these OBMs. We have manufacturers which are making boats. However, this simple outboard motor, there is a complete dominance of imported substitutes in this. Galley equipment and ship furniture, Indian companies are doing this job. We are paying in Indian rupees. However, galley equipment, galley furniture and ships furniture are coming from various countries. On Indian built ships, I see no reason that we have to buy furniture from Norway or a table from Poland or a small chair from Sweden. But that is the hard truth which is there. Marine centrifuges, this equipment was indigenized about 25 years back. Most of the main components of this are imported. Sandwich panels, this is the standard panels which are used in outfitting. This, to a very large extent, are still getting imported, and one of the biggest supplier today for these sandwich panels is China. Paints, we have been highlighting that we have got indigenous capability of manufacturing paints. However, the key components of these paints are still imported, and almost all the Indian manufacturers are highly dependent to import the basic raw material from European sources. So mostly these paints which are kind of indigenous paints in where you're paying in rupees, they are blenders. A simple thing like nylon rope, a mooring rope which is used on a ship, the basic raw material is imported. We are highly dependent on this particular raw material which is used for creating these ropes. If we have to make 430 ships or more, we will need anchors. Anchor is a very less sophisticated item. It just needs a good quality casting. All big ships will require big anchors. Today we do not have this capability, and we are importing anchors. Everybody is importing anchors. I would like your attention on this particular metal, which is copper. Till 2018, India was exporting copper. We were copper surplus country. And you are aware of that famous case in Tamil Nadu where the copper smelting units were closed down due to local agitation. And now we are severely dependent on imports for copper. This has got a direct relationship to our shipbuilding and EVs and solar panels, and everywhere copper is used. Also, the copper cost is shooting up. So if you are looking at making a ship and you miscalculate the variation in copper pricing, you will be importing very expensive stuff, or your subcontractors will be making very expensive stuff. Sometimes they won't be able to even supply. The cost escalation may go up so much. Marine grade shipbuilding steel, this is a study in itself. We all know that Indian Navy is now almost using 100% indigenous steel, which is of a much higher quality. But for some reasons, because of lack of aggregation of demands, disconnect between the steel industry and the shipbuilding industry and the shipyards. We are still importing ships for merchant ships, which is a lower grade steel as far as the quality is concerned. Even the steel which is used in submarines is now built in India. Nickel. In your studies in future, kindly keep a close watch on this metal. When you make stainless steel, which will be used more and more, the 50% the cost of that metal is of nickel. We are completely dependent for nickel imports. Nickel just doesn't exist in our country. It is imported from Norway, Japan, Canada, and some other countries. We need to be friendly with these countries in the foreseeable future. Model testing. This is one of the fundamental things which is done when a new design is made. Despite having domestic setups, this is another part where a lot of foreign exchange is getting leaked because we are dependent on foreign testing setups. Class certification, IRS has just given the presentation. I call them the hidden gatekeeper. One of the fundamental roadblocks, as CSL has brought out, is when we require class certification for an equipment manufacturer who's probably supplying to a domestic industry or an auto industry, and when he realizes that he has to go to class or DGQA. The difference between class and DGQA is that DGQA is free. That's the only difference. However, the role of gatekeeping is almost similar. And this class has got a direct bearing on what a customer will finally demand, whether it is an Indian customer or a customer from Europe. So this is like an overlay which is having a cost component. Even if your quality is good enough to get a class certification, but if you are not certified, it has got a time penalty, and a shipyard would like to go to a vendor who's already having a class certification to reduce its delivery timelines. So 4 fundamental things that imports is demand, that is how much can you foresee the demand, trust, certification and policy. In marine equipment ecosystem, certification and policy are of paramount importance, and a lot of Indian vendors find it very difficult to understand this whole ecosystem and join up with shipyards and class authorities. Now, the Government of India is also trying to do ease of doing business, and the Defence Procurement Manual, which has been recently revised in 2025, gives various incentives for boosting that indigenous thing. One of the core things is that the indigenization is now looked at as a strategic imperative and not only as a commercial thing. We all know that any supply from any country can be stopped depending on the geopolitics. Earlier, there was no provision for advance payment. Now, up to 30% advance is also permitted. The LD provisions also has been relaxed. And if it is a development project, there are certain more relaxations which are there. So, if you make something or if you want something, this is the central portal which Government of India has created. You can demonstrate your product, your brochures here. And if you are a shipyard, you can see what all is available in the country. This is a common marketplace portal which has got created towards connecting the shipbuilders, shipbuilding industry, Indian Navy, and the equipment manufacturers. If you want to join up the defense ecosystem, you will have to go through a process of vendor registration. Some of you must be aware of this process. This requires submission of a certain amount of documentation. Some factory visits are there, and then you are categorized for a particular class of equipment. If you get registered, then you can be nominated by the Navy for a certain class of equipment, and then you will join up with the defense ecosystem. There are two vendor trust schemes which have been started so that you are away from us. One is called the self-certification scheme, in which if you are a MSME kind of company, you have your own quality processes, you can apply for self-certification. It's like an audit, and if you clear that audit, thereafter you will certify your own products. There is no inspection done thereafter. The higher level of this is the green channel status, where the complete trust is given to the industry. Some of the top industries have got, some of them you will hear the press briefs in the next 6 months. In this, not only the inspection is waived, you also become eligible for exports. So the government will project your company for exports. There was a limit of turnover of 500 crore per year in this scheme. Now it has been reduced to 200 crores, and many applications have come and they are being processed. So there was a negative import list, and now they are called positive indigenization lists. These lists are available. These are declared government policies where what is it that we want to indigenize. I will give you some examples. These are longer lists, but these are the things which are stated goals of the government of India of what is it that needs to be indigenized, and after a particular date, imports will be completely stopped in this. To encourage the indigenization, there are four basic schemes of the government. One is called the MAKE scheme, the IDEX, the revenue route, which was the traditional indigenization route, and the TDF, which is a joint venture with DRDO. I am not going into the details of the scheme because of the time constraint, but I'll give you some ideas of what is happening in the industry, what kind of things are getting made. These are the examples of what has already been made in the country and is now getting bulk orders. I will now conclude by giving a quote by Sridhar Vembu on nail cutters. It should be interesting to note that India imports 90% of its nail cutters from China. We are not making a nail cutter in our country to the quality which is required in a clipper of that kind of sharing and at the cost at which China is able to send it to our ports. So while we talk of Make in India and all that, let's have a look of this news article of what is happening in our own domestic industry. We are talking of getting foreign order, export orders and all that, but our Indian companies as late as February 26 are still placing orders on Chinese shipyards. I'll now end my presentation by saying that indigenization is not only for saving money, but it is also to safeguard against various global shocks which we have experienced in the last 5 years, starting from COVID pandemic to Suez Canal crisis, Russia-Ukraine war. We are all aware that how the supply chains have got affected. 100% of our gas turbines comes from Ukraine. Hormuz crisis which is going on, sanctions and the Houthi crisis which is getting built up. No supply line is secure today and no memorandum of understanding or contract is honored. In case of a geostrategic, these things can be challenged and that supply line can be closed and that item or equipment or system may not be available to India in future. That's all. Thank you very much.
Thank you, Commodore Goel, for very high quality slides and your perspective on indigenization and import. And so now I request DIG Manoj Pandey to present his thoughts.
Permission of the chair, sir. Morning, ladies and gentlemen, and my fellow panelists. First of all, I must thank the organizers for giving opportunity to the Indian Coast Guard for presenting its view as a user towards breaking import dependency. It delights me to begin the panel discussion, share my thoughts on this topic, which is a very perpetual topic and will remain so. India is moving forward with the vision of Atmanirbharta and a self-reliant, which will act as a force multiplier for global economy. This heavy statement was made by none other than the Honorable Prime Minister in UNGA 75th edition, September 2020. It made all of us think that this subject being a very whole organization's approach, everybody has to work together to break this import dependency, which all panelists have brought out very clearly and forthrightly. To give the perspective of services, including ICG, as we are the end users of all these products which are either imported or indigenously made, I would like to apprise the informed audience that before 1990, there was no separate procurement manual, and the same government procurement manual was applicable for the defense services, including ICG as well. Thereafter, the Public Accounts Committee in 1989 recommended there is a need to have a separate procurement manual. The reason being, previous to that era, there were only government-to-government imports that were being considered. So it was thought that the world will remain like as it is now at that time, and things will go very smooth. However, the situation did not remain so, and there have been geopolitical situations, disruptions of supply chain, which have been witnessed by the whole world. Therefore, the first DPP was promulgated in 1992, bringing some aspects of make, then buy Indian, etc. and etc. So we can say that breaking of import dependency started long ago. However, this has to be a gradual process and it will take some time. We see that indigenization content has been raised from a meager 30% to 50% as of today. And a lot of other aspects of IDDM concepts have been brought in, which gives impetus to all walks of stakeholders to put in their best and achieve this. So the core point here, what I want to bring in, the policies provide the foundational structure and backbone for lasting transformation by defining clear expectations and embedding new behaviors. Formal guidelines can only take the initial momentum to sustain results. Today we see that the Indian industry is eager to explore avenues offered by services and locally developed systems, bringing a great percentage of indigenization in manufacturing. Having said that, I agree with the previous panelists that there have been areas wherein we are still dependent quite a bit of import content, but that will slowly and gradually also this will phase out. Indian Coast Guard since inception in 1978 is a front runner among the proponents and receptive towards indigenized equipment to break import dependency. All classes of ships in ICG have been built in India, and the indigenous content in the last 10 to 15 years have surpassed by 10 to 15% of the mandated IC in DAP. We have always encouraged Indian shipbuilders and especially promote the local manufacturers by inducting large number of locally manufactured COTS equipment, and moreover we also encourage the private industry to build their skill on maintenance of the equipment which are of foreign origin, which gives the impetus to skill building, therefore reduce the exchequer which is otherwise going out in terms of providing the services by the foreign partners. ICG also offered platforms to DRDO DPSUs for experimental purpose, thereby contributing towards import dependency reduction. Now I come to shipbuilding as a concept. As everybody has brought out the breakdown of different compositions of a shipbuilding, primarily there are 4 definitive linkages if we can see. The first one is the upstream industries, which consist of shipbuilding material, machineries, equipment, etc. The second would be the production factors, that is labor, land, investment, etc. Valuable inputs like R&D, and finally the capital, that is the end user, be it government, defense, commercial sector. I'm talking about domestic sector. General findings have revealed, as brought out earlier, that 60 to 70% of the final output value ship production generates is through the upstream industries. So this is a very core and focused area where if we reduce the import dependency, we will be definitely gaining all what we are here for. So the more inward focused approach a country adopts, its dependency on imports will increasingly become less. Now when I say that ICG encourages Indian industry in all its ship acquisition program, it is a joint strategy with the shipyard, such as CSL, to see that the systems which are being produced domestically should be compatible with other systems which the shipyard is working on. Because that is a very important aspect, and here comes the aspect of IRS as well. So the systems which are developed by the domestic industries should be compatible with other ingredients, because the shipbuilding, what I have read in some papers is that it is integration of more than 5 lakh parts to build a ship. It may go to 10 lakhs also. So this integration is very important, and the domestic manufacturers should consider this aspect while they go for breaking the import dependency. We also encourage the standalone systems that have already been proved in the current policies of MAKE and IDEX, and we give the edge over to the manufacturers for induction of these equipment, thereby reducing the import dependency. Now, upstream industry, if we talk, it is a valuable thing to discuss that the shipbuilding material, as brought out earlier, we are now self-reliant as far as 90% shipbuilding material is concerned. I am very glad to share with the August gathering that the project of hovercraft, which is undergoing presently, has been supplied with the aluminum which is till date being imported up to a tune of 98% by an Indian manufacturer. So in the field of marine aluminum grade material also, we are gradually inching towards 100% indigenized. Talking about R&D domain, which is still catching up as a whole nation's concept, and everybody is talking about, percentage of GDP to R&D, we should increase, etc. Rightly so. But being a country of more than 140 crores of population, this percentage will, increase gradually, not at a stretch. But I am very happy to tell that in the latest facts which have been published, the private contribution towards R&D has marginally surpassed the government contribution, and this is a very healthy sign. Though it is a very marginal increase, but given the percentage of Indian GDP, that is 0.84% towards R&D, in that if the private contribution is getting bigger than the government contribution. It's a very healthy sign, and we can say that our industries have realized the need of putting the money in R&D and thereby achieving global prominence as well. There are examples of countries like China to Israel, which spend around 2 to 5% of GDP on R&D, and rightly so, because these countries have evolved long back on R&D, and we are still catching up, and this thrust by the government is only a 10-year ago concept, if we can say. Now, I come to the challenges of upstream industries because it constitutes around 60 to 80% of indigenous content, or there the break of import dependency can really come in. The main challenges, as we have all discussed, is economy of scale, low order quantity, and initial funding challenges. So what we have thought of in the Coast Guard headquarters is that we have identified 5 Ps. Now 5 Ps are policy and promotion, production and people, and partnership. To cater to indigenized upstream industries. To cater these 5 Ps, as we have listed out at the headquarters, we have developed a 3-pronged approach, wherein we make effective utilization of policies and promote the industry whenever they come up through the proposals like Make IDEX and open challenges also, to induct those items and give them a sustainable maintenance contract also, so that they can sustain their investments. Secondly, we are now toying up with the new idea of production of spares and components under Make in India by none other than those foreign OEMs who have earlier supplied the equipment to us, by having them make partnerships with the Indian competent firms. I am glad to share that a very major component of our fleet, that is water jets, we have been able to make a joint venture happen under a TOT agreement with one of the Indian firms, and they have started production in India. Production will come later, but they've started assembling, testing, FATs, etc. has also been conducted for the first time. So this partnership, so the production within India will also form the kickoff point for reducing the import dependence. Lastly, I talk about the partnerships with DRDO and DPSU, and also we have some memorandum of understanding with Codicia, as brought out by the previous panelists. They are working as a first defense industrial hub, and there is a lot of clusters of companies who are working there. Majorly they are working on automation of land-based system, but they are now gradually understanding the need to venture into marine field as well. As the previous panelist has brought out, and I am very happy to share with you, sir, that RO plant, the critical component what he has brought out, we have been able to indigenize those critical component, that is the membrane what sir has spoken about. And he is rightly in saying that till last year it was being imported. But with the efforts of DRDO and ICG, we have been able to indigenize, and it is under the trials. Most likely within a year, we would be having indigenous RO plant membranes also. So what we have done is that we have narrowed down our import list, which we are importing, and slowly and gradually we are tapping those areas with the industries which are already having some associated domain knowledge and graduating with the help of DRDO or DPSU who are working on those fields. I would like to emphasize here that MSMEs have a large role to play, and they have to be suitably compensated by the government in terms of providing easy loans and giving them some kind of tax rebate. I just toyed with an idea of giving them incentivizing them if they are engaged in export of the same item which they develop and get exchequer for the country as well. Now, in this what happens is that, first of all, they get into import substitution, then they get the class approvals and be a global standardized component so that they bring the exchequer also to the country. I'm happy to share that when I was preparing my speech for today, I chanced upon Economic Times and it gives me a heading that PLI 2.0 in the making. And PLI 2.0 in the making suggests that government is having an idea of giving compensations to these industries which produce manufacture items which goes towards import substitution. So this is another way of working towards reducing import dependence. I would just sum up and say that there are three models which we can adopt. One which Anjana Madam has spoke about, that is Fraunhofer model of Germany, wherein the local small manufacturers, they don't have to invest a very great capital in their R&D. However, such kind of institute can be instituted and the smaller players can take the higher facilities of that thing and bring out products wherein they are good at. Lastly, the role of academia like this could play a very critical role in breaking import dependency, as it acts as an engine for structural indigenization and can bridge the gap between basic R&D and commercial deployment. A triple helix model, which is used by some countries in Europe and Asia, involving the government, industry, and academia, which has been proved to be very effective. This will also take care for robust intellectual property if it is filed early and it can be adopted by production and induction by the government. A long pending issue of R&D will definitely go a long way, as the government has given some policies on TDF, etc., as brought out by Commodore Mohit also. And the graded support of industries engaged in exports of such product, which brings tax benefit as well. Lastly, as an update on use of indigenous systems and equipment towards reducing import dependence in ongoing ICG acquisitions, I flash few slides here, which will give you the equipment which we have used indigenously in the projects. You can play this from here. Just play. That's all. It will automatically. Indigenization Day2. Thank you so much.
Thank you, DIG Manoj Pandey. Thank you very much for presenting the perspectives of Coast Guard. So what we see is that this forum has brought all the four stakeholders together who are independently and individually doing so much towards Make in India. So we have some time, we have 5 to 6 minutes. We can have some questions from the delegates. So any questions? You can specify the name of the, to the person you are directing the question.
Yeah, I'm Rear Admiral Menon. My question first is to CSL, that you have taken good initiative with respect to getting indigenous vendors on board for a certain set of equipment. My basic question is, are all the shipyards involved in this? Because again, otherwise what happens is all your efforts is going to be repeated by other shipyards. So the bigger shipyards should take the lead, be on a collaborative, make a collaborative effort in terms of indigenization with the involvement of the class. Only this will benefit in terms of getting numbers for the vendor who's doing the development. Otherwise, CSL will go to one vendor, MDL will go to another vendor, another shipyard goes to a third vendor. You don't have the numbers for him to do, to make quantities in large number. And if you don't give him that sort of a visibility with numbers, I don't think he will put any effort in R&D. So I just wanted to understand if it's a collaborative effort of all the shipyards, or if not till now, can we get into a collaborative effort of all shipyards getting into it? Second point, I'll just add one more question is for Commodore Mohit Goel. While you have shown what is happening on the indigenization, my suggestion would be to you that whenever any vendor supplies, first and foremost, the government accepts that indigenization does not mean 100% indigenous. There is a certain amount of material or certain components which you may need to import. But can it happen that whenever anybody supplies an equipment, you get a certificate from him very clearly indicating what are the imported components in this, and then monitor his subsequent supplies to see if there is a gradual reduction in the import component? Thank you.
Sir, to the first part of your question, yes, we had an interaction with all the other different shipyards also, because we were primarily focusing on the pumps and valves, where we have really felt the pinch, because there were very few manufacturers in India. There are manufacturers in India, but all the shipyards were going to these manufacturers, and there was a real delay in the supply chain. So we have been collaborating, we've been discussion with the shipyards also, and when we conducted the marine valve and the pump conclave, the shipyards were also invited. So we are part, and they are also part of the indigenization committee by the ministry. So I think all of us are going through this together.
Sir, regarding the indigenous and import component in indigenous equipment, that list is known. It is very accurately defined. However, today the issue is there is no incentive for an Indian manufacturer to start taking up the indigenization of those components once he is nominated by the organization. But your suggestion is very valuable, sir, that if we insist that over a period of time, that also needs to be indigenized, it will lead us towards higher level of indigenous content.
I'm Mahesh from ABB. My question is, DGMA yesterday shared the ambitious plan, to go up to 430 plus vessels. And if you look at the first few tenders which are coming in, we see all shipyards are dependent mostly with the technology or design support from Koreans. So what we see is, who is going to address, we see some of the Indian designers and even OEMs, equipment manufacturers, don't get a chance to participate in it, because then the designers come with their own equipments. So you're not only losing the opportunity for the design, but also the equipment supply. I'm not sure whether you will be able to address that. Maybe I just wanted to use this forum to convey this to the decision makers.
While closing the session, I'll try to address.
Okay, thank you.
Because after that, we have to stick to time also.
Sir, I'm Commander Sunil from Gardenry Shipyard. So I have 2 points to submit here. One is about the speakers have all brought out about the indigenization part. So what I'm trying to bring it out is that the long-term procurement visibility means it's like, we are all aware that there are certain plans already fixed. When I'm saying that acquisition plans, naval acquisition plans. Similarly, commercial sector also, there are certain plans are there. If we have these plans made for 10 to 20, 15, 20, 25 years from now, and these plans are to be go in depth to all the domestic firms. When I'm saying domestic firms means it can be the industry partners, OEMs and all, so that they have clear indication how much they can invest, so that they can also gain by virtue of doing the indigenization part. So what happens now is that they are getting a small benefits for some 2-3 years, some sort of vessels, and they go for a shorter routes by virtue of taking from outside India. This is one point, sir. The second one, I would like to take lead from what Commodore Goyal has brought out. So as on date, the DMR steel, when I'm talking about the steel, which is around some 80,000 per ton, and whereas the lower grade AH36, which you use it for many of the commercial vessels, it is around some 70,000 per ton. Where AH36 it exactly has a lot of raw materials which are to be sourced from outside. Now we need to bridge a gap between these two. Maybe that can be exploited and utilized for all the ships which are being built in India, excluding, there are some exceptions which we are going for the import vessels. We can bridge it. Else we can look for some government policy exactly in this particular point, so that though we are going for a higher steel, but we can do it the cost cutting thing exactly in this particular, and I think we can reap some benefits from these two things, sir. Thank you very much.
Okay, thank you all the panelists for presenting their mind and good questions. Sorry, we couldn't take some of the questions, but I'll try to see if everything is covered. So first of all, this topic is very relevant for the strategists who are sitting in the front and for the students who are sitting at the back. So next 50 years belongs to them, and we have to plan for them in next 5 to 10 years. So when we are talking about this particular topic, we have to think of three aspects. One is, where do we come from? What is the history? Where do we stand? What is the present status? And how do we look at the future? So history is, we started very well post-independence. We had MDL, HSL, GRSE. Enough ship owners were there, ship owning companies were there. Very good industrial setup was there in Calcutta and Kolkata now and Mumbai. That was the age of the boilers. Then there was high confidence in 1950s. We had the Atomic Energy Commission, early 50s, BEL, Bharat Electronics. Corps of Constructors was formed in Indian Navy in 1956, where the naval visionaries that time decided to go for indigenous shipbuilding, ship design and construction. DGQA was reorganized in 1957, and in 1958, DRDO was formed. So 60s were again good. ISRO came up, BHEL, Engineers India Limited. Engineers India Limited is a pioneer in offshore oil and gas. BEML came up. Navy formed the Central Design Office, which is now known as the Warship Design Bureau. Goa Shipyard Limited was acquired by MDL in 1961, and Leander project started. 70s continued. Steel Authority came up that time. Cochin Shipyard came up. Indian Register of Shipping. Around that time, we moved from steam to diesel. So we were also doing a lot of oil platforms during those times. Oil platforms, warships. Then came 80s and 90s. The construction was going on. I still remember in 1995, we had visited some of the shipyards in the country. Some work was going on for commercial shipbuilding, naval shipbuilding, oil platforms also. But shipbuilding had not picked up in a big way that time. So we all also moved around that time from diesel to gas turbines. So after opening of economy in 90s, so all our ship owners started looking outwards. So whatever was happening within the country also started going down. Also, of course, there were other reasons why our shipbuilding did not pick up that time. So although in 2000s, the government gave impetus with some subsidy, some new shipyards were formed, ABG, Pipavav, L&T, Bharti Shipyard. But the effort failed because overall global shipbuilding went down. But our industrial base, what we are talking about, equipment, auxiliary industry, still came up. In Tamil Nadu it came up in Gujarat. But during this lean period also, the Navy and the Coast Guard maintained the tempo. Today, Navy has indigenized up to 75 to 80% in a ship. So where do we stand now? So this is the history. Where do we stand now? So today we have already built a 45,000 ton aircraft carrier in our own shipyard, Cochin shipyard. Very complex ship, and it has been integrated into the Indian Navy within 1 year, which is a record time anywhere in the world. So for us to have that capability to build a ship, that complex ship, is quite a remarkable thing. I call it the 1983 moment in Indian shipbuilding, when we realized we can make ships. In 83, we had realized that we can win World Cup. So that is how it is. So we have also realized that enough ship design and construction knowledge has been retained in the country. We have also realized that shipbuilding gives the GDP a multiplier effect of 1.8 and employment a multiplier effect of 7. Every 1 job in shipyard gives 7 jobs outside. We have also realized the importance of the sea in the ongoing conflicts which are going on. We have also realized that sea gives us clear connectivity with 50 plus countries, whereas through land we are connected with barriers with around 7 to 8 countries only. We have also realized that we have a glorious maritime past. Government is promoting shipbuilding with complete focus. Greenfield shipyards are coming up. Indigenous orders are coming. We spoke about 437 commercial ships order which is in the pipeline. Navy is already there with 2.5 lakh crore worth of orders for our shipbuilders. Manpower is getting aligned. We spoke about training of manpower. So a lot of shipyards have started internship programs. In Warship Design Bureau also we have started internship program. We have already finished one set of internships recently. Now the world is moving from gas turbine to now electric, green ship, autonomous. So we have to look in that direction. We have also realized from the presentation given by DIG Manoj that DRDO has already done so much of work within the country. DRDO has already given so much of TOT. What is now required is, although a lot of work has been done for Navy and the Coast Guard, the technology has to be moved towards the commercial ships. So how's the future? I think the future is very bright. We need to remain focused and patient, which was also brought out by some of the speakers. Madhu sir has already told in one of his speeches, we have to look at 5 years. But I think 5 years, up to 10 years, we just have to continue. And like I said, next 50 years belongs to the people sitting at the back. So we have to look at indigenous design initially and then slowly move towards exports. Make in India has to remain the theme and then make for the world. Now, a lot of questions came up on vendor management and those kind of things, technology, import balance and all that. I think shipyards have to look for long-term partnerships. Some questions were asked. I think that is the only way ahead. Shipyards have to tie up with designers so that the designers know that there's a long-term business. They have to tie up with the vendors so that the OEMs know there is a long-term business. They have to tie up with classification societies so that they know there is a long-term business. They have to also tie up with other shipyards so that there is a conglomerate which is formed and they look at a long-term business. Then there is enough business which is coming, indigenous I'm saying. Enough organizations. Navy is there, Coast Guard is there, Army is there. Army has got maritime interests. Border Security Force is there, Customs is there, NDRF. During floods, you need maritime support. We can think of concepts like hovercrafts during floods. You don't know the depths. You can operate those. So, then there is business opportunity in sports, in tourism, underwater tourism. There is business opportunity in undersea resources which are there. So enough business which is available. Now also, I think while we are doing all this, we have to think about our MSMEs. This was also brought out by DIG Manoj. MSMEs are products of passion of that individual who has worked for last 40 to 50 years and created that setup. How does it go to the next generation? It's a national knowledge which is there. How it is retained, what is the second line of succession? Although it is left to the individual, but as an ecosystem, we have to think about it. So, like I said, we have to look at next 10 years minimum, so that how things develop, we have to continuously focus, continuously engage, and continuously do things. With that, I think I would like to thank the organizers for conducting the session and for all the panelists for presenting the thoughts and all the listeners who have been patient. Thank you very much.
Thank you to our chair and panelists. We will now proceed with the presentation of mementos. May I request our session chair, Rear Admiral Sujit Bakshi, Director General, Warship Design Bureau, to kindly present mementos to our distinguished panelists as a token of appreciation. I shall now invite each of our distinguished panelists to receive the mementos as I announce their names. Commodore Mohit Goel, NM, Chief Quality Assurance Officer, Marine Systems, Indian Navy. DIG Manoj Pandey, Superintendent Coast Guard Refit and Production Team, Goa, Indian Coast Guard. Mr. H.V. Ramesh, Head of Technical and Chief Surveyor, Indian Register of Shipping. Ms. Anjana KR, Chief General Manager, Design and Material, Cochin Shipyard Limited. Thank you. May I now request Rear Admiral Nirmal Menon, Indian Navy retired, to kindly present a memento to our session chair, Rear Admiral Sujit Bakshi, Director General, Warship Design Bureau, as a token of our appreciation. Ladies and gentlemen, please join me in giving our chair and distinguished panelists a warm round of applause. Kindly request everyone to please come forward for a group photograph. Thank you once again to our session chair and distinguished panelists. Our platinum sponsor Aviva has set up an experience center right outside the hall. I expect all delegates to visit it. We will now take a short break for tea and networking. Following the break, we will reconvene at 11:45 a.m. for our first technical paper presentation session powered by Mazagon Dock Shipbuilders Limited, one of our valued gold sponsors. This session will focus on computational techniques in naval engineering, showcasing the latest advances in computational methods, simulation and numerical analysis. Thank you and enjoy your tea break.
With the motto of providing unrivaled environment to exchange information, interesting topics have been lined up for this year's conference, some of which include renewable energy, technical innovations in shipbuilding and marine engineering, marine heavy lift and transport, marine operations and safety, and many more. Bringing together the global market leaders under a single roof, Mastic invites you to become a part of this prestigious event where industry comes together to learn and grow together.
New sustainability regulations from the International Maritime Organization signal massive changes ahead for shipbuilders. Whether you're designing new ships or retrofitting an existing fleet, your next voyage is digital. Digital transformation means you can navigate IMO 2050 regulations while improving your engineering efficiency by up to 30%. You can cut the time it takes to model a retrofit by as much as 20%. And design digital twins to guide you in building safer, more efficient, more sustainable operations at sea. Digital transformation ahoy! Aviva, we'll take you there.
Namaskaram from Singapore. On behalf of SAFE Economy Far East, I sincerely express my wishes to Dostas for conducting this event. I hope this event will help the industry professionals, leaders, and alumni across the world.
Greetings to everyone attending DIMS 2026. With the motto of providing unrivaled environment to exchange information, interesting topics have been lined up for this year's conference, some of which include renewable energy, technical innovations in shipbuilding and marine engineering, marine heavy lift and transport, marine operations and safety, and many more. Bringing together the global market leaders under a single roof, Mastic invites you to become a part of this prestigious event where industry comes together to learn and grow together.
New sustainability regulations from the International Maritime Organization signal massive changes ahead for shipbuilders. Whether you're designing new ships or retrofitting an existing fleet, your next voyage is digital. Digital transformation means you can navigate IMO 2050 regulations while improving your engineering efficiency by up to 30%. You can cut the time it takes to model a retrofit by as much as 20%. And design digital twins to guide you in building safer, more efficient, more sustainable operations at sea. Digital transformation ahoy! Aviva, we'll take you there.
Namaskaram from Singapore. On behalf of Safe Economy Far East, I sincerely express my wishes to Dostas for conducting this event. I hope this event will help the industry professionals, leaders, and alumni across the world.
Greetings to everyone attending DIMS 2026. SAFE is a strong connection between ShipTech alumni across the region and generation. And DIMS provide an excellent platform for sharing knowledge, strengthening the friendship, and building new opportunities for collaboration.
Hello all. From the build-up, the program, and the enthusiasm, DIMS 2026 promises to be the best of its versions yet. We are all waiting for a slam dunk.
No matter where our career takes us across the world, we will always remain connected through our shared ShipTech roots, friendship, and values. From Singapore, we are proud to be part of this global alumni family and wish every participant an inspiring, rewarding, and memorable DIMS 2026.
Innovation is changing how we design, build, and operate ships. DIMS is where we come together to explore the ideas shaping the future of the maritime and offshore industry.
Congratulations, Dostas,
for engaging discussions,
inspiring innovations,
and lasting partnerships.
Best wishes to DIMS 2026. Polikita.
Have you noticed? India's maritime industry is changing faster than ever.
It has to. With Maritime Amrut Vision 2047, India is aiming to become a global leader in shipbuilding, marine technology, and the blue economy.
But ships, ports, and technology don't build themselves.
They need the next generation of engineers, innovators, and leaders.
And that's exactly why Anchorage has been reimagined from a cultural fest to a techno-cultural fest, connecting students with the future of maritime industry.
Experience the IMO chamber, understand how policies and regulations are made, lead the discussion in the captain's table, CEO edition, and explore the innovation hub featuring AI, machine learning, Python, CAT, ANSYS, VR, and more.
Explore the Indian Navy and Maritime Expo with powerful insights from distinguished guests and our proud alumni.
Compete in boat tours, ship model challenges, paper presentations, quiz, Shark Tank, and treasure hunt.
Experience mentalism, expert sessions, photography contests, and film screening, and edit all with a spectacular pro show.
Whether you're here to innovate
or to compete,
see you at Anchorage 26, happening on October 10, 11, and 12.
Hello, this is Naufal here from the 20th batch of QSAT, belonging to the UK arm of Dostas. And I want to wish all the organizers and the participants a fantastic event with DIMS 2026. I think this will go a long way in promoting our community, our experiences, and our journey in shared knowledge across. So, wish you all the best and all support from the UK alumni. Thank you.
I wish all the delegates, the speakers, and the organizers all the very best for DIMS 2026.
To all the delegates and speakers for sharing your knowledge and experiences, and wishing everyone a very successful, exciting, and insightful event ahead.
It's wonderful to see experts from all over the globe coming together to navigate the challenges and opportunities in naval architecture and ocean engineering. May the sessions lead to valuable insights, strong international partnerships, and pioneering innovations. Hats off to the organizers.
I wish all the very best to DIMS and look forward to the innovative ideas that will come out.
This is one of the most important events. As a maritime professional, I look forward to.
It is a privilege to attend this function.
The first day was a huge success.
I really want all of you to come for next day.
Modern warships and submarines are engineering marvels. Shaping them demands mastery of engineering and a vision that goes beyond the horizon. Mazagon Dock Shipbuilders Limited, a Navratna DPSU, and India's only shipyard to have built destroyers, submarines and frigates. Spread over 75 acres, our state-of-the-art infrastructure enables the concurrent construction of 10 warships and 11 submarines. It all began here, in the historic Mazagon Dry Dock. Indian craftsmen built ships of Malabar teak that sailed the oceans of the world. In 1960, Mazagon Docks became a public sector undertaking under the Ministry of Defence, charting a course that would make us shipbuilders to the nation. First of the blocks was Nilgiri, India's first indigenous capital warship. Since then, we have delivered over 808 vessels, including 33 men of war. From missile boats to 7,000-ton destroyers. Every platform begins its journey in our VR-enabled design center. Integrated construction at our dedicated module shop enhances efficiency, compressing timelines. Every build is validated through rigorous harbor and sea trials. Our flagship programs, the Project 15 Bravo destroyers, Project 75 submarines, and Project 17 Alpha stealth frigates, demonstrate our ability to integrate complex and diverse systems and reflect the skill, expertise, and commitment of our 6,000-strong workforce.
Ladies and gentlemen, may I have your kind attention, please? We will be resuming the program in 5 minutes. May I kindly request everyone to make their way back to Oman Hall and take their seats as we prepare to commence our first technical paper presentation session. We would also like to take this opportunity to once again acknowledge the generous support of our sponsors. Our platinum sponsor Aviva, our gold sponsors Mazagon Dock Shipbuilders Limited and Dassault Systems, our silver sponsors Cadmatic and Chowgle Shipbuilding Division. We sincerely thank all our sponsors for their continued support in making DIMS 2026 possible. Thank you.
Always been essential to our world's prosperity. But if we are to realize the full potential of the ocean economy, we need to rethink a more responsible and sustainable path. We need better, safer, greener assets. From smarter ships designed with high-performance hulls, new materials, and alternative propulsion systems, to offshore assets capable of harnessing new energy and natural resources. It is time to transform the marine and offshore industry. Innovating new business models and processes, leveraging advanced simulation, analytics, smart automated manufacturing, standardization and modularity, bringing operational excellence throughout an asset's entire life cycle with digital continuity. By enhancing the real world with the virtual world, Dassault Systèmes 3D Experience Platform unleashes a new wave of innovation, empowering the next generation workforce with deep knowledge. From ideation and engineering to manufacturing and asset in operation, the entire value network is connected into a single collaborative environment, unlocking the true value of our oceans by harmonizing product, nature, and life. In a future made possible by virtual universes, experience the future today.
Ladies and gentlemen, may I have your kind attention please? We will be commencing the program in a couple of minutes. I request everyone to be back. Thank you. Ladies and gentlemen, since we are about to begin the program, I request all the delegates sitting behind to please come forward and fill the vacant chairs. Welcome back, ladies and gentlemen. We now begin our first technical paper presentation. Computation Techniques in Naval Engineering, proudly powered by Mazagon Dock Shipbuilders Limited, one of our valued gold sponsors. This session brings together researchers, industry experts to present innovative work in computational methods, simulation, and numerical analysis, highlighting the technologies shaping the future of naval engineering. To moderate this session, it is my pleasure to invite Dr. P. Krishnankuti, Professor retired, IIT Madras, a distinguished academic and researcher whose contributions to naval architecture and ocean engineering have inspired generations of maritime professionals. Ladies and gentlemen, please welcome Dr. P. Krishnankuti. Welcome, sir. May I now invite Mr. Andre Pozzo, Product Owner, Napa, who leads product development in hull form and hydrodynamics and brings nearly 2 decades of experience in ship design, stability, hydrodynamics, and digital engineering solutions for the maritime industry. Welcome, sir. Next, may I invite Mr. Saurabh Bardwaj, Technical Account Manager, Catmatic India, who works closely with shipyards and engineering organizations in advancing integrated design and digital twin technologies to enhance collaboration and efficiency in shipbuilding. Welcome, sir. Finally, may I invite Lieutenant Gaurav Tehlan, Indian Navy, who is an alumnus of CUSAT, specializing in advanced warship design and non-conventional marine vehicles. Welcome, sir. Ladies and gentlemen, please join me in welcoming our moderator and presenters with a warm round of applause. I now have the pleasure of handing over the session to Dr. P. Krishnankuti. Sir, the session is yours.
Yeah, good morning to all of you. If people in the audience is very less, I hope it will build up over the time. And we are going to start a technical session. I think this is the first of the kind here, session 1. And actually, it's planned to have 4 presentations in this session, but unfortunately, one is absent. So we'll have 3 presentations, of which 2 or more onto the, the major softwares, Napa and Catmatic, more onto the various aspects of ship design and helping in fabrication and maybe also in the operation. They have softwares and they may be covering these various features of the softwares. And we also have another presentation on the basically naval application on the identification of underwater vehicles from the hydrodynamic signatures. That is looking to the Bernoulli hump of the body, underwater body moving just below the surface, looking to the characteristics of this hydrodynamics, one would be able to identify the vessel. These are the things which are going to be covered in this session. And so we are running late, and so what I suggest is maybe we can restrict the presentation to 15 minutes, okay? And so we give more time for the discussion subsequent to that. Hope to get more response from the audience, maybe more inquisitive about knowing about the various features of the softwares in these applications, and also the work done on the identification of bodies, underwater bodies from its hydrodynamic signatures. So with that, we'll open the session, and I call upon the first presenter here, Mr. Andre Pozzo from Napa, who will be talking on voyage optimization for ship design. So we look forward to your presentation. Thank you.
Okay. I hope everyone hears me now. First of all, let me thank the organization, Dostas organization, giving me a possibility to give my presentation among the giants of the Indian naval architecture and ship design and marine industry. Thank you. And as the title says, it's about the voice optimization for ship design from calm to storm. And I hope that the subtitle will make more sense after my presentations. First, let me introduce myself. My name is Antti Pösö. I am a product owner for the hull form and hydrodynamics development team at Napa. My background is in naval architecture, not in a software development originally. So I worked with Napa more than 10 years in my daily work. Then, roughly around 8 years ago, I joined Napa first as a software developer and later became the product owner for the team. As mentioned, this is about the voice optimization for the ship design. And some of you might already know that Napa has been offering for the voice optimization for the ship owners, operators, and charterers already for the years. We have been hearing from the ship owners more and more that there is an interest more towards the actual sea conditions rather than the sea trial results, as the sea trials might not predict well how the ship will perform in actual sea conditions. So this is something that we are now developing, and we call it as an operational simulation, to giving the same tools that the ship owners are using to naval architects and ship engineers. Unlike the ship owners who have existing ships that gathers data roughly around every second, and we can fine-tune the ship, the performance models to predict how the ship will perform in a real sea. This is not available for the naval architects or the ship designers. So instead, what we have is to have need to give is the opportunity for them to create their own performance models using the best knowledge that they have. The performance model itself, it is based on the hull form that can be developed within the Napa or coming from some external software. In the beginning and early stages, we can have estimations of the ship's resistance using the empirical methods, hull drop 84, or what is needed. Later on, there will be the CFD results that can replace the rough estimations, model tests, and even the sea trial test for the calm water resistance. Same thing, we need the wave-added resistance to get more realistic estimations how the ship will perform when they are sailing and we are simulating. We also need then to understand what are the rudder's lift and drag coefficients for more predictable and understandable maneuverability, as well as to understand what is the added resistance coming from maneuvers, as well as the wind coefficients of the ship to understand how the winds will affect its performance. After we have the performance model created, what is needed then is, of course, to model what is the route where the ship will be operating. For the ferries and ropaxes that have the fixed route, it's quite easy to know what are the ports that it's traveling. And this can be easily modeled. Whereas if you are designing the bulk carrier that operates all around the world, it might be impossible for the designers to actually know what is the operational profiles. Napa has been recording the AIS data over 7 years now, almost the whole world fleet that is available. This will be giving the possibility for the ship designers to utilize AIS data to get the realistic routes for their design, and then can utilize this for estimating. Other part, unlike then the ship owners and operators who are more interested on the next voyage, ship designers need to have more understanding and more broad view. So what we can do is then to simulate either longer period for years, or we can then utilize, for example, seasons. So what is then the weather conditions in spring, summer, autumn, or in winter in the area. as well as the frequency of simulations. It's all depending what stage this design is at that moment, how often you need, and how much data you need. In this example, we are modeling then the route from Cochin to Mumbai for my colleague Manos to get back home. As you can see, we can start creating just by telling what are the port names, and what happens then is that the operational simulation will find what is the shortest route between. By estimation, if we go with the 7 meters a second, so roughly 14 knots, the route will take 2 days to travel. After the modeling the route, typically the shortest route is not the best route for the ships, because there is winds, there's waves, so environment affects. So we can decide what is the interesting part for our simulations, whether we set the constant speed for the ship, or we set up the MCR to be constant, or the RPM. These are then used then to find what is the optimal route for the ship to travel, taking account the weather conditions, wind waves, swell, wind, and sea currents. So when we click calculate voyages, the NAPA start simulating the routes. And the most important features that we have developed is the small ship there traveling along the route that you can see while you are waiting for the results. And as you can see, the result starts coming within a few seconds. So in total, in this case, we are simulating 16 voyages, and the time it takes is less than 1 minute. And as you can see, each route that has been optimized, they have quite a lot of variance depending on the weather. The next step, when the simulations are done, this is not the end. We need data, and the data is collected. As you can see, the table and the amount of data that we do get is massive. It can be tens of thousands of lines. Time-stamped winds, waves, all the environmental conditions the ship was facing during that time. In addition, what is the at-time speed of the ship? What is the needed MCR for the ship to operate? But it's quite hard to understand what is going on just from the data. So we are also developing tools to visualize them and give the better understanding what is going on with the ship. So just as a few examples here, we can see what was the power distribution on the left in a histogram. Well, most of the time in this case it was around 80%, but we can also see that quite often the maximum power of the engine was exceeded. On the right side, there is the rows about the waves that the ship has faced during its voyages, as well as the NAPA's second generation index stability calculation can be used to estimate how often the ship will be actually facing the condition where it is subject for the parametric rolling. So where this then fits in the actual design. Now you've seen what we can do, and if you think about the traditional process, energy efficiency design index is typically done for the design speed and then for the design draft. This doesn't typically translate well for the ship owners' considerations, for example, carbon intensity indicator values. Powering curves are typically estimated in the calm water. So no wind in laden and ballast conditions typically are only things that the ship designers are taking care of. In addition, we have seen that the realistic ship profiles, how they perform, are hard to gather for the naval architects. Weather data is there, AIS data exists, but it is breaking. It's distributed all over. It's not always easy to use straight away. Some of our customers have been doing this as well, but they have quickly noticed that it is a heavy burden for the naval architects to just gather data and mangle it to be usable. In addition to traditional ship design, typically gives a little or to no insight of the lifetime of the fuel consumptions or the ship emissions or operational costs. Of course, we cannot replace the rules and regulations, so all of these will stay, but we do see the benefit of the operational simulation and what it adds to actual ship design process. This gives the opportunity for the naval architects to start looking already the ship owner concerns, as mentioned multiple times already, CII, IMO Net Zero, IMO GFI, EU ETS. These are all problems that are affecting ship owners heavily. A few years back when I was talking with the shipyards and asking about the CII, the reply was that it's a ship owner concern, not the design concern. But what we are hearing more and more is that this is something that the ship owners want from the designers, so they can actually understand how the ship will perform. We have two cases after this. One is the parametric rolling. The second one is about the fuel consumption, and especially how the energy saving devices will affect the energy consumptions and how to estimate those. So one more slide about how this goes. So typical process, how we see it goes to the design process, is that the naval architects and designers develop their ship with the best knowledge they have at the moment. This knowledge is then used to create the performance model, modeling the routes and operations, running the simulation, analyzing the results, and making changes to design. And then the loop starts again. As you know, typical ship design process, it is an iterative process, and we do the same things multiple times with a better understanding and better knowledge we have. So, going for the first case, Chrysler container ship regarding the parametric rolling. What we did is that we modeled the route from Korea, Busan to Los Angeles, US. In total, we did the 20 weather-optimized voyages in 10-day interval, going back and forth. So in a sense, we had the 40 different voyages done. In total, we found out that the 40.4 megawatts was needed MCR, which is a little bit high, but this can be still is still in the range of that ship size. Average engine load was 80.9%, and average combined wave was 2.1 meter. Average combined wave in this case means that it combines the wind waves as well as the swell. But when we start looking more about the data, we can see that most of the time ship was considering the starboard side or the little bit in the forward starboard side waves. But still, the waves weren't that big, and only 4.0% of the time the ship was sailing in the conditions where the parametric rolling could have happened, or this design would have been sailed, not the ship itself. But we can see also that the maximum roller amplitude that was estimated is already at 17.6. So this gives also importance for the safety of the crew to understand how to operate in the conditions where the parametric rolling can happen. But anyway, I think that this design would have been suitable for this route based on this data. Then the second case, especially the wind assistant propulsion. And this is the place where I see maybe the most benefit in these kind of tools, because you cannot estimate the effect of the energy saving devices without understanding what are the conditions where the ship is sailing. Similar thing, we modeled the route from Port Hedland, Australia to Pohang, Korea. Typical iron ore route. Then we did 4 different simulations. One of the shortest route without the sails and with the sails. One with the weather optimized route and one with the weather optimized together with the sails. So in total, 80 simulations done, and each case took from 1 to 10 minutes. So we can say less than half an hour the designer would have understanding, does the sails make sense in the specific route? As you can see, having only the rotor sails, we estimated only 2.4% energy saving. Having the weather routing only would actually give more savings for the ship, but adding the rotors as well, we can find out that the design would actually have performed 7.3% better than the ship without the sails. So, as a takeout, a few minutes short, but as a takeaway, we see that there is a need and demand in the future about the ship designers, naval architects to be able to actually simulate the voyages of their design for selecting the proper engine, making the tank sizing, and especially in the future with the alternative fuels that has less energy density as the heavy fuel oil at the moment. Compliance can be then predicted rather than declared. Energy efficiency design index will still be there, but ship designers can answer for the ship owner problems in early design stages rather than the ship is existing. Energy saving devices can be designed and selected to actual how the ship is operated. Of course, the foundation will stay. There's no way that the class rules would be taken over, and on CFD and model testing will be still there. We do add and develop tools for ship designers to take the next step that is needed for the future. So, if you found my presentation interesting, I will be here for the rest of the seminar. Please come and talk. And in cases you don't have time or we don't have time this seminar, feel free to contact me at any time. I'm more than happy to talk more about this, as well as my colleague Manoj is here. Thank you.
Thank you. Thank you for the nice presentation and just keeping to the time. Thank you. So we'll take the questions at the end of all the presentations. At the end of the presentations, we'll take the questions. Okay, you can have your seat, please. Okay, we take all the questions, the discussion part only at the end of all the presentations. And so we move on with the next presentation from Mr. Saurabh Bharadwaj from Cadmatic, who will be, please, talking on the revolutionizing the industry with Cadmatic's integrated design, PLM, and digital twin technologies. Thank you.
So, good afternoon, everyone. A very warm welcome to all of you, and thank you for joining this session at DEAMS 2026. It's a privilege for Cadmatic to be here for the third consecutive years as a silver sponsor. My name is Saurabh Bharadwaj, and I work as a technical account manager at Cadmatic. Today, I would like to share how the maritime industry is evolving and the technology that are driving this transformation, and how they support India's vision of becoming a global shipyard hub. Let's begin by looking at the bigger national picture. India is at a very exciting stage in its maritime journey. We are no longer talking about being just a maritime nation. We are talking about becoming a global shipbuilding leader. Government initiatives such as Maritime India Vision 2030 and Maritime Vision 2047 provide a clear roadmap for this transformation. These are supported by initiatives like Make in India, Atmanirbhar Bharat, green shipping policies, and National Hydrogen Mission. But all these ambitions have one common requirement: a strong digital backbone. Without digital engineering, connected data, and integrated workflow, achieving these goals become extremely difficult. Why this vision is so important? Because maritime is already the backbone of India's economy. Approximately 95% of India's trade by volume moves through the sea. The government has planned investments of approximately 3 to 3.5 lakh crore under Maritime India Vision. And India also aims to move from 16th position today to among the top 5 shipbuilding nations by 2047. Along with this, around 10 world-class shipyards are planning through public-private partnerships. So the ambition is real, the funding is real. Now the challenge is making sure how engineering and production capabilities grow at the same speed. Let's see the challenges. Today, challenges is no longer simply design larger ships. The biggest challenge is managing information. Many shipyards still work with fragmented data. Engineering, procurement, and production often operates in separate systems. Information is duplicated. Design change arrive late. Team loses visibility. This leads to delay, rework, and higher cost. That's why we always say building bigger shipyard isn't enough. We need smarter shipyards because we cannot achieve 2047 vision using workflows designed 30 years ago. So what these trends that nowadays is emerging. So what does a smarter shipyard look like? The answer is digital first engineering. The first trend is model-based design, where one intelligent 3D model replaces hundreds of disconnected drawings. Second is integrated PLM, connecting engineering, procurement, production, and lifecycle informations. Third is the digital twin, providing real-time visibility throughout the vessel's life. And finally, artificial intelligence, helping engineers automate repetitive tasks, improving clash detections, and accelerate design reviews. These technologies together create one continuous digital thread. This is exactly where Cadmatic is different. Many companies provide excellent individual solutions. Some focus on CAD, some focus on PLM, other focus on digital twins. Cadmatic connects all of them. We provide one continuous digital thread from design to workflow to PLM, all one platform. And this platform supports surface ships, submarines, and offshore assets. Today, over 6,000 organizations across more than 60 countries trust Cadmatic. Let's walk through this digital thread. It's all start with the digital and design technology. Every engineering discipline works on the same shared 3D model. Hull, outfitting, HVAC, electrical, PNID, everyone works for the same source of truth. The result is better collaboration, fewer clashes, and faster engineering. The next stage is Cadmatic Wave. So Wave connects the complete life cycle of shipbuilding, starting from design, move into planning, prefabrication, fabrications, assembly, and finally operations and retrofit. Everything is built on the same digital model. As the model grows, planning becomes richer and more accurate. You will also notice technologies like virtual reality, augmented reality, and mixed reality supporting production activities. Please scan the QR code to explore the complete case studies. So right away, you can scan this QR code to get where the unified foundation for unified shipyard operations we already have implemented, and they are successfully leveraging these policies on Cadmatic Waves. So what the Cadmatic Waves and eShare combinedly can do? Different people experience this platform differently. A head of design gains visibility over complex project. Naval architect works confidently from one trusted model. Production planner always know what is ready to build. IT team maintains secure and scalable systems. PLM manager ensures consistent product data throughout the life cycle. Different role, one platform, one source of truth. Now let's move beyond engineering. This is Schematic eShare, our digital twin solution. It brings engineering information directly to production team and vessel operators. One major advantage is that it works offline. Even deep inside a ship where network connectivity is unavailable. It's a browser-based, easy to learn, easy to deploy. One great example is Meyer Raft, where they successfully transformed their workflow from paper to tablet, improving efficiencies across the shipyard. So you can scan this QR code and you can see this, how they have leveraged Schematic eShare for paperless technology. Another strength of Schematic is flexibility. The same platform supports every vessel category: commercial ships, naval vessels, submarines, offshore platforms, offshore support vessels. Instead of maintaining multiple disconnected engineering environments, organizations work with consistent platform across every project. Now look at the future. Artificial intelligence is becoming a practical engineering assistance. At Schematic, we say, stop searching, start asking. Our AI automatically recognizes equipment tags for point clouds. It can answer engineering questions directly within documentations. Our hull solution can generate bracket design from sketches or text prompts. And in electrical, AI helps maintain an accurate equipment database. Very soon, AI will also recognize tags from legacy engineering documents. AI isn't replacing engineers. It's allowing engineers to spend more time solving problems instead of searching of information. So why do shipyards choose Schematic? Because we are focused entirely on shipbuilding and naval engineering. We combine global experience with strong local support. Our industry specialists work closely with customers to solve real engineering challenges. And whether you are a small yard or one of the world's largest shipbuilders, the platform grows with your business. Let me finish with one thought. India has an incredible opportunity to become one of the world's leading shipbuilding nations. But success won't come simply by building more ships. It will come by building smarter ships and using smarter shipyards, powered by connected digital technologies. I would like to thank you, all of you, for your time today. If you would like to see this solution in action, please visit the Schematic booth after the session. My colleagues and I will be helping to answer your questions. Thank you very much.
Thank you, Mr. Bharadwaj. Okay, and we move on with the third and last presentation of this session. That is going to be on non-acoustic detection of submerged bodies using hydrodynamic signatures, experimental characterization of the Bernoulli hump. So I call upon the author of the paper is unfortunately not able to come and present it. So the responsibility has been handed over to Lieutenant Gaurav Teglan. Please come over and so, yeah, please.
Good afternoon to one and all present here. I am Lieutenant Gaurav, standing before you to present the experimental work which is carried out by Lieutenant Kodikal Arvind as part of his minor project in IIT Delhi. He is currently undergoing a PG diploma course in NCW Delhi. The topic of his project is hydrodynamic methods for detection of submarines using the Bernoulli's hump. This work focuses on understanding how a submerged body creates detectable disturbances on the free surface and how the signatures can be used for non-acoustic detection. The scope of the presentation is as flashed on the screen. It begins with the project objectives and the background. I'll then discuss the hydrodynamic signatures, the factors affecting the Bernoulli's hump, the experimental setup, PIV methodology, model preparation, experimental procedure, results, and finally the future scope of the work. The first objective is to experimentally investigate the free surface disturbance created by submerged bodies at different speeds and depths. Next, the surface elevation is mapped using image processing. And finally, the Bernoulli's hump is identified and analyzed using different operating conditions. Further, objectives include analyzing the flow and pressure field using PIV, that is particle image velocimetry, extrapolating laboratory observations to full-scale submarines, which they have not figured out yet, and studying the effect of sail configuration on the surface signature of submarines. When a submerged body moves close to the free surface, it produces different hydrodynamic signatures, which is a surface elevation or depression, caused by pressure changes around the submerged body. Kelvin waves and Kelvin wake angle generated are other important signatures. The long-term objective is to use these signatures for the detection and tracking. Several parameters influence the Bernoulli's hump. Increasing depth generally reduces the surface disturbance, whereas increasing speed increases the pressure variation and makes the hump more prominent. Ocean condition, stratification, and submarine geometry also influence the observed surface signature. To investigate these effects experimentally, a carefully calibrated circulating tank is used. A NDYAG laser produces the laser sheet, while a high-speed camera records the flow and free surface behavior. And later, the BHH can be understood by the MATLAB code, which is a 600 to 700 line code, and the flow parameters can be analyzed using PIV. The tank which is displayed in the picture was manufactured in IIT Delhi as part of Ministry of Ports, Shipping and Waterway Authority. I was associated with the initial fabrication of the tank when I was an under trainee in NCW Delhi. It is a circulating water channel in which the test piece can be placed stationary and the water flow past object. The main objective of the tunnel was to investigate the turbulent flow. As it is said that two things which are unknown to humans are probably the God and the turbulence. The project was directed in the sense towards understanding turbulent flow for various surface types. Its main components are an inlet section, outer section, a test section with a transparent glass, and a few other measurement components. Moving on to the stratification process, in real oceans, water density changes with depth because of temperature and salinity. This creates stratified layers that resist vertical mixing and generate internal waves. Since stratification can modify the surface signature, it is an important parameter for future investigation. Another important concept is the significant wave height, h1 by 3, which represents the average height of 1/3 of waves in a sea state. Understanding the background sea state is an essential component because natural waves can mask or distort the submarine generated surface signature. Here the data is calculated by 3 different buoys deployed at different places of the Bay of Bengal and average is around 0.35 to 0.4 meter. PIV, particle image velocimetry, is the important primary experimental technique used in this work. It is a non-intrusive optical method that allows us to measure the velocity field without disturbing the flow. In our experiments, a uniform flow is generated in the circulating tank which was shown. Our laser sheet illuminates the seeded particles and the high-speed camera captures their motion. These images are later processed in MATLAB to obtain the flow field and free surface information. This slide compares different imaging platforms that can potentially detect submarine surface signatures. Aircraft and satellites operate at different altitudes and speeds, affecting their observation capability. This comparison highlights the importance of understanding how surface signature appears under different sensing conditions. Here, images corresponding to different submarine speeds are shown on the screen. This demonstrates that submarine speed has a strong influence on the detectability of free surface disturbance. Coming on to the model preparation, as all of you can see in the photograph, which is displayed on the screen, that the model was prepared using three components: a cylinder, a hemisphere, and a cone. Three-scale Akula class submarine models were prepared with different diameters while maintaining the geometric similarity. These models allow us to study how diameter influences the Bernoulli's hump. Calibration of the circulation tank and preliminary testing were also carried out before conducting the experiments. This slide summarizes the important experimental parameters, the calibration studies which were performed using PIV, the images were analyzed using MATLAB, and the flow velocity corresponding to different RPM values was obtained. The lens, field of view, frame rate, particle size, and water temperature were carefully selected to ensure reliable measurements. This figure shows the mean flow field obtained from MATLAB under PIV processing. A region of interest was selected and the mean velocity was calculated. This confirms that the flow inside the test section is sufficiently uniform before carrying out the actual submarine experiments. The graph represents the calibration of the circulation tank. The blue curve represents the expected calibration trend, while the red points represent the experimental measurements obtained during this work. The close agreement indicates that the calibration is satisfactory and the measured velocities are really reliable. The experimental setup used for recording the free surface wake is displayed here. Proper positioning of the model, the lighting arrangement, and camera alignment are essential to capture clear images of the surface disturbance. Using this experimental arrangement, the surface elevations are generated above the surface model, which can be measured accurately. These images form the basis for further MATLAB code processing and identification of Bernoulli's hump. For each test condition, the free surface is recorded both with and without the submarine model at different speeds. MATLAB code is then used to detect the free surface, compare it with the Rankine or void model, and generate the corresponding velocity and the pressure fields. The experimental procedure using model 3 operating at 750 RPM is illustrated here. It simply demonstrates the sequence followed during the experiments from data acquisition to analysis, covering entire experimental procedure. The figure presents the theoretical Bernoulli's hump and hollow predicted using the Rankine or void model. These theoretical predictions provide a reference against which the experimental observations are compared. Previous studies have shown that a source sink distributions can successfully represent the submarine flow field. They also demonstrate that surface disturbance decreases with increasing depth, and the pressure variations produce the characteristic Bernoulli hump as well as hollow. These are the streamlines obtained from the flow analysis. The streamline pattern helps us understand how the flow accelerates and changes direction around the submerged body, which ultimately influences the pressure distribution and the free surface deformation. The experimental velocity field is shown here. The red and black colors indicate regions with different flow velocities around the model. These velocity variations are directly related to the pressure changes responsible for Bernoulli's hump formation. Here, the corresponding pressure field is presented. The blue and red regions represent different pressure levels obtained from the experimental analysis. The pressure distribution clearly explains why humps and hollows appear on the free surface. This slide presents additional PIV results supporting the velocity and pressure analysis. Together, these plots validate the experimental methodology and improve our understanding of the flow behavior. This flow chart summarizes the MATLAB algorithm used. The images are pre-processed, the region of interest is selected, the free surface is detected and smooth, pixel coordinates are converted into physical dimensions, outliers are removed, and finally, the Bernoulli hump height along with the statistical plots is obtained. The figure on the left shows the Bernoulli's hump height obtained from the experiment. The figure on the right compares the experimental measurements shown by the blue points with the rank in overall prediction. This comparison allows us to evaluate how closely the theoretical model represents the experimental behavior. The velocity profiles above the submarine are analyzed for different operating conditions. Regions of high velocity correspond to low pressure and produce hollows, whereas low velocity corresponds to the high pressure and produces humps. This helps us to understand the movement of the Bernoulli's hump. Talking about the effect of input parameters we give, this slide compares the shift of Bernoulli's hump for different submarine diameters, speeds and depths. The results clearly show how these parameters influence both the magnitude and location of the surface disturbance. The future work will focus on obtaining higher resolution surface morphology using image stitching. The experiment is performed using 50 mm lens, but they will try to use 100 mm lens and repeat the same experiment for higher resolution. Further, optimizing the MATLAB code correlating the Bernoulli hump with the measured velocity and pressure fields, and introducing sail configuration into the experiment. Lastly, I thank all of you to be very patient and the good listeners. I also thank NIMS committee to facilitate the platform to present the experimental work carried out by Kudikala. Should you have any further questions, I have flashed an email ID on the screen. You may please write it to the author for further clarification. Thank you.
Yeah, thank you, Mr. Tegalan. And so the presentations are over. So what I think, we have just completed 3 presentations. I thought it's better to have a briefing on the papers before going to the discussions so that you come to know what all things have been covered in different presentations. So the first one, which has been presented from the NAPA side, Mr. Antti presented. So he presented it on route optimization. I think the routing of ships, which usually happens during bad weather conditions, when the motions are excessive and other considerations when derouting of ship is basically required. And one need to look into the, rerouting of the ship, look into the aspects of how much fuel is going to get consumed, what would be the length of the derouted path and all that. And usually happens in severe weather conditions when the sea is rough. So these are the things he has presented. I'm just, for the sake of the audience to recollect what has been presented, I'm just briefing it. He'll be able to address the details of it when we come to the discussion part. Then the second presentation has been on smart shipbuilding and ship operations, and how the various technologies, and including artificial intelligence, can be incorporated to enhance the speed and quality of shipbuilding or any fabrication. And so these are the things, and what also suggested that it can be the same technology can be used for surface ships, submarines, and offshore platforms. These are the things which has been covered in the second presentation. The last presentation is on the identification of submerged bodies, particularly submarines, when it operates at different water depths, and depending on the stratification of the fluids, whether density of the fluids are going to vary. So how the hydrodynamic signatures, including the buildup of water column at different locations when the submarine moves, so this can build up a database which can be used for a later identification of the submarine, including its speed and how much water beneath it. And so that's what I understand from the Bernoulli's hump aspect of the submarine or submerged body operation. So this is just a briefing of the presentation, what has been done. So now it's open for discussion, and may please go ahead.
Hello. Yeah. It's nice presentations for all of you. I mean, my questions to the person NAPA software, I mean the route optimizations and all. The question is, we are also have done some work on the same. Now, when you do the route optimization, what kind of parameters, what I understand from the presentation is that under the severe conditions, you have to find out the way to optimize the route in terms of timing and the fuel consumptions. Is it that?
I think there's some echo which has been coming. The question is not so clear. Would you please repeat briefly?
Okay. My question is that when you talk about the route optimization, is it under the severe weather condition, is it optimizing the with respect to the time and the fuel consumptions? That is the objective.
Is it on now? Yes. So the route optimization at the moment is based on the hindcast data, which of course, when we utilize that for optimizing routes, gives a little bit too optimistic, because the ship owners are, of course, optimizing their route based on the forecast. So in that sense, yes, we optimize based on the actual weather conditions along the dates.
So optimizing what? Like time or the fuel consumption?
Fuel consumption at this time. In the future, we are also looking this estimated arrivals time, make sure that the ship will perform such a way that the voyages can be done within the time limit given.
Okay, so then my next question is, when you're optimizing the fuel, that what parameters for the extreme sea conditions that you are taking into the consideration? I mean, the wave height, significant wave height, or any other speed of the vessel?
So the optimization is based either fixed speed, fixed MCR, or fixed RPM. And then we utilize, when we start finding the optimal route that is then based on the, well, all the sea conditions. So we have the wave heights, both from the wind as well as then the swell. So these are taken account in the different directions. Same thing is that we take account where the wind is blowing. So we have the yaw moments and drift angles are taken into account. And we try to find what is then the short or the optimal route with minimal fuel consumption.
Okay, so it is a kind of a Descartes algorithm, or it is some real-time monitoring system?
No, I'm not sure. Did I understand the question again?
It is when you are doing it, for example, there is a two way of looking at it. One is you can use some desktop simulation using some Descartes algorithm, all other stuffs, or maybe, and then you can improve the design of the vessel, or suppose the vessel is on board in ocean, and then based on the immediate weather condition, you are trying to optimization the route. I mean, which one basically? I'm just.
So if I understood correctly the question, the optimization is done based on the weather, and then we find what would be then the optimal route. That's the way.
So this optimum route, you are, it is real time you are doing it, or?
No, it's not the real time. It is based on the hindcast data. We do have certain time steps. We figure out if the step is such a way that the weather condition has changed too much and too drastically, we need to shorten the voids. If there is a maneuvering is needed, then we take shorter steps. But in cases when, especially if you are doing long voyages in the ocean, we can have quite a long time steps between.
In your software, for example, since you have done it desktop before actually it goes to the ocean, is there any possibility that you could, modify the hull geometry so that it can improve the performance of the vessel or optimization of the thing? Because what we can see that that let us say added resistance, something is actually typically affected the speed of the vessel, and typically it is basically the optimizations things and all fuel comes related to that. So some of the design normally we do, considering our wave resistance become the less, but when it actually operates in a rough sea conditions, it because of this second order, this added resistance, speed is going to be decreased heavily, and that affect the thing. So when you actually, because NAPA is a very good software for designing and everything, we all use in our industry, academy, everywhere. So it's a very interesting, that's why I'm asking such questions. Is it a possibility to do based on the some AI/ML model to do the hull optimizations once I specify the thing, and then you can see that, okay, if you design these sort of things, maybe you can avoid these sort of loads, and then you can optimize the hull, and performance will be the better in terms of,
Short answer, yes. This is exactly where we are developing it, the tool itself. So it is the tool designed, and we want to use it for the naval architects and the ship designers. So you can see that if, especially if you set, for example, constant RPM, and you start noticing that your ship speeds keeps dropping, that means that most likely you're going to need to think the wave added resistance, and can you minimize that? And the same thing, so the idea is that it is additional tool for the naval architects.
Yeah, because you are talking about the constant speed, but if in an adverse situation, your code is based on the ship is moving in a constant speed, but in case of this situation, you cannot maintain the speed actually because of this added resistance component.
So this would, if you set the optimization with the constant speed, and you exceed the limit of the engine or the propulsion power, then in a simulation, the speed will drop. So it doesn't allow you to estimate kind of the overpowered engine.
Yeah, I think we can have more discussion during the break, during the lunch break. And any other questions related to the presentation? Okay, maybe Arvind, just from my side, can I ask?
Sir, excuse me.
Yeah.
Sir, this is the same question related to that what you have asked. This route optimization.
May I know who is asking?
Sir, I am Babu Fakhruddin from Judging Corporation of India.
Okay.
Sir, this route optimization, it will happen on a real time because when vessel is sailing from one port to other port, this distance or if any weather is rough in particular area, that will be detected and route will be optimized and fuel consumption will be reduced. Like that it will happen. That way it will work.
So yes, it's not the real-time optimization, so we of course need to do it a discrete optimization. So as mentioned, we do have the weather data for recorded up to 10 years, the hindcast data. So we use this, so in a sense we know what is the next point, we know what is the time that they arrive there, and what is then the difference with the weather. Between those timestamps, there is the interpolation, what was the weather conditions around that time.
Okay, it will automatically change the route and automatically speed will be controlled. Like that it will happen, sir?
Yes, so at the moment it automatically optimizes the route. If it's set to optimize the route, it will find what is the route where the weather conditions are minimized, or the effect of the weather conditions are minimized, and fuel consumption is as small as possible.
Okay, thank you, sir.
Yeah.
Any other questions? Need? Okay, I think if no other questions, I congratulate the presenters for giving a wonderful presentations and also sticking to the time. And thanks to the audience for the nice cooperation. With that, I think we'll wind up. We are just winding it up before schedule. Thanks a lot. Thank you.
Thank you to our moderator and all presenters. We will now proceed with the presentation of mementos. May I request our moderator, Dr. P. Krishnankuti, Professor Retired, IIT Madras, to kindly present mementos to our distinguished presenters as a token of our appreciation. I shall now invite each of our presenters to receive the memento as I announce their name. Mr. Auntie Poso, Product Owner, Napa. Mr. Saurabh Bhardwaj, Technical Account Manager, Cadmatic India. Lieutenant Gaurav Tehlan, Indian Navy. Thank you, sir. May I now request Mr. Akshay Jain, Founder and CEO, Vedam Design, and Secretary, Indian Marine Designers Association, to kindly present a memento to our moderator, Dr. P. Krishnankuti, Professor Retired, IIT Madras, as a token of our appreciation. Thank you, sir. To commemorate this special session, I invite our moderator and all our presenters to please come forward for a group photograph. Once again, thank you to our moderator and all presenters. We will now break for lunch and networking. May I kindly request everyone to be back in the hall by 2 p.m. as we reconvene for our fourth panel discussion, AI and Automation in Ship Design and Shipbuilding. During lunch break, I request all delegates to visit exhibition stalls on either sides of the hall. We would once again like to acknowledge the generous support of our sponsors, our platinum sponsor Aviva, our gold sponsors Mazagon Dock Shipbuilders Limited and Dassault Systems, our silver sponsors Cadmatic and Chowgle Shipbuilding Division. We sincerely thank all our sponsors for their continued support in making DIMS 2026 possible. Thank you.
This is one of the most important events. As a maritime professional, I look forward to.
It is a privilege to attend this function.
The first day was a huge success.
I really want all of you to come for next day.
With the motto of providing unrivaled environment to exchange information, interesting topics have been lined up for this year's conference, some of which include renewable energy, technical innovations in shipbuilding and marine engineering, marine heavy lift and transport, marine operations and safety, and many more. Bringing together the global market leaders under a single roof, Mastic invites you to become a part of this prestigious event where industry comes together to learn and grow together.
New sustainability regulations from the International Maritime Organization signal massive changes ahead for shipbuilders. Whether you're designing new ships or retrofitting an existing fleet, your next voyage is digital. Digital transformation means you can navigate IMO 2050 regulations while improving your engineering efficiency by up to 30%. You can cut the time it takes to model a retrofit by as much as 20%. And design digital twins to guide you in building safer, more efficient, more sustainable operations at sea. Digital transformation ahoy! Aviva, we'll take you there.
Namaskaram from Singapore. On behalf of Safe Shiptech Alumni Far East, I sincerely express my wishes to Dostas for conducting this event. I hope this event will help the industry professionals, leaders, and alumni across the world.
Greetings to everyone attending DIMS 2026. Safe has a strong connection between Shiptech alumni across the region and generation. And DIMS provide an excellent platform for sharing knowledge, strengthening the friendship, and building new opportunities for collaboration.
Hello all. From the build-up, the program, and the enthusiasm, DIMS 2026 promises to be the best of its versions yet. We are all waiting for a slam dunk.
No matter where our career takes us across the world, we will always remain connected through our shared Shiptech roots, friendship, and values. From Singapore, we are proud to be part of this global alumni family and wish every participant an inspiring, rewarding, and memorable DIMS 2026.
Innovation is changing how we design, build, and operate ships. DIMS is where we come together to explore the ideas shaping the future of the maritime and offshore industry.
Congratulations, Dostas,
for engaging discussions,
inspiring innovations,
and lasting partnerships.
Best wishes to DIMS 2026. Polikita.
Have you noticed? India's maritime industry is changing faster than ever.
It has to. With Maritime Amrikal Vision 2047, India is aiming to become a global leader in shipbuilding, marine technology, and the blue economy.
But ships, ports, and technology don't build themselves.
They need the next generation of engineers, innovators, and leaders.
And that's exactly why Anchorage has been reimagined from a cultural fest to a techno-cultural fest, connecting students with the future of maritime industry.
Experience the IMO chamber, understand how policies and regulations are made, play the discussion in the captain's table, CEO edition, and explore the innovation hub featuring AI, machine learning, Python, CAT, ANSYS, VR, and more.
Explore the Indian Navy and Maritime Expo with powerful insights from distinguished guests and our proud alumni.
Compete in boat tours, ship model challenges, paper presentations, quiz, Shark Tank, and treasure hunt.
Experience mentalism, expert sessions, photography contests, and film screening, and edit all with a spectacular pro show.
Whether you're here to innovate
or to compete,
see you at Anchorage 26, happening on October 10, 11, and 12.
Hello. Nakul here from the 20th batch of QSAT, belonging to the UK arm of Dostas. And I want to wish all the organizers and the participants a fantastic event with DIMS 2026. I think this will go a long way in promoting our community, our experiences, and our journey in shared knowledge across. So, wish you all the best and all support from the UK. Thank you.
I wish all the delegates, the speakers, and the organizers all the very best for DIMS 2026.
To all the delegates and speakers for sharing your knowledge and experiences, and wishing everyone a very successful, exciting, and insightful event ahead.
It's wonderful to see experts from all over the globe.
This is one of the most important events. As a maritime professional, I look forward to.
It is a privilege to attend this function.
The first day was a huge success.
I really want all of you to come for next day.
motto of providing unrivaled environment to exchange information, interesting topics have been lined up for this year's conference, some of which include renewable energy, technical innovations in shipbuilding and marine engineering, marine heavy lift and transport, marine operations and safety, and many more. Bringing together the global market leaders under a single roof, Mastic invites you to become a part of this prestigious event where industry comes together to learn and grow together.
New sustainability regulations from the International Maritime Organization signal massive changes ahead for shipbuilders. Whether you're designing new ships or retrofitting an existing fleet, your next voyage is digital. Digital transformation means you can navigate IMO 2050 regulations while improving your engineering efficiency by up to 30%. You can cut the time it takes to model a retrofit by as much as 20%. And design digital twins to guide you in building safer, more efficient, more sustainable operations at sea. Digital transformation ahoy. Aviva will take you there.
Namaskaram from Singapore. On behalf of Safe Ship Academy Far East, I sincerely express my wishes to Dostas for conducting this event. I hope this event will help the industry professionals, leaders, and alumni across the world.
Greetings to everyone attending DIMS 2026. SafeWell is a strong connection between ShipTech alumni across a region and generation. And DIMS provide an excellent platform for sharing knowledge, strengthening the friendship, and building new opportunities for collaboration.
Hello all. From the build-up, the program, and the enthusiasm, Teams 2026 promises to be the best of its versions yet. We are all waiting for a slam dunk.
No matter where our career takes us across the world, we will always remain connected through our shared ShipTech roots, friendship, and values. From Singapore, we are proud to be part of this global alumni family and wish every participant an inspiring, rewarding, and memorable DIMS 2026.
Innovation is changing how we design, build, and operate ships. DIMS is where we come together to explore the ideas shaping the future of the maritime and offshore industry.
Congratulations, Dostas,
for engaging discussions,
inspiring innovations,
and lasting partnerships.
Best wishes to DIMS 2026. Polikita.
Have you noticed? India's maritime industry is changing faster than ever.
It has to. With Maritime Amrikal Vision 2047, India is aiming to become a global leader in shipbuilding, marine technology, and the blue economy.
But ships, ports, and technology don't build themselves.
They need the next generation of engineers, innovators, and leaders.
And that's exactly why Anchorage has been reimagined from a cultural fest to a techno-cultural fest, connecting students with the future of maritime industry.
Experience the IMO chamber. Understand how policies and regulations are made. Play the discussion in the captain's table, CEO edition, and explore the innovation hub featuring AI, machine learning, Python, CAT, ANSYS, VR, and more.
Explore the Indian Navy and Maritime Expo with powerful insights from distinguished guests and our proud alumni.
Compete in boat tours, ship model challenges, paper presentations, quiz, Shark Tank, and treasure hunt.
Experience mentalism, expert sessions, photography contests, and film screening, and edit all with a spectacular pro show.
Whether you are here to innovate
or to compete,
see you at Anchorage 26, happening on October 10, 11, and 12.
Hello, Nakul here from the 20th batch of QSAT, belonging to the UK arm of Dostas. And I want to wish all the organizers and the participants a fantastic event with DIMS 2026. I think this will go a long way in promoting our community, our experiences, and our journey in shared knowledge across. So, wish you all the best and all support from the UK. Thank you.
I wish all the delegates, the speakers, and the organizers all the very best for DIMS 2026.
To all the delegates and speakers for sharing your knowledge and experiences, and wishing everyone a very successful, exciting, and insightful event ahead.
It's wonderful to see experts from all over the globe coming together to navigate the challenges and opportunities in naval architecture and ocean engineering. May the sessions lead to valuable insights, strong international partnerships, and pioneering innovations. Hats off to the organizers.
I wish all the very best to DIMS and look forward to the innovative ideas that will come out.
Good day everyone. I'm Sandeep Kumar from the 14th batch of Department of Ship Technology. The DIMS that is being conducted by the Department of Ship Technology alumni on the 5th and 6th of August. Look forward to seeing you all there and wishing the organizers and the entire Department of Ship Technology all the very best for today and for the future.
We'll look forward to meet you all during the program. Thank you.
I would like to congratulate the Department of Ship Technology alumni for having this DIMS.
So I was a part of 2022 DIMS. So looking forward to see you all at DIMS and wishing you all the best.
I wish all of you all the very best for the forthcoming DIMS 2026.
All the very best to DIMS organizers, organized by the Department of Technology Alumni Network, Dostas.
I wish you a most inspiring and productive conference.
Wishing all the best for DIMS 2026 from Australia.
All the best to the DIMS 2026 and the organizers. All the best. And I was the first convener for the DIMS, and I'm so happy that DIMS is continuing. I wish all the very best to the organizers and the entire program. Thank you so much.
All our best wishes to DIMS 2026, organized by the Department of Ship Technology. See you all there. Thank you.
On behalf of MAST, the Middle East alumni of Ship Technology, it is our great pleasure to extend our heartfelt congratulations to the organizers and to everyone who have contributed to making this technical seminar a reality. May this seminar be a great success and a source of inspiration to everyone who are in attendance.
This seminar is more than just a gathering of experts. It is an opportunity to inspire new thinking, foster meaningful connections, and to create solutions that will shape the future of host industries and communities. The discussions, experiences, and insights shared today have the potential to become tomorrow's breakthroughs.
Events such as these are invaluable platforms for bringing together professionals, academics, industry leaders, and aspiring engineers to share knowledge, exchange ideas, and explore the latest technological advancements. In an era driven by innovation, digital transformation, and emerging technologies, collaboration and continuous learning are more important than ever.
To our speakers, delegates, students, sponsors, and organizers, thank you for being part of this remarkable event. We hope this event provides valuable knowledge, encourage productive discussions, and create lasting professional relationships.
From all of us at MAST, we wish DIMS 2026 every success. Have a wonderful seminar, enjoy the beautiful city of Kochi, and may you always have fair winds and falling seas.
Together we connect, together we innovate,
together we shape the future.
We welcome you all to DIMS 2026.
Modern warships and submarines are engineering marvels. Shaping them demands mastery of engineering and a vision that goes beyond the horizon. Mazagon Dock Shipbuilders Limited, a Navratna DPSU, and India's only shipyard to have built destroyers, submarines, and frigates. Spread over 75 acres, our state-of-the-art infrastructure enables the concurrent construction of 10 warships and 11 submarines. It all began here, in the historic Mazagon Dry Dock. Indian craftsmen built ships of Malabar teak that sailed the oceans of the world. In 1960, Mazagon Docks became a public sector undertaking under the Ministry of Defence, charting a course that would make us shipbuilders to the nation. First of the blocks was Nilgiri, India's first indigenous capital warship. Since then, we have delivered over 808 vessels, including 33 men of war. From missile boats to 7,000-ton destroyers. Every platform begins its journey in our VR-enabled design center. Integrated construction at our dedicated module shop enhances efficiency, compressing timelines. Every build is validated through rigorous harbor and sea trials. Our flagship programs, the Project 15 Bravo destroyers, Project 75 submarines, and Project 17 Alpha stealth frigates, demonstrate our ability to integrate complex and diverse systems and reflect the skill, expertise, and commitment of our 6,000-strong workforce. Amongst the most advanced warships in the world, their integrated systems enable superior situational awareness. Networked architectures provide hot redundancy, enhancing operational availability. Advanced sensors deliver comprehensive battle space awareness, while next-generation weapons provide the decisive edge. MDL has built 8 submarines, including 6 state-of-the-art Kalvari-class boats. With 2 independent construction and launch lines, including a dedicated submarine assembly workshop, we stand ready to build at scale. We have also built expertise in submarine repairs, refits, and modernization. We are currently progressing the manufacture of an indigenously designed air-independent propulsion plug for the Calvary class, significantly enhancing dived endurance. Our shipbuilding orders include 22 ships for the Indian Coast Guard and an export order for 6 multi-purpose vessels. We have also commenced production of 3 offshore platforms for the Oil and Natural Gas Corporation. Backed by consistent delivery and strong order book, MDL's financials reflect its robust growth story. With an eye on tomorrow, our expansion plans include asset acquisitions and a greenfield shipyard at Nhava Sheva. The strategic acquisition of Colombo Dockyard PLC marks MDL's first international foray, strengthening regional cooperation and growth in line with the Government of India's Mahasagar initiative. MDL has also expanded its R&D footprint, advancing projects such as AI-driven welding stations, fuel cell and solar-powered boats, underwater swarm drones, expendable underwater targets, lithium-ion batteries and mobile target emulators. Studies for the design of a new conventional submarine have also progressed. Furthering the vision of Skill India, MDL nurtures talent through its apprentice school and continuous training programs. We place equal emphasis on industrial safety and health, ensuring a secure and resilient work environment. Committed to give back, our CSR initiatives focus on meaningful and lasting impact. They include adopting tribal villages, empowering women, and supporting homes for children with special needs. Beyond platforms and projects, MDL invests in people. We believe steel forms the hull. People give it purpose. Mazagon Dock Shipbuilders Limited, built for scale, engineered for excellence.
Hello everyone, warm greetings from MAST, the Middle East alumni of Ship Technology. On behalf of the entire MAST family, it's a real pleasure to congratulate the organizers and everyone behind the 5th edition of Dostas International Maritime Seminar.
The maritime industry has always been about connecting people, ideas and possibilities. Today, as artificial intelligence, automation and digital technologies reshape the way we design, build and operate ships, that spirit of collaboration is more important than ever.
DIMS is more than just a seminar. It's a place where curiosity meets experience, where today's conversation becomes tomorrow's innovation, and where the next big idea might just begin over a cup of coffee.
To all the speakers, delegates, students and organizers, thank you for being part of this wonderful journey. We hope you all leave DIMS 2026 with fresh ideas, new friendships and renewed inspiration to shape the future of maritime together.
From all of us at MAST, we wish DIMS 2026 every success. Have a wonderful seminar, enjoy the beautiful city of Cochin, and may you always have fair winds and following seas.
Together we connect, together we innovate, together we shape the future. We welcome you all to DIMS 2026.
from food to trade and energy. Vast and powerful seas have always been essential to our world's prosperity. But if we are to realize the full potential of the ocean economy, we need to rethink a more responsible and sustainable path. We need better, safer, greener assets. From smarter ships designed with high-performance hulls, new materials, and alternative propulsion systems, to offshore assets capable of harnessing new energy and natural resources. It is time to transform the marine and offshore industry, innovating new business models and processes, leveraging advanced simulation, analytics, smart automated manufacturing, standardization and modularity, bringing operational excellence throughout an asset's entire life cycle with digital continuity. By enhancing the real world with the virtual world, Dassault Systèmes 3D Experience Platform unleashes a new wave of innovation, empowering the next generation workforce with deep knowledge. From ideation and engineering to manufacturing and asset in operation, the entire value network is connected into a single collaborative environment, unlocking the true value of our oceans by harmonizing product, nature, and life. In a future made possible by virtual universes, experience the future today.
Hello everyone. Warm greetings from the Middle East Alumni of Ship Technology, MAST. On behalf of the entire MAST family, it's a pleasure to congratulate the organizers and everyone behind the 5th edition of Dostas International Maritime Seminar DIMS 2026.
The maritime industry has been about connecting people, ideas, and possibilities. Today, AI and automation, digitalization are reshaping the way we design, build, and operate ships. The spirit of collaboration is more important than ever in our industry.
DIMS is more than just a seminar. It's a place where curiosity meets experience, where today's conversation may become tomorrow's innovation, and where the next big idea might just begin over a cup of coffee.
To all the speakers, delegates, students, and organizers, thank you for being the part of this journey. We hope you leave DIMS 2026 with fresh ideas, new friendships, and renewed inspiration to share the future of maritime together.
From all of us at MAST, we wish DIMS 2026 every success. Have a wonderful seminar, enjoy the beautiful city of Kochi, and may you always have a fair wings and a flowing sea.
Together we connect. Together we innovate. Together we shape the future.
Welcome to DIMS 2026.
Ladies and gentlemen, may I have your kind attention, please? We will be resuming the program in 5 minutes. May I kindly request everyone to be back in their seats as we prepare to commence our fourth panel discussion, AI and automation in ship design and shipbuilding. Thank you.
This is one of the most important events. As a maritime professional, I look forward to.
It is a privilege to attend this function.
Ladies and gentlemen, may I have your kind attention, please? We will be resuming our program right now. I request all the delegates sitting behind to please come forward and fill the vacant chairs. I would once again like to acknowledge the generous support of our sponsors. Our platinum sponsor Aviva, our gold sponsors Mazagon Dock Shipbuilders Limited and Dassault Systems, our silver sponsors Cadmatic and Chowgli Shipbuilding Division. We sincerely thank all our sponsors for their continued support in making DIMS 2026 possible. Thank you. Ladies and gentlemen, we now move to our fourth panel discussion, AI and automation in ship design and shipbuilding. This session brings together distinguished leaders from industry and technology to discuss how AI, digital engineering, automation, and advanced software are driving innovation across the ship design and shipbuilding lifecycle. May I now invite our chair for this session, Mr. Anil Das NT, CEO and Managing Director, Conceptia Software Technologies Private Limited, a distinguished naval architect, former Indian Navy officer, and technology entrepreneur with over 4 decades of experience in naval construction, ship design, and digital engineering solutions. Ladies and gentlemen, please welcome Mr. Anil Das NT. Welcome, sir. May I now invite Jaykumar Shah, Principal Marine Consultant, Aviva, who has been driving engineering excellence and digital transformation in the maritime industry for over 17 years, specializes in helping shipyards modernize operation through advanced life cycle management solutions. Ladies and gentlemen, please welcome Mr. Jaykumar Shah. Welcome, sir. Next, may I invite Mr. Krishna Chandra, Chief Mentor and Head of Strategy, C2C Advanced Systems, a technology leader with over 4 decades of experience in defense, industrial systems, and AI-driven digital platforms, dedicated to advancing indigenous innovation and next-generation defense technologies. Ladies and gentlemen, please welcome Mr. Krishna Chandra. Welcome, sir. Next, may I invite Mr. Navdeep Singh Arshi, Industry Leader, Aerospace, Defense, Marine and Offshore, Dassault Systems, India, who leads digital transformation initiatives across India's defense and shipbuilding ecosystem, helping organizations accelerate engineering, manufacturing and lifecycle management through advanced virtual technology. Ladies and gentlemen, please welcome Mr. Navdeep Singh Arshi. Welcome, sir. Next, may I invite Mr. Basant Konat, Senior Director, Research and Development, Ares Energy, a naval architect with over 2 decades of international experience leading research and decarbonization technologies, sustainability and innovative solutions for the marine and offshore sectors. Ladies and gentlemen, please welcome Mr. Basant Konat. Welcome, sir. Finally, may I invite Dr. Giri Rajashekhar Gunnu, Founder and Director, Vaishvik Vertex Solutions Private Limited, a researcher and innovator whose work focuses on AI-driven ship design automation, structural health monitoring, digital twins, and intelligent decision support systems for the maritime industry. Ladies and gentlemen, please welcome Dr. Girish Rajashekhar Gunnu. Welcome, sir. I now have the pleasure of handing over the session to our chair, Mr. Anil Das NT. Sir, the stage is yours.
Thank you very much. Good afternoon to all. After a sumptuous lunch, now it's my duty to serve you another sumptuous subject that would be, I hope, to make it sumptuous enough for all of you. Before I start, I would like to thank the organizers of DIMS 2026 for giving me this opportunity to chair this panel and drive home the point of today's subject, AI in ship design and shipbuilding. When Captain Jaishankar called me up to say we have a panel on AI and automation in ship design, and that I need to chair it, I was really elated on this opportunity because this field has the potential to attract talent to our industry. There are several pullers to the shipbuilding industry, and we must concentrate on all of them. And including this one, it will make very
attractive for youngsters to join the industry. Yesterday, we heard that the industry is dirty, difficult, and dangerous. Now, AI has a potential to bring in those safety features that are in the required in the shipyard, and therefore make it attractive and what is a safe working place, apart from the productivity part of it. Now, today's discussion, I would like to steer it in three parts. First would be about the data privacy when talking about AI. And the second one is about the availability of data, that is the surrogacy of data for the AI applications. And finally, about skilling. So skilling would be on the aspect that naval architects or engineers are not data scientists. Data scientists are not naval architects or engineers. But it is easier to equip a naval architect or an engineer with the tools that he requires to enable to him to become a data scientist. Now, with these three focus areas, I have this wonderful panel selected by the DIMS organizing committee, and I would be requesting them to make their presentations for 10 minutes, and thereafter I would engage with them in a question answer session before I open it out to the members. You may have noticed the name of Gautier Stone Street. His place is being taken by Mr. Jaikumar Shah because he had a problem of travel. So Mr. Jaikumar Shah replaces him. Now with this, I request Dassault Navdeep Singh Arshi to please come forward and make the presentation.
Hi, good afternoon, everyone. While the presentation loads, before that, I would like to thank the organizers of DIMS. This is a great event. All of us were fearing that AI will take jobs, but as of now, it's like AI has taken a lot of audiences. So I don't see a lot of people coming back from lunch. I think this is a post-lunch session, and I will do my best to keep you awake and not bore you with the content. So Dostas Systems is a known brand, and I think a lot of you here are users of SolidWorks, CATIA, these kind of tools, so I need not get into that. I've been entrusted with this opportunity to talk on AI-powered adaptive technologies in shipbuilding, and happy to be with this esteemed panel. So Dassault Systems, quickly I'll still tell about Dassault Systems. We are 25,000 people. Dassault Systems is not Dassault Aviation, so all of you who still have this doubt, these are two separate organizations. I want to clear it. Dassault Systems is a 45-year-old company now. We are the people who hold CATIA and SolidWorks, Abacus, these kind of tools. Yeah, so just to give you history of Dassault Systems, we started in 1981, where we founded CATIA. Post that, we work with the likes of Boeing and many automobile companies to coin the word PLM along with them. Then we launched a 3D experience platform in 2012, and this blue logo signifies a lot many things. See, what was happening after 2012, you as users used to come and say that I need this tool, I need that tool, right? But tool is exactly not what you're looking for. What you're looking for is someone to solve your problem. That is where we brought in the 3D experience platform, and this is our vision to AI, and I'll explain in the subsequent slides also. Platform unifies all 4 domains of your design, simulation, manufacturing, and analytics all put together. And we believe everything is connected on one unified data layer, and there is no concept of a separate PLM or separate PDM that exists anymore. every object has to talk to that single collaborative layer. This is what was launched in 2012 as unified platform. Then we applied the same to science, life sciences, and now in 2025 we have launched 3D experience universes. We are proud to have our large operations in India. India happens to be our largest R&D lab today. So this is the platform. As you see on the left side, on your left side, you will see SolidWorks, CATIA, GeoVia, BioVia. These are the kind of tools that bring in 3D modeling. Bottom, you'll see simulation, where we have engineering and manufacturing simulation. On the north quadrant, you will see the collaborative applications, and on the east quadrant, you will see the all analytics applications. We bring all of the input together, as I said again, on a unified data model to serve these 12 industries, and today we are going to talk about shipbuilding. So what we have done in terms of AI, if you see, as I explained, we started with Gen 1, which was mere 3D, to we have crossed the word of PDM, PLM, in Gen 3, Gen 4. We heard about virtual twins that you are doing today. Today we are at Gen 7, which is unified architecture, which brings everything that you do today, from your design to your simulation to your manufacturing to your maintenance data, everything is an object. It's not a file. All these objects are interlinked and they talk to each other, and that is what enables AI. So with 3D experience universes, and you'll see a very peculiar way where we are writing it, in between V and R, you will see a plus sign. That means that is where virtual meets real. Okay, that is exactly what we are trying to do. So 3D experience universes offers you a host of things. It synchronizes your virtual and real data. It integrates your modeling and simulation. It helps you do generative engineering. It has virtual companions that do work for you. A virtual twin in context of action is probably what you can see. It has immersive working environments, and intelligence capitalization is there. All these put together compile the new Gen 7 3D experience universes that was launched. Now, to do this, we have a concept known as industry world models. Now, what is industry world model? This is a very interesting thing to know. So, industry knowledge, this is where all of you come into picture. You know what your product has to do. This is a knowledge that is residing with you. It is your knowledge, right? Your IP. We have been building these kind of tools for last 45 years. So we understand how the physics works behind this, how the mod sim is there, what are the kind of structural analysis that has to be done. There is a complete physics behind our tools. All of this put together, you are trying to reason and generate your data faster. Now to do that, we have 3 virtual companions, Aura, Leo, and Mary. And I will explain this, what are these virtual companions that we have launched, which you query. Actually, these are industrial virtual companions, which you will query and get answer out of these industry world models. So one of the questions that is asked to us is that because you are working on industrial AI, it will require a lot of compute power. So we have partnered with NVIDIA, and we announced this partnership last year in Feb 25, where the compute and the store part is taken care by NVIDIA, and the learn and the generate part is taken care by us. So we are not only giving you a solution, we are also giving you the GPUs behind it to power this. So how does this work? What's the architecture? As you see at the bottom layer, there's an Outscale AI factories. Outscale is our own brand where we set up sovereign AI cloud factories for you. Okay. NVIDIA powers these AI factories with their GPUs and the CUDA-X models that you can see. This is then your industry world models come and sit on top of this compute and store layer, where you create your virtual twins. Virtual twin of a product, virtual twin of a production system, or virtual twin of a business model or an organization. Essentially, as I said before, there is nothing known as a product. I'm not saying it's nothing known, but we believe that we have moved far from product lifecycle management, and now we have entered into a phase of IP lifecycle management. Everything that you create is your own IP. And that is where 3D experience IP lifecycle management works on top of this. And then there is virtual companions, Aura, Leo, and Mary, which help you get answer to your queries on these objects through the brands that we offer. Essentially, I always keep on hearing that we want to add more features to the software. We want to add more users. We are moving, that is a value up approach where we keep on adding. We are moving to a value X, that's an exponential approach, where we are adding more knowledge, that's your IP, more units of work, and more user requests are being handled. This is exactly the change we are bringing. So how we are doing it? Let's take an example. Aura, Leo, and Mary are 3 agentic AIs that we have launched. Aura is the program manager, is the business worker. Leo is the designer or the engineer who manages all engineering disciplines, and Mary is the scientist. So Leo coming from Leonardo and Mary coming from Marie Curie. So that's how it has been named. So let's take an example in action actually over here. If you look at this, this is a 3D model of a ship and a program that is, a project deliverable that is there, a program timeline is there. What essentially we are doing, we are now trying to query through help of Aura that this is my program, can you identify risks that are there and give me a new project plan? So Aura is now looking at the project task and it is trying to update and create a new timeline. It is actually doing on its own while you are just giving it inputs, and all this structured data is coming from your 3D experience platform that is there, right? This is one of the examples probably I wanted to take and explain. Now it has created a new project plan. If you see, it has added some subtasks, and it is now also trying to adjust the duration. It is taking an example of a bulk carrier and doing it. Due to paucity of time, this is a fastened video, but this is exactly what I wanted to bring. This is an action launched now in 26x on our platform, and it is available for you to use. Aura, Leo, and Mary, all 3 agentic AIs working on 3D experience. In the interest of time, I'll try to go ahead. So how do we operate? In the shipbuilding context, we operate in 3 domains. Infrastructure, where we are supporting facilities for shipbuilding, your ports, your yards. We are working in the space of ship design, construction, and maintenance, and we are working in the domain of ship classification. So one of the questions, who are the customers we have been working with? We have a very interesting journey where we see people are now moving away from file-based import-export kind of a system to centralized platforms. So this has been our journey throughout. If you see, we have Indian customers like L&T, DGNPs, DRDO, IR Class, Mazgaon, CSL, and now SDG also on this. That was my presentation, a quick summary of probably what we do. And as we say in Dostas Systems, we make virtual worlds for real life. Thank you. Thanks a lot.
Thank you, Navdeep, for keeping on time. Now, may I request Jaykumar Shah to come and make your presentation. These are the 2 AI developers that we have on the panel. I also have the others with whom we will be talking shortly.
Hello, good afternoon, everyone. My name is Jaykumar Shah, and I am a principal marine consultant in Aviva. And thank you very much for the DIMS team to giving us the opportunity to present Aviva's solution on industrial AI for shipbuilding. So as you can see, Aviva's industrial intelligence delivered at scale, and we have globally more than 20,000 plus customers spread across 150 plus countries and in various industries. But broad level, if I just touch upon, top 10 global shipyards are using Aviva platform, 16,000 plus customers for manufacturing sites and smart factories are using Aviva solutions. 49 out of top 50 chemical producers, all top 25 F&B and CPG companies, and all top 10 mining and metals companies are using some part of Aviva solution. If you see here, Aviva, so Aviva is developing the AI solution since long. We have started this journey before there was a buzzword of AI. We started this journey from 2004. And what our goal is? Our goal is to make AI accessible, scalable, and actionable at the core of everything what we do. We believe that AI will power industries to build greater and more sustainable world. Imagine an automated, self-sufficient ship where AI is seamlessly guiding operations alongside human intelligence and creating a future where technology and people work together in harmony. So in Aviva's overall portfolio, we present more than 50 years of innovation and over 2 decades of AI expertise. We have 19 AI powered products across the life cycle of the ship and more than 170 patents which are awarded to date. And Aviva is continue to lead this way in the industrial intelligence solution. If we see here, the most important thing is digital thread, which must continue from engineering, commissioning to operation and maintenance. If we see during warranty or operation and maintenance phase, owner operator or a ship operator or even Navy needs the trusted data which are validated, which can be used to take the decision quickly and which can be used to take the action down the line so that we can have a better efficiency in operation and maintenance. But what happens in our present scenario, that whatever till now handover happens from the ships or the projects to the operation, those handovers typically happens in form of hard disk or in form of soft copies or hard copies. But during this handover, lot of informations are getting lost, and this is a major value leak in this information availability. So Aviva's digital thread removes this barrier by maintaining the continuity of the data end to end, enabling the information flowing from design and operation and beyond. It allows organization to aggregate the data from multiple sources, be it engineering 1D data, 2D data, 3D data, or our ERP data, which are a transactional data, or the real-time operational data. And these all the data are validated and harmonized, and which can be used as a single source of truth. And the foundation for this enables us the data quality, governance, validations, which basically unlocks the huge opportunity for cost savings across the entire life cycle of our ship, from design and execution through operation, maintenance, and optimization. If you see here, some of the use case of AI using industrial data. So first, if we see industrial AI assistant, we'll see it in detail, how we can leverage this trusted information which we have built throughout the project and even during the operation by leveraging the industrial AI assistant, when user can give the prompt and then information can be find out which is based on the trusted data. So here most important thing is the data foundation. Further, when I have the data which are trusted, I can use this data to train the model and build the predictive design. Also, I can use the various AI model to do the generative design. Now, let us see one example, our engineering excellence in action. Here, what example I am showing, that traditionally what happens, that we were also discussing about the how we can leverage AI in upskilling. So now when I talk about the software side, what is happening, that there is a long software learning cycle. User has to go through the training, he has to go through the lot of manuals and hands-on exercise to learn the software. But with our industrial AI assistant, what the user can do if his user is new and whether, let us say, he is routing the pipe or he is doing some hull modeling and he is having any query, so he can directly write a prompt in the help, and then system will go through all the documentation or all the past cases, support issues, whatever has been raised, and it gives you the clear direction that how to create the model, how to modify the model. Not only that, it also provides the citation. When I mean, what I mean by citation is, it gives the result and also it gives you the link from where you can see that this result has come from exactly which source, which section of the document, so that if he wants to deep dive in detail, he can open and he can go through this in detail. So basically this reduce the dependency of the user on the admins or on the long trainings, or I would say on the various issues which are already resolved in the past. Because with this he will get all this information with click of a button when he writes the prompt. So here we are using the large language model to get all this information from different sources. Now further I want to move to the next step, that is basically on the operation side, it is autonomous inspection. So traditionally what is happening, we do the inspection by person moving on site and he is taking the lot of records and then notes, and he comes back and he plans the activity. Now with the robots available nowadays, what robots can do, robots can be trained on our plant layout or a ship layout, and then these robots with the use of drones can be used and trained to do this inspection. So here this robot is trained and there is a drone which is guiding him to navigate in the plant or in the ship, and then he can identify the various places through which he has to do the inspection or he has to take the records, and he is also trained with the condition in the ship. Now here if we, let us say, it gets little closer and watch that how this reading is, he scan the images, but what we are seeing, it is not that simple, because if we see for a human, if human does this activity, there are a lot of intelligence goes behind it. He gauges the situation, he measures the pressures in the bar, he reads the scale from 0 to 10, and then he is reading roughly that it is 8.5. But when we talk about the robot, what he has to do, there are various practical challenges. There may be a poor lighting, there may be not a straight angle, straight face of the meter, or there may be a dirt, or there may be a wear and tear, and also there may be a issue in understanding the range, in interpreting the ticks on the bar, and even he has to figure out the right hand of that needle which basically provides the exact reading. But all these things nowadays are possible with the technology development, that industrial cognition is what gives the gauge image reading. So all these things nowadays with this industrial cognition we can achieve this. And then so further what happens, that once this information is there, this information we can bring it on the platform where we can see this information in context, that what reading was taken at different timestamp, what is the trend, exactly where this pressure gauge is there in my PNID, and then based on the trend and based on the readings, the user can take a call that some work or at site has to be taken up. So that activity can be taken. So in summary, what we are seeing here is the inspection and the decision and action, what action has to be taken. All these things can be automated using the industrial AI technology. Further, if I go, once this is done, we know that these are remote locations. It is difficult to access, difficult to have connectivity. So robots can be charged, can be recalibrated, and can be ensured that whatever functioning it is doing properly. I'm just moving fast. So just to summarize, this is the future and the technology is available. With Aviva, we can take you there. Thank you.
Thank you, Jayakumar. I now invite Krishna Chandra to present.
Yeah, sure. Good afternoon. My name is Krishna. I work I lead a company called C2C Advanced Systems. It's an 8-year-old company. We started as a command and control company, and the very first month of our inception, we sold combat management system outside of the country. My team members had already built the platform, and that was our first success. Over a period of last 8 years, we have emerged as one of the leading platform players on all the military platforms, and then onto the security platforms, then onto critical infrastructure platforms. So we are primarily a platform company. We fuse design, manufacturing, supply chain, maintenance into one real picture, which is relevant in the shipbuilding industry. We are not a product vendor. Our DNA is military, but it's extended to the industry. We fully integrated from edge to command, and we are a software-first company. We don't manufacture anything, and sometimes we do have a problem when I talk to a lot of people when they say, what do you manufacture? What IT deliveries that you do? That's always a problem. It's a top-down architecture, bottom-up implementation. Our ontology is unified, global standards. The AI system actually communicate rather than becoming disconnected vendor islands. So we recognize the fact that AI/ML is proliferating and complex, but most of the proliferation is on the LLM side, on the IT side. We do not see that in the OT side. And that's where I think our focus has been in the last few years. And I'm very happy to talk in DIMS because I believe this is the right conversation. So what we have, we created 4 architectural suites. C5ISR is primarily on the military side. It's a multi-domain command control system. It fuses all the radars, EO, IR, acoustic, real-time common operating picture. It's been deployed in Indian Navy, DRDO, Royal Malaysian Navy, and we expect to announce a few more deals in the Southeast Asia, and we are working with the Canadians on the navigational systems at this point. Magi-IX is primarily directed toward the industry and critical infrastructure intelligence platform, focused on OT, ICS monitoring, and anomaly detection. It's physics-grounded AI, not statistical baseline. So in the shipyard, it'll be process intelligent and quality control. So it's aligned on the IEC standards. The Magi OI OS, which is what we announced a few weeks ago, it's an AI apex layer, which is a platform intelligence that sits on top of the decision support system. Common ontology across all sensors, builds sovereign intelligence layer, and it has an inbuilt digital twin integration capabilities. And then we have the Magi Security 360, which is a comprehensive OT security that we have announced. So it's essentially a layer on top of all of the OT security that you have. And that would essentially, our intent is that the system gets protected. For us, AI is not a software tool. It's very different for us. Architectural question is not which AI tool to buy, but it is who owns the intelligence layer. That's our philosophy. On the IT side, incredible amount of investments is flowing in. They're adapting fast, but please watch what you depend on. That's our considered opinion. On the OT side, sensor vendors are all adding agentic AIs. Design companies are adding agentic AIs to various AI systems. The question is, it's very powerful at the edge, blind at the command level. Our approach on this has been to build a common ontology, physics-grounded models, vendor agnostic. We couldn't care where the systems, the subsystems and the sensors came from. And it's sovereign. It's all built in India and validated in India. Just to add to it, the entire platform that we have developed, all the 4 of them are indigenous, built on several million lines of code, all done indigenously. Coming to the shipbuilding, it's a huge industry. It's growing at a reasonable pace. And I think India is going to be a factor in this market. There are about 25% of the applications in the shipbuilding industry is AI-driven. Korea, China, I think, are building at scale implementation of AI models. The question in India is whether the transformation happens or will it just become a consuming economy of third-party products? The moment is now, the choice is ours. India is at an inflection point. We are launching a new indigenous vessel every 40 days. Data from those vessels, from design all the way to operations, is a national asset. The question that I have right now is, are we capturing that? Yes, we have created great institutions like INICAI, which is operational, Crystal, which is operational. I think the Navy is ahead of the private sector, and the industry needs to catch up. Cochin and Mazagon docks and IIT Hyderabad, I think, are collaborating. I think that will yield enormous results. AI in shipbuilding is not a hype. I think the data is already there. 65% of the shipbuilders have adapted it. 45% are investing in AI-powered VR training. 30% see a reduction in unplanned downtime thanks to application of the AI systems. There's also 10 to 15% fuel savings. The design iteration time is coming from weeks to hours, thanks to some of the products that are out in the market, which really aid that process. But still, I see 4 challenges. And I think our architecture will address all of them. First one is data security in AI-driven design. I think this is a very critical challenge that we have. The second challenge we have is interoperability between design systems, fragmented vendor-locked AI, workforce reskilling at scale. All 4 of them are the challenges. I think I've already explained to you the OT security, the data ontology, and the systems we are building around AR, VR, I think, which is already built into the platform, will address some of them. The advantage and the constraint. Indigenization program drives demand. The deep software talent that is existing in India Is it ready for the maritime use? Is a question. We don't need to import anything. We can build most of it in India. INICAI and Crystal, they're already operational. I think they're going to give some depth to it. And I think from our point of view, we have the domain depth. We don't attempt any platform unless we have and we understand the domain carefully. The real constraint is shop floor data infrastructure, sensor, data pipeline, people infrastructure. That AI requires as a raw material, we are not very clear whether that exists. And I think that requires to be addressed very quickly because no AI can function unless this issue is addressed. Finally, I think on the people, not headcount. I think AI changes what workers do, not how many are needed. Welders need to become quality supervisors, draftsmen need to become co-pilots, and for India, the skilling is the most strategic sector. Digital twins is again an issue that we have, and I think what I would be happy to do is to share some of my slide presentation with you, any of you would want it. Again, we have thought through some of this, and we have a fair amount of knowledge and experience in it. The final point I'll make is that we have delivered number of platforms. The CMS is one of them. Drone command and control is the other area that we have delivered several platforms. Vessel stability management, I think we have 90 ships in India are operating with that stability management. So we have delivered both in India and globally. And the final point again is sovereignty is really at stake. It's not the efficiency. I think we cannot be dependent eventually on others to build our sovereign knowledge. Thank you very much.
Thank you, Krishna. I would like to now invite Basant for making his presentation.
Thank you, Dostas, for inviting me here. Here, I would wish to discuss with you, share my thoughts regarding how intelligent is AI in terms, where does AI stands in shipbuilding, the challenges and gaps in implementing the AI into shipbuilding process and ship design process, the gap mitigation measures, the pros and cons of AI and further developing the AI infrastructure, what are the ethical and governance things that we need to focus. Yeah, a brief on my company. I work with this company, Aries Marine. It's a group of 88 companies spread across 31 countries. We started in the year 1998, and this is our 28th year of operation. And we have roughly around 4,000 employees, and we are providing our services worldwide. And our main activities into the offshore naval architecture and engineering, where we provide the consultancy services for the marine and offshore industry. Another core division is the inspection and maintenance, where we provide all the conventional and advanced entities and inspection services for maintaining offshore and marine assets. So now coming into the a few cases there where Aries utilizes AI into its operations. So we utilize our services in underwater inspections, topographical surveys for analyzing the data, and also we have an R&D project on paint inspections. So now coming into where we stand in the ship design and shipbuilding AI implementation. So I have just tried to list out a few industries and compare the level of maturity of level of AI maturity of shipbuilding and ship design compared to the other industries. So many of the fields like language recognition, software development, automobile industry, iron and steel industry, they have a high level of maturity. Some have the medium level, and shipbuilding and ship design lies in the low level of maturity. So if you look at this, the industries having high level of maturity, you can find certain common features. They have abundant data availability on their field, and also they have standard operating procedures. So, and unfortunately in shipbuilding and ship design we lack both. So there is sheer lack of data, and our procedures and processes are very complex, and each ship is different. So that makes the process slightly difficult to implement AI process. A huge amount of effort is needed and intelligence is needed compared to standardized processes. So now coming into the challenges that we may face when we try to implement AI, number one is on the data. There is non-availability of data or lack of data available in public domain or in shared form. And on the design aspects, it is a highly customized product, and each ship is different. So, and there is complex multidisciplinary engineering processes involved, and we have different types of individual softwares doing different types of analysis and processes. So integrating that will be a challenge. And validation is another issue that we need to address. The AI process which is used to produce the designs and products, that should have a validation procedure. And coming into the production, again, this is also a multidisciplinary integration process which need a higher level of AI intelligence. So there also we need to work out. So now how we mitigate the gaps. So on the data side, we have a lot of data available in hard copies or in scanned formats. So we need sheer digitalization of data. All of us companies have so much data, but in non-digital form. So again, further data can be developed, if not available, it can be developed synthetically using general engineering methods, using simulations. So that is synthetic generation of data, and hundreds and thousands of sample designs can be produced this way, and that can be used for AI training. And again, domain-specific databases, like specific database for specific domains like hull, structure, piping, electrical, that also need to be segregated and collected for specific AI trainings, agentic AI trainings and things. So, and on the design aspects, the agentic AI-based design and the agentic framework, that seems to be the way forward for integrating the complex processes of ship design and shipbuilding. So huge amount of work is needed in that direction. Also on the validation standards, the classification societies and the authorities, they need to make validation standards as well. So, and the high level of skill development is needed for adopting into the AI world. On the production side, again, the agentic AI, it plays a very big role in integrating the different domains. And again, here also the digitalization is important, and digital twin also plays a very big role in coordinating the process. A lot of robotic systems like cameras, scanners, and sensors, they will act as the eyes, ears, and skin of the AI system, giving feedbacks and things. So now coming into the pros and cons. Pros are evident. We get a better quality product in a very fast pace at a reduced cost. So definitely there is a improvement in the efficiency. On the cons, we have a high capex investment for implementing the AI process. And there are certain legal issues like data privacy, cybersecurity, and reduced workforce issues, the job loss issues, and also some technical problems like very novel designs. Even though the AI is trained, it can struggle. And always we can expect hallucination errors from AI, so that demands for a human intervention. Yeah. So to address the concerns, the concerns, we need policies from the state as well as technical solutions from the authorities as well. So the general impressions for discussion I would wish to discuss. Okay, AI is beneficial for us. The foundation stone is laid by different industries here. We have challenges, but we have solutions as well. And for future development, we have to be systematic, responsible, accountable, and ethical. Thank you.
Thank you, Basant. I now call upon the final presenter, Dr. Giri. Yeah.
Good afternoon, ladies and gentlemen. It's a pleasure to be here at DIMS 2026. As a young budding entrepreneur, probably I'm a little different sector from them, just to bring it to that, because I started building AI products on particularly AI-based ship design and digital twin from the scratch. So now, if you see that AI-powered adaptive technologies in ship design, why is very important in the I need to change it here. Yeah. Can you change it? Next slide. I can do it from here. Okay. Sure. Yeah. So now when we talk about, if you see, when we talk about like adaptive technologies in the ship design, why a hype, and is it a hype or a reality? If you look into that, the Manchester Institute of Technology, they developed a diffusion-based artificial intelligence model, which is basically going to give you the fine hull form, which are better resistance characteristics, and also better fuel optimizations. So that means it's not just a hype. Industry has already started adopting. So that's what I want to bring it to that. The ship design is nothing but generative algorithms. When you talk about adaptive technology, adaptive-based ship designs, plus machine learning and digital twins. Finally, to build smarter and lower drag hulls and lighter optimized structures. So we talk about one side is in hydrodynamic performance. On the other side, we're also talking about a structural optimizations, and which in a way is going to affect on multiple other decision parameters. Like if you change the different types of stiffening and strengthening, how the weight is going to vary, or how the maintenance is going to vary, or what is the cost of the welding, and also how much the cargo is going to be reducing the weight or increasing the weight, we can carry the more cargo. So all these parameters can be taken, these multi-objective parameters can be taken when we talk about it with a unique objective. So now some of the AI in changing ship design, the faster hull design optimizations, basically lower fuel consumption, better hydrodynamic performance. When we talk about hydrodynamics with respect to the resistance and motion and also the maneuvering. And all these three things again depends on the type of the vessel, the objective also going to vary. And reduced emissions, automatically if you reduce the fuel consumption, emissions is going to be controlled. And if you manage the structural health monitoring perspective, also one of course people talk about the failures. The second one is how do you manage the vessel? Automatically the life of the ship itself can be increased. On the other side, on the machinery, we are thinking about moving to the, if you see the Rolls-Royce dream, by 2050, most of the vessels will be operated autonomously. So that means you need the engines and machineries to be monitored, and also we should know the faults and failures much advanced. If possible, we should also come up with the prescriptions, what type of mitigations has to be done. The digital twin, if I look into digital twin, according to me, there's 210 varieties of the digital twins. Out of that 4 or 5 is predominant. I will come to that in upcoming slides. The better performance, the better maintenance, reduce the operational cost, and also improve the safety, that's a goal. On the other side, we are moving to the AI and autonomous vessels. Now we talk about certain advantages. Some challenges are there. I think the earlier speaker also mentioned about data quality and availability. As the industry is moving and adopting AI, now there is other challenge comes to the regulatory bodies need to come up with the compliance, and also ethics also another important concern, and the cyber security. Of course, one way it is enabling us to take a better decisions. On the other side, we are over and over getting our reliance increasing on artificial intelligence. So that is in a way creating some type of expertise gap in upcoming days. And cost and integrations, there are different types of digital twins and solutions as there, but we need to come up with that, what is the cost effective solutions. And to cope up with this technology, we need to also train and upskill the human resource. So the core AI design technologies, the generative hull optimizations, just now I mentioned about the MIT as an example, and the graphical neural networks, the models map complex structural elements like stiffeners and plates to streamline the block construction layout. And reinforcement learning, it's a continuously adapt based on the model what you develop and the behavior, and based on the environment, it's more adaptive. And on the other side, surrogated models. If you think like, something like a CFD simulations, to convert sometimes is use computational time. So why don't we learn the past experience, encapsulate into surrogated model, then it's a small duration, we can extrapolate from that using the surrogated models. So now, all these things basically to finally come to that, AI is an accelerating for decision-making process, not to replace the human. It is going to help us in a better decision-making. So we primarily focus from our side on a prescriptive. Something descriptive means something has already happened, and you can understand why it has happened, and predictive. But the business is always depends on the prescriptive side. That means what type of actions are need to be executed to come up with a better return on investment. So with this with this basic introduction, I will shift to what we are doing in Vaishvik Vertex Solutions Private Limited. I'm a founder of this Vaishvik Vertex Solutions Private Limited. Basically, it's a engineering intelligence company. It started basically like a lot of naval architecture analysis, a repeated work. We do a huge amount of time, but it's a little bit boring. So why don't we try to automate it, and from the automated, why don't you take it to the AI-based digital twins or solutions? With that thought process, we started this. It's an end-to-end solution from rigorous design to AI-driven deployment. It can be design side, or it can be condition monitoring side, or it can be fault detection and failure detection side. So our organization primarily have 4 verticals. Here I can only see here 3, but 4 verticals. The first one is basically design consultancy. Every design consultancy experience, we take it to the AI-based level solution. And the second one is the products. We do indigenous products, like we develop our own solvers. for doing the ship design, for doing the CFD simulations, for motion estimations, and also the structural design, even with satisfying the rules and regulations. And the third one is the training and capability. We help corporates to train in digital twin and also the structural analysis, structural reliability, and CFD in other areas. So as I mentioned earlier, there was about 210 varieties of digital twins. This is I got it from IoT Analytics. But if you see here, the first one is the simulation, the twins for system prediction. That means fault detection and fault prediction, or maybe the forecasting about the health condition. The twins for the system simulations, that is going to contain about 28% of the market. So a lot of times when you try to do the design or simulations like CFD simulations, FEM simulations, why don't we encapsulate that information to the digital twin, and going ahead, we don't require to spend that much simulations time. In a short span of time, we can come up with better decisions. This can assist in the design phase, or in analysis planning phase, or in a real-time condition monitoring phase, or it can be on regulatory compliances or guidelines for the people involved in that. And the twin for asset interoperability, yeah. So these are our products, ship design product and midship section. We made a complete AI-based midship section, and also the ship recycle planner, and also complete transportation, end-to-end transportation for barges. And just I will go to the few of the products. The first one is the barge sim. If you do the transportation of the offshore of any jacket section offshore barge, you need to maintain the stability, motion, strength. Now this is a complete ship specific, barge specific system, the framework. You just give a basic information, the framework builds it. It can be used by all the stakeholders in different phases. And similar way, this is the emergency response twin. Any accident happens, you have emergency response service for to manage the stability. Instead of depending on shore, you can ask the platform within a small fraction of time. It is coming up with the best mitigation strategy you can implement and sail the ship back to the yard for repair. The third one is ship design. This is a complete design. You give a basic form coefficients and parameters. The hull form will come automatically, and all the stability and strength and will be assessed. And the final one, this is a completely indigenously developed FEM package for performing the structural analysis, both static and dynamic and nonlinear analysis for monopiles and truss alignments. Yeah. So what should we do now? I primarily here, I think this is the time for hand-holding from all the stakeholders, and we should come up with develop a solutions which is a local, but it should be given for the global. So yeah. And the final one for GenJet, because there is a questions like, I think it's, when it's particularly coming to the naval architects and marine engineers, we need to think about a combination of engineering skills and also the AI skills. So both is required. You can't just only rely on AI skills, because we said like, we're completely relying on the AI systems. That's going to throw certain challenges to us. Thank you very much.
Now that all the presentations have been done, in the same order of the presentation, I would like to have a chat with you. So when we talk about unified environments for the applications of AI in ship design, Navdeep, can you please articulate the priorities on your tool, that is the 3D Experience platform?
Thank you for the question. So as I said in my presentation also, 3D Experience platform, when it was launched in 2012, which was launched with a vision of moving away from siloed approach of files, of your CAD data, of your simulation data, of your MBOM, EBOM, into an object-driven fundamental. 14, 15 years later today, when I spoke about 3D Experience Universes, what it does is it takes these objects, and every object, when I say, is actually queryable. That means your agentic AI can go and query the object. And the vision that we have is that, for example, let's say your hull design is an object, and you make a change to your hull design. it will flag a change to your simulation, it will flag a change to your downstream manufacturing activity, and it will flag a change to your even maintenance data. Now, all these objects, which we call as your IP, are working together to manage the life cycle of this entire IP that is there. And our agentic AIs will help you, either you want to do program management, you want to do design optimization, or you want to even create a new material for your project. Work on these using your data and the physics equations that we bring with the help of our tools together. That's the vision we have for AI. And that's the simplification. We started in 2012. And now with this data being available, I think it's possible.
So at the start, I explained that we would like to focus on three things, that is data privacy, data availability, and the skill development. So when you say about AI systems in yours, how private is the data? Are your systems available on customers' campus?
Yes.
Or is it a web-based solution?
So we do both. We have both on-premise and on cloud. And our AI systems are powered by our own Outscale brand, which offers the sovereign cloud. And this 3D Experience Universities, which is based on Gen 7 and powered by the Outscale brand, is SECNUM 3.2 ANSSI certified. Now, what does that mean? While it's a heavy terminology, but what does that mean? It means that we need to do three things. Number one, I have to make sure that the data is there on the user's premise with the user. That's the sovereignty. Second, it has a multi-factor authentication that is built in. Number three, it is protected from inter-territorial or extraterritorial kind of legal laws. That means today, if you have a data which is resting in your premise, it is your data which is running on our cloud application. A change of law in some other country cannot ask you to reveal your data, right? So the data is truly protected. So let me give you a working example also of this. Today, Dassault Aviation is working on futuristic combat aircraft, which is exactly working on the same principle where data is resting inside Dassault Aviation. They have brought 17 different European organizations together to build this next generation aircraft. The idea is to use the accelerated cloud and AI development and deliver the aircraft within next 7 years, right?
Right. So you also mentioned in your presentation about your association with NVIDIA. Right. And so can you explain what it is physically and how is it going to, are you focusing on any foundational models that work? I mean, will your tool also become part of the workflow in future?
Yeah, so let me explain this in a more simpler manner. As I explained, NVIDIA, we are doing the compute and the storage part, and the learning and the generation part is taken care by Dassault. And in my presentation, I mentioned the word CUDA. CUDA is compute unification of the device architecture. The idea here is that the GPU is given by NVIDIA, and we give the learning and the generational part. So let me take an example. Let us say today we want to do a simulation of a hull, and we will first create a surrogate model. And a lot of my fellow panelists have mentioned about it. What's a surrogate model? To simplify, surrogate model is let's say a replica where what happens that AI comes and it runs high fidelity computations through design of experiments, and now it has created, let's say, 500 different type of simulations are there. It has mapped the input-output, that input-output that it has actually run the high fidelity simulation on that GPU, which is given by NVIDIA. We have the input-output available with us, which is then given to a neural regression model. Now, once you come and say that this is my hull and I want to run this kind of simulation on it, it will actually go to that synthetic data on the surrogate and give you an output instantaneously because it has already run a model, right? So that part NVIDIA brings in where the model is being run in GPU, but the front part where you are querying and getting an instantaneous generational output, that is where we come into picture, right?
Thank you. That's clear. Now I come to Jayakumar Shah. You have the Aviva Connect platform, okay? So how is it in terms of data privacy, and how much is the data that is required to be available in each of the, be it design houses or individual naval architects or companies? Could you please throw some light on that?
So basically, our Connect platform is open and neutral, and Connect platform is basically enables you to manage the data which are on the cloud or critical data which are there on premise. And this gives you the single pane of view, which basically gives the contextual visualization on a browser. And our Connect platform is available as a SaaS, where the data center is residing in India, which is Mighty M Panel Data Center. Second thing is, these can also be deployed in the hosted environment. So sometimes the customers or clients will have their own cloud infrastructure. So this platform can also be deployed on the third-party cloud hosted environment. And this is not limiting you to use any specific application. So it can be a third-party application, probably a 3D model, or probably the design data or drawing. So we have the connectors where we are leveraging the AI agents which process those different data, extract the information, and contextualize it, which can be used to take the decision.
So my question was more in the context of, there are several defense customers also here.
Yeah.
They would like to have your AI systems on premises, and at the same time they would like to have the advantage of the underlying the AI model that they can use, be it ChatGPT or be it other foundational models. Can you please explain about that?
So if we have to use, let us say, on-premise capability of ChatGPT, then in that case, we can also have the MCP servers. So nowadays, to leverage this AI model, which is mainly a cloud subscription or cloud services based model are available. But if we want to leverage it in our on-premise infrastructure, then we can also leverage this MCP server, which can enable us to leverage these AI services and build the use cases which remains within our environment. So these can be deployed through MCP server also.
Yeah, thank you. So that clarifies. Chandra Saab, you explained about your journey in the area of AI. Could you please throw your points of view regarding these three things of data privacy, data availability, and the skilling?
No, we built our entire platform on the basis of sovereignty is our fundamental logic.
Okay.
All data must remain within the country. At various levels, there are data that's generated, and how do you unify the data and to be able to put a structure on top of it that's able to make use of everything that happens. Design side is one side, but much of the on the defense as well as on the security environment, or even on the critical infrastructure, it's the sensors. Defense, it'll be radars, electro-optical sensors, and so on. Most of them are imported at this point in time, and even if it's partly made in India, several of the components are coming from overseas. And there are also vendors who are willing to provide agentic AI on top of that equipment. The question that comes up is, how sovereign is it? How do we protect it? So our entire strategy is around how to protect a group of sensors, and their ability to ensure that we create an AI layer on top of it that's able to make use of all the data that's available.
Okay, so here we have several people who would like to deploy AI in their in their premises, or in their respective companies. because either it is today or tomorrow we have to be there. Otherwise, we are not in a position to leverage that. So how do you suggest companies to start their AI journey with your experience?
Sir, it's always best to start at the edge level and get the edge AI sorted out first before you go all the way to at the command and control level.
Okay.
So one of the projects we are working on is at the command post at the border, which has multiple sensors, various kinds of sensors feeding into it, starting from radars to drones to whatever, satellite communication. So that's where we start our journey from, because going and selling a large system to somebody in the defense in India is not possible. Overseas, yes, but not here.
Okay. Yeah. Thank you. Thank you. Here, I would like to now go, Basant, just give me 1 minute. I'll go to Dr. Giri. The same question, Dr. Giri, can you are a developer of AI systems. You have given a presentation of the systems that you have developed. Could you please tell the audience how an AI journey should start? Of course, each of us, including my company, we have about 15, 20 years of data available. Some of them even may have IP rights. So data privacy is very important. So how do you suggest that it is taken care of?
First of all, when we want to adopt AI-based solutions, most of the time, what I see that people sometimes start from the model and trying to find the business case. I think I should go other around. Fix the business case and come back and see how it should be solved, what data is required. And when we talk about data security, actually I think every data we are trying to say it has to be secured. Probably that is where we need to come to some level of clarity which data need to be secured and which data can be shared. And if it is supposed to be secured, at least what we try to adopt it can be, the complete application can be given to them. User can work with that application, or if you want, he can also, a small scale user, if you can't manage that computational resources, he can take his own cloud service and he can deploy there. And that is also possible. Yeah.
Now, how do you give the confidence level to the two aspects? One is data privacy, which you said, share the data that is permissible to be shared. But the other aspect is of data availability. If data availability is less in terms of what is required for training an AI model, how do you suggest that we proceed?
If I talk about a simulation-based digital twin to start, in fact, that complete data itself can be created by us, and surrogated models, optimization models, everything can be built. That can be verified, validated with with the new set of the data. And besides that, when we want to go for a real-time digital twin, already you built a surrogated models with the simulations data. The deviations can be trained with a less amount of the data. Sometimes quantitative, it may not be so accurate, but qualitative, it will give a lot of insights for the operator. Over the period, it will be quantitatively also accurate. So this is the way to start. And another aspect, a small problem with a low-hanging fruit, and which can be scaled horizontally, vertically, better to get the belief for the organizations, small organizations.
Yeah, that's taken. So go for the low-hanging fruits is what is the thing. Now, when it comes to safety in shipyards, this can be taken by any one of you. Safety in shipyards, I have been exposed to situations where the geo petrol pump has a problem of, naked flames is totally a no-no. So if manually, if the footages of video cameras were to be monitored, it's going to take a lot of time. So how is AI used in such kind of image processing applications? Is there anybody who could answer this, please?
Maybe I can start. There are two things, here. Safety is one is a culture driven. The second one is a technical way to address that. Of course, culture, we need to put more trainings for them to how it has to be addressed. When it comes to the technology, we can put cameras, but it's not supposed to be monitored by the people. There should be an application and which can process that information and tell safe or unsafe. Example, I did a previous one project for BPCL where the cylinders are filling, and if there is any leak, instead of seeing it manually, you put an infrared camera and capture the information, and then based that we processed with the deep neural network models, and we are going to say that is a leak or not leak. So that human, first of all, is completely eliminated unsafe regions where the human intervention, and also second thing, we can ensure that safe. Yeah.
Thank you. Basant, yeah, would you like to answer that?
Yeah, I just wanted to add one point that on such operations where we use AI for monitoring things, it also depends on whether how critical is the safety. That also is a concern, whether we completely depend on AI or we should put a checkpoint with a manual intervention. So with AI, we can always expect errors, however, it is strange.
That is true. So there was another question that I wanted to ask you. I know that your business is largely on the operational and maintenance side. So I was wondering that you may have 20, 30 years of data that is available, but in your presentation you mentioned that lack of data is one problem that you're facing. So can you please explain that?
Yeah, I was mentioning about the design data. But on the, we do both design and inspection and maintenance. On the design, there is a lack of data. But on the inspection and maintenance side, it is not like that. We have huge amount of data. Okay. And that data is very huge. We can use it for AI training processes.
Yeah.
So I will tell you an example. We have a service of risk-based inspection, where we utilize this thickness gauging data for predicting the residual life of plates and ships. Yeah. So this is completely a manual process traditionally using classification rules and thickness gauging data. Yeah. So we have started a AI-based process where this thickness gauging data can be avoided. This is a research and development project.
A subject of research and development in your own company.
Yes, yes.
That's great.
So the input will be the original thicknesses and the scan data.
Yeah.
So comparing the attributes,
yeah,
it will automatically.
That's thank. So I come to the end of this panel. We are left with 5 minutes. I am ready to take questions from the audience. If there is anybody, yes, please.
Hi, my name is Mohammed Abrar Saifuddin and I'm from Zeroco Solutions BV. So I have 2 questions. I will summarize it very small. So we have talked about CapEx and how it is very high to implement all the AI solutions. What about the OpEx part? How well are we equipped, or how does the price changes over the life product? When the demand increases, you will have much more things to do with AI, right? And the AI doesn't come out free. We have to implement so much things going back, even if it's token or if it's the infrastructure or the power itself, it's getting higher. So how does a company compute that or predict that? Part number 2, I heard about sustainability and AI in this panel. And personally for me, I find it very ironic since, yes, sustainability part is there, but we all know how AI data centers have been powered. And is there any alternative, or what are you looking forward to? Is it even a consideration at this point? Thank you.
So to whom is your question?
It's open to all, everyone.
It's open.
Yeah.
So as I understood, the question from Abrar, right?
Yeah. Yes, Abrar.
Yeah. Yes. So of course, he is aware about the CapEx, but what about the operational side? So the product companies here, do you have an operational model which you can say?
So our experience with implementing where sensors are put in and there is a command and control AI architecture that's built in, the cost savings outweigh any of the other considerations that you have, including CapEx. OpEx does not increase. The only thing that changes is that technology cost goes up, and which is typically in India, we are used to buying only an equipment. We are not used to buying technology other than for software services. So
I don't believe that the price changes. In fact, you get a better quality output and probably a better pricing outcomes.
So that's about the product. About software services.
So as I said, one of the key problems that we have is that if you start setting up data centers for everything that you need, you'll consume a lot of power. And that's where software companies like us, at least I can talk about myself, that how we have, have a partnership with NVIDIA and these companies to bring that processing power to you as a package where you don't have to spend, right? That's the first part. Second, on the CapEx versus OpEx, I have a little difference of opinion and I'll share my views probably. We can discuss it later also. Today, there is a certain mentality, a certain kind of a mindset that we have. We end up buying more, perpetual licenses. There's a perpetuity that you want to bring in terms of the software that you own, the asset that you own, which actually far outweighs the expense you would like to do on the project, right? Whereas the AI option or the cloud option gives you use on demand kind of a feature, right? For example, so if you want to use one of our features and you pay for those tokens, you use it, your work is done, and you're done with it, right? It is use as you need. It is not that you have to create a perpetual asset. Actually, creating a perpetual asset has far more cost considerations on your own organization, whereas a tokenized way of working, which is now how AI works, is actually a better way of working, which puts less cost pressure on you. So I've tried to answer both parts, the sustainability part, as well as the cost optimization on CapEx and OpEx. Thank you.
Thank you, Navdeep. Kumar?
So I agree with his approach, and just I would like to add one more point. For such solution, we should not take a big bang approach. We should identify the use cases and what are my critical use cases. We should try with small pilot, and we should see that and validate the value that I am realizing the value. Once my solution is proven, I should scale it up. So this is how we are avoiding the lot of spending, and we are ensuring that whatever spend is going to happen, I am gaining the value against my investment. So this is also one of the approach we should take while implementing the solution.
Thank you, Kumar. Any other questions from the audience? Yes, please. The mic, yes.
Hi, I'm from C2C as well. Just wanted to bring up a point. We deliberated some of the questions, and I think thanks to everyone here, we covered most of the things, and thanks to the panel as well. We just wanted to bring up one point which I think I want to keep it open, and it's on the slide as well, which was there. What about sanctions, right? I mean, while we talk about the sovereignty, the data ownership, everything has been covered, but we are missing one critical point, right? If there's a sanction, where are we with that? So that's something which...
You mean to say if our country is under sanction from...
For some reason.
For some reason.
Yeah.
So isn't it that it's imperative that we develop our own AI systems here with it?
Agreed, but are we there yet?
Yeah, that is a question. Yeah. Anybody would like to answer?
One of our main objective is to develop, we talk about Atmanirbhar Bharat, but most of the softwares we're relying on the outside. I think it's a time to develop indigenously.
Absolutely.
So that's where, and even my last slides also I said, develop a local and reach it to the global. So we're not limiting to only India. I think the world should look for us probably in the down the line 2 or 3 years. So that's a basic objective.
You want, as a last word, please.
Yeah, sanctions. Yeah, I agree with you. Is an issue, but I think it's an interconnected world. Even the Chinese have been able to overcome any impediments that they've had in acquiring whatever there needs to be had. I think that is definitely a problem, but I don't think that should be a consideration. More important is how do you collaborate with the world and see how to get the best and keep the data sovereignty in-house.
Yeah, thank you very much. So with that, our time is up. Ladies and gentlemen, this panel is closed. I bring it to close. So thank you very much for all of you.
Thank you to our chair and distinguished panelists for an engaging and insightful discussion. We will now proceed with the presentation of mementos. May I request our session chair, Mr. Anil Das NT, CEO and Managing Director, Conceptia Software Technologies Private Limited, to kindly present mementos to our distinguished panelists as a token of appreciation. I shall now invite each of our distinguished panelists to receive the memento as I announce their names. Mr. Jay Kumar Shah, Principal Marine Consultant, Aviva. Mr. Krishna Chandra, Chief Mentor and Head of Strategy, C2C Advancement Systems. Mr. Navdeep Singh Arshi, Industry Leader, Aerospace, Defence, Marine and Offshore, Dassault Systems, India. Mr. Basant Konat, Senior Director, Research and Development, Ares Energy. Dr. Giri Rajashekhar Gunnu, Founder and Director, Vaishvik Vertex Solutions Private Limited. Thank you, sir. May I now request Mr. Sojan Pivarki, General Manager, 21 Notes, to kindly present a memento to our session chair, Mr. Anil Das NT, CEO and Managing Director, Conceptia Software Technologies Private Limited, as a token of our appreciation. Thank you, sir. To commemorate this special session, I invite our panel chair and all our panelists to come forward for a group photograph. Once again, thank you all. We will now break for tea and networking. Please take this opportunity to enjoy your refreshments, connect with fellow delegates, and visit the Marine Expo stalls outside the hall. May I kindly request everyone to be back in Oman Hall by 4 p.m. as we reconvene for our second technical paper presentation session, Navigating the Blue Economy, Regulatory Evolution and Sustainable Innovation, proudly powered by Dassault Systems, one of our valued gold sponsors. Thank you and enjoy your tea break.
This is one of the most important event. As a maritime professional, I look forward to.
It is a privilege to attend this function.
The first day was a huge success.
I really want all of you to come for next day.
From food to trade and energy, vast and powerful seas have always been essential to our world's prosperity. But if we are to realize the full potential of the ocean economy, we need to rethink a more responsible and sustainable path. We need better, safer, greener assets. From smarter ships designed with high-performance hulls, new materials, and alternative propulsion systems, to offshore assets capable of harnessing new energy and natural resources. It is time to transform the marine and offshore industry, innovating new business models and processes, leveraging advanced simulation, analytics, smart automated manufacturing, standardization and modularity, bringing operational excellence throughout an asset's entire life cycle with digital continuity, by enhancing the real world with the virtual world. Dassault Systèmes' 3D Experience platform unleashes a new wave of innovation, empowering the next generation workforce with deep knowledge. From ideation and engineering to manufacturing and asset in operation, the entire value network is connected into a single collaborative environment, unlocking the true value of our oceans by harmonizing product, nature, and life. In a future made possible by virtual universes, experience the future today. From food to trade and energy, vast and powerful seas have always been essential to our world's prosperity. But if we are to realize the full potential of the ocean economy, we need to rethink a more responsible and sustainable path. We need better, safer, greener assets. From smarter ships designed with high-performance hulls, new materials, and alternative propulsion systems, to offshore assets capable of harnessing new energy and natural resources. It is time to transform the marine and offshore industry, innovating new business models and processes, leveraging advanced simulation, analytics, smart automated manufacturing, standardization and modularity, bringing operational excellence throughout an asset's entire life cycle with digital continuity, by enhancing the real world with the virtual world. Dassault Systèmes' 3D Experience platform unleashes a new wave of innovation, empowering the next generation workforce with deep knowledge. From ideation and engineering to manufacturing and asset in operation, the entire value network is connected into a single collaborative environment, unlocking the true value of our oceans by harmonizing product, nature, and life. In a future made possible by virtual universes, experience the future today. From food to trade and energy, vast and powerful seas have always been essential to our world's prosperity. But if we are to realize the full potential of the ocean economy, we need to
New sustainability regulations from the International Maritime Organization signal massive changes ahead for shipbuilders. Whether you're designing new ships or retrofitting an existing fleet, your next voyage is digital. Digital transformation means you can navigate IMO 2050 regulations while improving your engineering efficiency by up to 30%. You can cut the time it takes to model a retrofit by as much as 20%. And design digital twins to guide you in building safer, more efficient, more sustainable operations at sea. Digital transformation ahoy! Aviva will take you there. New sustainability regulations from the International Maritime Organization signal massive changes ahead for shipbuilders. Whether you're designing new ships or retrofitting an existing fleet, your next voyage is digital. Digital transformation means you can navigate IMO 2050 regulations while improving your engineering efficiency by up to 30%. You can cut the time it takes to model a retrofit by as much as 20%. And design digital twins to guide you in building safer, more efficient, more sustainable operations at sea. Digital transformation ahoy! Aviva will take you there. New sustainability regulations from the International Maritime Organization signal massive changes ahead for shipbuilders. Whether you're designing new ships or retrofitting an existing fleet, your next voyage is digital. Digital transformation means you can navigate IMO 2050 regulations while improving your engineering efficiency by up to 30%. You can cut the time it takes to model a retrofit by as much as 20%. And design digital twins to guide you in building safer, more efficient, more sustainable operations at sea. Digital transformation ahoy! Aviva, we'll take you there. New sustainability regulations from the International Maritime Organization signal massive changes ahead for shipbuilders. Whether you're designing new ships or retrofitting an existing fleet, your next voyage
Namaskaram from Singapore. On behalf of SAFE Ship Academy Far East, I sincerely express my wishes to Dostas for conducting this event.
On behalf of MAST, the Middle East Alumni
This is one of the most important events. As a maritime professional, I look forward to.
It is a privilege to attend this function.
The first day was a huge success.
I really want all of you to come for next day.
Ladies and gentlemen, may I have your kind attention, please? We will be resuming the program in 1 minute. May I kindly request everyone to make their way back to Oman Hall. I would also request all the delegates sitting behind to please come forward and fill all the vacant chairs and sofas. Ladies and gentlemen, we now begin our second technical paper presentation session, Navigating the Blue Economy, Regulatory Evolution and Sustainable Innovation, proudly powered by Dassault Systems, one of our valued gold sponsors. This session explores sustainable practices, evolving regulations, and innovative solutions that are shaping the future of global maritime industry and blue economy. To moderate this session, it is my pleasure to invite Dr. Sadish Babu PK, Associate Professor, Department of Ship Technology, CUSAT, a distinguished naval architect, former Indian Navy commander, and researcher whose expertise spans ship design, marine hydrodynamics, corrosion engineering, and sustainable maritime technologies. Ladies and gentlemen, please welcome Dr. Sadish Babu PK. Welcome, sir. May I now invite Dr. Abdul Rahim, Commercial Director, Executive Ship Management, Dubai, an internationally renowned maritime professional with over 3 decades of leadership in classification, ship management, and maritime research, whose work focuses on decarbonization, alternative fuels, and energy efficient shipping. Ladies and gentlemen, please welcome Dr. Abdul Rahim. Welcome, sir. Next, may I invite Mr. Sunil Kumar K, Naval Architect and Advisor to the Board, Capital Register of Shipping, a distinguished naval architect with over 3 decades of global experience in shipbuilding, marine service, regulatory affairs, and maritime management systems. Ladies and gentlemen, please welcome Mr. Sunil Kumar K. Welcome, sir. Next, may I invite Mr. Amit Kumar, co-founder and Chief Technology Officer, Syracuse Solutions BV, a marine engineer and former chief engineer whose expertise in maritime data analytics and digital platforms is advancing vessel performance optimization and operational efficiency. Ladies and gentlemen, please welcome Mr. Amit Kumar. Welcome, sir. Finally, may I invite Mr. Pranav Sharma, Senior Surveyor Class NK, who will be presenting a technical paper authored by Mr. Hirobomi Kaneko, Strategic Advisor, Research and Development Division, whose research focuses on underwater radiated noise, maritime sustainability, and advanced technologies for naval platform. Ladies and gentlemen, please welcome Mr. Pranav Sharma. Welcome, sir. I now have the pleasure of handing over the session to Dr. Sadish Babu PK. Sir, the session is yours.
Okay, good afternoon, respected speakers, others. Ladies and gentlemen, it's my pleasure and privilege to be moderating this session, which has 4 excellent papers. As you know, DIMS, we had a number of panel discussions, technical paper presentations, but I think, sir, it is complete only if you talk about the regulatory aspects, the sustainable practices. So in this context, the theme of this technical paper session is navigating the blue economy, regulatory evolution, and sustainable innovations. So we have 4 distinguished speakers. Sir, let's keep 15 minutes each per session for presentations, and after that we'll have a discussion, or we can open up for questions from the audience. And so we'll have a question answer session at the end of all presentations, sir. Is it okay, sir? Can we start, sir? Okay, so let's start the session, and it is my privilege to welcome the first speaker, that is Dr. Abdul Rahim. He's a senior naval architect. He has authored more than 120 technical papers, got more than 30 years of experience in Class NK. He has been chairman of NAPA, and the paper title is Green and Sustainable Shipping Technologies, Pathways to Decarbonization and Operational Efficiency. Over to you, sir.
Good afternoon, ladies and gentlemen. So today I'll be talking about pathways to decarbonization and operational efficiency. I work for a ship management company, Executive Ship Management, and I am based in Dubai. And there are several decarbonization pathways, and it requires both operational improvements and radical technological innovation. So I have listed 6 of the main pathways here, and I will be talking today about the top 3 ones. That is adoption of low carbon and zero carbon fuels, vessel energy efficiency enhancement, and renewable assisted propulsion systems. And of course, there is no single solution to fully decarbonize shipping. Integrated systems and hybrid energy architecture is preferred, as you have seen in the previous presentations. They were discussing about that. And of course, ultimately, from the ship owner side, cost is the biggest concern. Now let me go into the alternative fuels. So here I have listed 3 fuels, LNG, LPG, and methanol. These are not zero carbon fuels, but these are kind of alternative fuels that will keep the show going until we have fully fledged zero carbon fuels. And as you can, why I'm called them transition fuel is, as you can see, the carbon emission, CO2 emission per unit of heat is, if you use LNG, it can be reduced only by 25%. LPG by 15% and methanol by just 10%. So you are not completely avoiding that. And of course, some of the volume, LNG is a little high. And from the safety aspect, flammability is one of the major concerns for all. And for LNG, the cryogenic property, because it's minus 253 degrees centigrade, you have to tackle with that. And for methanol, it is toxicity. Now, these are the 3 real zero carbon fuels. One is hydrogen, next is ammonia, and then biofuel or carbon recycled fuel. And their CO2 emission is 0. So they are truly zero carbon fuels, but the liquid fuel volume, as you can see, for hydrogen it is 4.5 times, ammonia is 2.8 times. And of course, if you look at the 4th line, that is the production cost, by 2030, we are expecting hydrogen to be about 3 times that of very low sulfur fuel oil. And by 2050, we expect, because of the volume production, it can be 1.8 times. And ammonia is, 2030, it's about 1.4 times the production cost. So it's very costly fuel. Now, some of the other technologies that we are using, one is the wind-assisted propulsion. There are different types, sail, rotor, kite, then electric battery propulsion, and of course the carbon capture device. Carbon capture device is getting traction because as of today, more than 50% of the ships on order run on fuel oil. So that means these ships have to run for another 20 to 25 years. By then all the regulations kick in. So for these ships to run, they have to have some kind of a method to reduce the CO2. So carbon capture is one of the best solutions available. It can reduce the carbon dioxide by about 80%. Now, I will come in a little bit detail about the wind assisted propulsion later. Now, if you look at the order book, of course, top is LNG, 1,450 ships are in operation, and about 1,200 ships are on order, and total fleet size is about 2,650. This is followed by battery, electric, and hybrid. Of course, these are small vessels. And then we have methanol. Methanol ships on order number is quite high, 420. Now, coming to the shipbuilding cost. As you can see, cost can vary anywhere from 10 to 20% extra. For LNG, for a standard LNG carrier, it's about 20% more. Because if it costs about $100 million for the ship to run on LNG fuel, the capex will be 20 million extra. So this is one of the main factors what is holding the owners from ordering these kind of ships. Now, the cost of regulation. As you know, European Union's ETS and FuelEU Maritime are already in place. And for ships which doesn't meet the standard, you have to purchase the allowances. And if you look at the price on the right side, as of today, it's about 80 euro per ton of CO2 if you want to buy. And it is likely to go by 2030 to about maybe 120, and it keeps on increasing. This is a prediction by the European Energy Exchange. And the last item, the IMO midterm measures, as you know, it is in doldrums because of the postponement, because some of the countries, especially the oil producing countries, Saudi Arabia, UAE, they are totally against, of course, including US. So that we have to see where it goes. Now the share of alternative fuels for new building as well as in service, as you can, the trend is the same. LNG is the main alternative fuel, and followed by methanol and LPG. So these are, as I mentioned before, the transition fuel. And of course, the ammonia and hydrogen fueled ships are slowly picking up. Then this is an important table, fuel saving of energy saving devices. Suppose you can save energy, and how much does it cost? And extreme right column is the return on investment in number of years. So the low-hanging fruits like weather routing, performance monitoring, or trim optimization, in a couple of months, you can recoup your investment. And some of the low-hanging other fruits are the Mavis deck, pre-swell, fairing devices, and the twisted rudder. All those things are about 1 to 2 years return on investment. And at the last two columns, if you see the air lubrication system, the return on investment is about 4.5 years, and rotor sails may be about 9.5 years. So that means the lowest two ones are not applicable for older ships, possibly younger ships, or for new building ships. These are applicable. Now this is the saving versus cost impact of some of the items. So right from improved cargo handling, the pre-swell device in the middle, to optimized turbochargers. And these are actual data obtained from ships that we have. For if you fit the pre-swell device, it can cost from $100,000 to maybe $500,000, and the fuel saving can be up to 10%, because the current level of fuel cost may be $600 per ton. So that's a huge saving you can get. Then these are some of the others like shore power, high efficiency radar, and on the extreme right is the carbon capture system. Of course, it can save 80% of CO2, it can save, but the cost is in the double-digit millions, maybe 8 to 12, $15 million. So this you have to put when the ship is either very young or its new building stage. So these are some of the energy saving devices that's actually fitted on board the vessel. The first one is the carbon capture system. That is the world's first carbon capture system installed on board a bulk carrier. And then you can see the pre-swell device, radar bulb and fin fitted onto another vessel. Then bottom left is the propeller Bose fin cap. And the right side you can see the air lubrication system. Then coming to the wind harnessing, hard sails, rotor sails, wing sails, kite systems, the saving can be anywhere from 4 to 30% depending on the methods that you use, the trade route, and so on. And again, bottom you can see the vent-of-fill suction fins fitted onto a chemical tanker. This is one of Executive Ship Management's tanker. And you can see the 4 suction wings, and on the next one you can see when it in the folded conditions. You can fold it for the cargo operation. Then we have the hard sails on an LNG carrier. This will be delivered this year. These are 2 collapsible hard sails. It's part of the Wind Challenger project in Japan. And at the bottom right, you can see one of the bulk ships' wind wings, which could get up to 8 to 10% saving. Now, if you look at the summary of the energy saving devices on ships, onboard carbon capture system, totally about maybe 60 units. And if you look at the bottom of the energy saving devices, the low hanging fruits are already applied in 27% of existing vessels, and 31% of the vessels on order will also be fitted, because it's very easy to fit it and low capex. Then I would like to introduce one ship energy efficiency monitoring system. This is developed by Samudra Institute of Maritime Studies. It is the Maritime Training Institute of Executive Ship Management. For the last 2 consecutive years, this was adjudged the best maritime training institute in India. So this system is a fusion of hardware and advanced software algorithm. It maximizes the onboard energy efficiency and minimizes the fuel wastage, because the real-time operational and maintenance data is processed and which is visible to the captain or chief engineer to make corrective action so that you can save fuel. And some of the features of that one is it shows the main engine thermal efficiency, propulsive efficiency, hull fouling indicators, and it shows real-time CII values. I will come to the next slide. And operation-wise real-time adjustment of main engine RPM for best CII, and again real-time adjustment of trim is possible for best CII. So it's a helping tool for the captain or chief engineer to operate so that we can save fuel. So these are some of the slides. The left one is the opening screen. It actually shows the CII as instantaneous CII is the bottom right, then CII or that particular voyage, and CII year to date, and CII year to date compensated. So all the values are readily available. So based on that, they can tweak the engine. And on the right side, it's a diagnostic thing. That is the second menu. It actually gives you the thermal efficiency and propulsive efficiency. So depending on that, the chief engineer can adjust. You can see on the bottom left, it shows the fuel loss. So at this condition, it is about 0.14 metric tons per day. And so they can tweak the running parameters so that can be saved. And this particular system was granted patent by the government of India, and Class NK has issued the innovation endorsement certificate for this product. So this is applied on some of our ships on a trial stage. Yes, we have everything, but there are a lot of challenges to sustainable shipping. So I have listed some of the top 10. One is transition away from fossil fuels. As I told you, the ships built today, more than 50% are running on fossil fuel, and they have to run for another 20 to 25 years. So it is difficult to take them away from there. So that's a big challenge. Then high upfront cost, because all the equipments as well as the installation cost is pretty high. Then limited infrastructure. That is, you have the fuel, but you need the bunkering facilities, and you need effective distribution of all this. And at present, I think LNG has started nearly 10 years ago. Still, LNG bunkering infrastructure is available only in a very limited number of ports around the world. So just think about hydrogen, methanol, LPG, everything coming into picture. So where do you have the infrastructure to bunker them? Second one is regulatory complexity. As I mentioned before, we have EU ETS, FuelEU Maritime. Unless IMO comes out with a common standard, everybody will be having their own systems, because now in Djibouti is going to start the EU ETS kind of system. UK has already started. Then China is going to start, because you can easily get money by taxing the ships. Then decarbonizing existing fleets. because existing fleet, as I mentioned, they're running on heavy fuel oil. You have to decarbonize that. Then supply chain pressures. In the earlier panel discussion, they were mentioning about supply chain. That is the true problem, especially now in flashpoints like maybe the Ukraine war or the Middle East crisis. Supply chains are completely shattered. So I think in the previous panel, somebody was mentioning we are getting all the turbochargers from Ukraine and we cannot get it now. The engines. Then technology maturity, that is okay. Technology will mature till we have technology, and it's only a couple of years before we get these engines. Then environmental impact beyond carbon, we have sulfur, particulate matter, and other impurities. Then most of all, global coordination and collaboration. Everybody in the world, including financiers, bankers, ship owners, shipbuilders, classification societies, shipyards, everybody has to come together and pull in one direction if we have to have sustainable shipping. And then finally, financing and access to green capital. Thank you very much.
Thank you very much, sir, for the excellent presentation. I think your findings suggest that a multi-technology approach combining fuel transitions, operation optimization, cost are essential for transformation of global shipping. That I think you have brought out the entire thing and supported by data. I think that makes it more interesting and a lot of research ideas for the young people sitting behind. Thank you, sir. So let's move on to the second paper. That is by Mr. Sunil Kumar Kuttappa Panikar. He is a senior naval architect with lots of experience. So your paper title is Regulatory Pluralism in Global Shipping, a comparative analysis of self-regulation, state oversight, and co-regulatory alternatives. I request you to kindly present your papers.
Good evening, everyone. Thank you for having me here, and thank you, Dr. Sadish, for his kind words. I have about 16 slides. I would try to rush through it within the limited time. I'm here to talk about the regulatory pluralism in our industry. The last 2 days, you have been hearing a lot of positive things about how technology and innovation is galloping forward. Mine is a little bit negative tone. I'm trying to see how our industry is lagging behind in this technological race. And why is it so? And while doing so, I'll compare it with another peer industry, which is aviation. So over the last 30 years, I think the certification and documentation requirement has almost tripled, and making it more complex and overwhelming for the operators and crew. Why is it important? Because we can be all proud to be a part of an industry which is a lifeline of global trade and economic. And it is governed by IMO, which is the UN wing for maritime trade. So over the years, IMO has come up with about 50 treaties covering various aspects of shipping industry. And it is a quite robust and matured regulatory framework. However, it has some flaws, and that is what preventing it from keeping pace with the industry. I'll also examine if, while progressing towards a smart regulatory network of risk-based and goal-based system, whether we can emulate the aviation industry. So to do so, we have to see the philosophy of a regulatory framework. A regulatory framework is a set of tools with which states or governments monitor, control, and regulate the business activities to protect the interest of the citizens under their jurisdiction. So if you see the spectrum of regulatory framework, it's from the very left of hard law, which is more prescriptive, and the command and control structure, and enforcement system, to the right end where it is a very soft law, which is more towards self-regulation and a free market economy. And the regulator only provides minimal oversight with information, education, and guidance. So IMO regulations, or our maritime regulatory framework, is more towards the hard law. And understandably, it has to be so because of the complex nature of the shipping now worldwide. More than 120,000 vessels of over 100 GRT are trading, not to count the fishing vessels and other vessels. So it needs to be on the hard side, but at the same time, we have to progress towards a middle path, because enforcement and compliance comes with a cost and time. So to avoid or to more economical path, we can even go to the extent of borrowing from the automobile industry, which is customer driven, like our BNCAP program of a 5-star rating in safety, which allows people or the customers to be the choice makers. But this precision and hard law is what makes it difficult to amend or come up with a solution for the fast-paced economic and technological development. So IMO regulatory architecture, I said it's about 50 treaties covering various aspects of shipping, but it is founded on 3 main pillars, which are SOLAS, dealing with the safety of life and property, and MARPOL, which is dealing with the environmental protection, and STCW, which is dealing with the human element, And IMO does not have a direct implementation or enforcement program. It enforces its regulatory structure through 2 paths, which is one is flag state control, which is countries regulate the ships registered under them through various regulations, and the other one is a port state control. If the vessel comes to your jurisdiction, you can enforce control by inspecting and probably detaining or restricting the ship. So there are a couple of structural flaws in this system and what made it slow and not being so proactive. One is slow rule making. Typically, a new convention or an amendment or a new code can take over a decade from the conceptual stage to implementation stage. For example, the Marine MAAS, the Marine Autonomous Ships concept was presented in 2017. It's just now they have come up with a non-mandatory regulatory structure governing those. But at the same time, the industry is galloping forward, and for example, the free fall lifeboats were invented in last decade of the 19th century, but it was not made it mandatory for shipping until the end of the 20th century. There are also political and economic compulsion which forces the IMO to go slow or even hindering blocks on the sea. The powerful or politically as well as shipping-wise powerful players in the field, they try to manipulate the way which is the rules are formed. Secondly, the compliance is not uniform in the sense that it is not universally, equally, and uniformly applied. For example, the MARPOL regulations need reception facilities to be installed in your jurisdiction. Many of the developing countries find it hard to have that infrastructure, so they don't sign into this, become signatories to this conversion. Open registries like Panama, Marshall Islands, and Liberia, they provide about 50% of the budget of IMO. So they have a big clout over there how the proceedings are done. And when it comes to a fleet, their fleet being economically affected, they do put some foot down and kind of stall the regulation. It has happened with the double skin bulk carriers. Even after research found that it is to be effective, finally they had to settle for a double hull carriers only for a limited option. And unfortunately, the data related to maritime incidents and the lessons learned are stored in silos, where each entity which have the data are unwilling to share it, probably because of the competition, probably because of the blame culture which is in the industry. So there is no universal database where the industry can learn that and make regulations from evidence-based system. And the other one is the legacy risk and phase compliance. Most of the big amendments need retrofitting and major modifications, so it kind of discourages IMO from implementing it on a retrospective aspect and mostly applying to the new buildings. So a prime example is even after single hull tankers were found to be unsafe and major accidents like Exxon Valdez and all, but they had to give a phase out time for the single hull tankers over about more than a decade or so. So here is a question of risk being identified and still the risky or the risk-prone vessels are allowed to trade. And the constraints in enforcement. As I said, the enforcement is mostly through port state control and flag state control. But port state control, many of the countries with lower resources or economically backward countries are not able to provide the resources to run a effective port state control system. So you'll find that the port state control is mainly confined to some regions like European Union, Far East, and Americas. So I'll have a small comparison with the maritime and the aviation quickly through. One is the governance and sovereignty. Most of the flights are from point to point, originating in one country and terminating in another country, and both the countries have a say in the regulatory control of the system. But whereas shipping mostly is high seas and with an open registry, the vessel is registered in one flag and operating all over the world. So it becomes complicated and difficult to control this thing. Second one is the profile of aviation accident is so high that it catches the attention of the whole world, and the remedial measures are quickly initiated. Whereas even with the biggest of the pollution incidents, they don't get the public attention that they deserve, and this results in a slow regulatory reformation. The operational model. Most of the commercial aviation industry is operated, owned and managed and technically managed by one entity, whereas in shipping it can be 4 or 5 entities sitting in 4 different countries. There is also a huge difference between the safety program in ICAOs and IMOs. ICAO's Safety Management System program comprises of, from the top to bottom, from the flag state until the designers and manufacturers, including operators and airport providers. Whereas in IMO, the ISM code is applicable only to ship management or ship operating entity. In aviation, you have the authority to ground or detain aircrafts and recall them from the service, but in IMO, there is no such provision of recalling or grounding vessels which are found unsafe. There is also stark difference between the certification regime in aviation and maritime regarding the personnel and the components, maintenance and components. In aviation, all the aspects are covered by the system, regulatory oversight, but in maritime, unless it is a major structural or critical machinery repair, the regulator hardly involves in it. In aviation, again, the revalidation and the training of the personnel are quite frequent, typically like 6 to 12 months, whereas in competency revalidation in Maritime or Seafarer is about over 5 years. And in aviation, you can have your competency restricted to certain type of aircraft which you have flown, whereas in Maritime, there is no such restriction unless it is a high-speed craft. And it also has a compulsory retirement after 65 in aviation, whereas in in Maritime, there is nothing. So some of the major incidents point towards the need to have a design with safety as the objective. Ever given the vessel which was stranded and grounded in Suez Canal, which is also a big container ship, similar to Dali, which was involved in an accident in USA, hitting the bridge structure. So in both cases, it was evolved that the bank effect, so-called bank effect, was one of the prime reasons where it drifted and could not be controlled. But I may be wrong, but I'm not sure if this is being taken into account while defining the mega-sized container ships. The Dali accident also pointed out to what I was mentioning before, of the lack of maintenance oversight, where a small flushing pump was involved in the blackout of the generators, which finally led to the accident. And NTSB had proposed that IMO should follow the ICAO safety management system. So obviously the need is to progress towards a smart, goal-based and risk-based system, which are cost-effective, have cost efficiency, timeliness, that is keeping pace with the technology, transparency, though that all the players are aware of consequences and limitations and why it is being regulated, and accountability, where regulator also is accountable as much as the regulated. I think most of you must be aware of the goal-based standards and the formal safety assessment, which is a step towards this smart regulation, where IMO is only involved in the top tier of the setting up the goals and functional requirement, whereas the industry players and class societies and flags are free to come up with solutions and measures. This, along with the IMO formal safety assessment cycle, is a step towards smart, goal-based and risk-based systems. Again, in the goal-based and risk-based system, only the goals are set, and the designer and the engineering team are free to come up with solutions as long as they can prove the safety levels are same. It is also more oriented towards the human-centered, because aviation and maritime industries are heavily human-centered, so these need to be taken into account the behavioral patterns and this human element while designing new regulations. There are some examples which I unfortunately have run through that, where the prescriptive approach compared to a risk-based approach is found to be wanting, because it is either it is in a go or no-go situation, whereas in risk-based approach, you find it a cost-effective solutions. So my recommendations are go for risk-based smart solutions and goal-based solution. And it is proven that when the people are convinced, which is called a normative compliance, the other one is an instrumental compliance, where you force people to do something. But once they understand the philosophy, they will voluntarily comply, and broaden the participation in rulemaking for whole industry, starting from designers, seafarers, and port operators in having a say. Extend the safety management system for the full value chain. Expand the GISS, which is the IMO's data base, to include real-time data and make it mandatory for data sharing. And adopt safety case system, which is prevalent in the offshore industry, and human reliability assessment in making new regulations. In conclusion, the present framework, I wouldn't say it is bad, but it is a robust and time-tested one. It has stood the test of time, but structurally slow and uneven. So we need to come up with a mid path where I mentioned it is more risk-based and goal-based. And it should be data supported by evidence and data. With autonomous ships, alternative fuels, digital twins being involved in the real-time measurement of the parameters, the pace of technology is something we cannot hold back, and it's not a question of choice, but more of a question of survival when it comes to regulation, keeping up with the regulation. Thank you all.
Thank you, sir, for the excellent paper. I think it was a very brave paper. We hope the policymakers will take note of it. I think your comparison with the aviation sector is also quite interesting, sir. Thank you. Okay, let's go to the paper number 3. It will be presented by Mr. Amit Kumar. He's a co-founder and chief technology officer, ZeroQ Solutions BV. He's a very experienced marine engineer, in fact, chief engineer who sailed in Maersk for several years. The paper title is Hull Performance 2.0, a predictive data-driven framework for quantifying fouling exposure and performance degradation in modern shipping. Sir, kindly present your paper.
Yeah. Good evening, everyone. So today my talk is about the costs sitting under every hull of a vessel of a fleet, but doesn't get measured in the real time. And this talk is about the Hull Performance 2. And I'm very thankful to DIMS 2026 for having me here, which is a work of last 1.5 years and back tested to 700 ships. So this is a predictive data-driven framework for quantifying the fouling exposure and the performance degradation. So first, what I will do, I will quickly run through some of the numbers, then why it is important now, then what problem we are solving, and what is the core idea behind this study framework. Yeah, so what number you see on the screen is up to 1.2 million USD per vessel per year. And this is for a moderate medium size of bulk carrier. And that's the maximum avoidable cost from the fouling alone. Let me explain to you how did I get this number. So a moderate fouling would raise the 7 to 10% of shaft power or the propulsion power, and to keep the same service speed, the vessel has to burn around 20 to 30% of higher fuel, and which will result into higher greenhouse gas intensity. But the industry is not in the denial state. Everybody knows that the hull fouling causes extra fuel consumption. But what is missing here is quantification. And that's the gap I'm trying to solve here, close here. Then the important question also came to my mind while I was doing this research work, that why the hull performance is very important, So everybody knows there is a maintenance cost, but And this was last 5 years back, if you talk about it, it was only the maintenance cost. But now the things have drastically changed, and that is the regulations. So CII rating, there is an annual rating pressure on every vessel in a fleet. Fuel EU Maritime, greenhouse gas intensity penalty on energy used on board. EU ETS, every tons of fuel now carries the UA allowance. And from July 2026, we also have UK ETS. IMO biofouling guidelines, also a binding framework ahead. So put it simply, the hull condition has moved from maintenance line item to a line on the compliance balance sheet of every company. Now, so then again, what problem we are solving? So the way the industry manages the hull performance, hull biofouling today has a 7 systematic blind spot. The first one, fouling growth is mostly gets underrated. Capex-led coating choices sacrifice the OPEX. Propeller fouling is treated as a secondary issues. And the most important is the weak data infrastructure and baselines. Speed and trim is not optimized to the fouling state. And then sometimes the weather resistance is misread as a fouling. And then there is always a fight among the 3 important stakeholders of a company: technical, operation, and commercials. Most of them work in silos. So here is the thing. Fouling is not a fixed interval phenomena. It is dynamic, we all know. It is environmentally driven and vessel specific, because every vessel travels in different temperatures, salinity, idle time, niche area will be different, coating will be different on every ship. So what's the root cause? The root cause is the exposure story and the performance story are never linked together. Now this is the core idea of this research work. So there are 2 stories here: exposure stories and performance stories. Exposure stories is mostly dependent on environmental and operational drivers which vessel encounters during the journey. And the performance story is the speed loss, power increase that result. Exposure story give me an index which is called fouling exposure index. You may call it a risk factor. And when both of them are studied together, then it gives a very meaningful result, which I will show you in next slides. So this is the framework of this work. So everything starts from the data layer. What are the data layers? Known reports, onboard sensors, AIS feeds, and the voice segments. This data layer is fed into the 2 engines which runs parallel. The exposure FI engine, what it does, it normalizes the exposure and mitigation drivers. Then there is a hybrid AHP entropy weightage, and the end result is we get a final FEI. And we categorize this FEI into low, medium, high, and critical. And then the performance engine, we have a gray box model. We often see that the ship in its entire life cycle goes through the many modification. Sometimes the sea trial curve is not the correct representation of today's, the ship structure. So we collect the most important data of the vessel and we make a gray box model. Then we apply the ISO corrections and we derive 2 important factors: speed loss and power increase. The end result, outcome of these 2 engines is fed into the decision engine. What it does, it compares the values of both the engines. It gives a cleaning window scenario. It gives a clear message to the operator: when should you clean it? If you delay, what's the impact? So there are 7 steps in this workflow. Collect the data, transform it, because every data will have a different unit, so you have to bring them all to the same platform with transforming them, then weight it, compute API, have a right baseline, correct it, and then predict and act. Then exposure engine, how it works. As I said, there are 5 main drivers for the exposure engine. Idle ratio. Idle ratio is basically how much vessel is idling as compared to her speed. Anything below 4 knots, we consider idle in this framework. Sea surface temperature, salinity, region and season risk, and niche area. Everything gets a score, all these parameters have a different units, so we normalize them to 0 to 1. And then there is a management overlay. Management overlay is basically every vessel will have a different type of coating. So what are the effectiveness of different paints? What are the hull husbandry activity? When was the vessel docked? When the vessel was clean, propeller was clean, all these gets a number. And we combine, then we feed this into a hybrid machine, which is AHP, based on AHP, analytic hierarchy process and entropy. That gets weighted, and then it gives a final FEI score. Then the performance service. So we prepare the model, physics model of a vessel based on the first principle, and it's called gray box physics based model. And we also prepare for, the CPP propeller, because it's a combinator mode and RPM mode and everything. So all gets into the modeling. And then we apply the propeller B series data, and then hull propeller thrust matching is done. Now we have a FEI, we have a physics-based model. So then in the decision engine, it fuses the 4 signals: speed loss, power increase, cumulative and leg FEI. And then it gives a final score. We also calculate the impact of the hull fouling, and then we forecast. We also link the vessel scheduling system to the platform, so the engine knows that when is the next port, and it can also give you a fair idea which is the most convenient place to have your hull activity done. A typical example would be like this. So you see the green curve, that's the exposure story. It's rising up. And if your hull fouling is saying that, okay, I am into the area where there is a huge high risk of falling, then ideally you should see that your vessel speed percentage should reduce, decrease, and power should increase. We also validate the speed percentage with other parameters also. Speed percentage based on fuel consumption, based on power, and all. So this degradation, you could see, we already in the month of November, we started seeing the divergence. And it gives a clear message to the operator that your hull has started falling. So if operator acts faster, then we save the fuel for next 5-6 months, and it gives a good decision-making engine. Now what's the value it creates? There is an operational benefit of 10 to 15%, fuel savings and greenhouse gas reduction, and it also reduces the unplanned off-hire. Sometimes for hull cleaning, you have to off-hire your vessel, you don't find the right ports. There is an economic benefit also, from 0.3 to $1.2 million per vessel per year. And the compliance cost, we save 3 to 7% on CI rating improvement, and up to 40% less time in the high-risk zone. So what's the key takeaway from this work? The fouling is quantifiable, and it is a board level cost, not a maintenance afterthought. The FEI links exposure to performance, and it is a repeated process, and it can be scaled to any number of vessels. ISO 90030 correction turns the noisy data into meaningful signals. And this is one of the highest ROI, lowest capital intensity decarbonization solution. Thank you. And if you have question, we'll take it at the end. Thank you.
Thank you very much, sir, for the excellent presentation. I think the term you coined, fouling exposure index, is a new one, I think. Anyway, good. So thank you once again. Okay. Now, let's remain underwater for some more time. The next paper is on guidelines for underwater noise from ships and trends in the IMO, etc. It is authored by Mr. Hirobumi Kaneko, Strategic Advisor, Research Institute, R&D Division, Class NK, Japan. And the paper will be presented by Mr. Pranav Sharma, who is a Senior Surveyor, Class NK. He's a IIT Kharagpur Naval Architect. So, we welcome you to make the presentations.
Good evening, everyone. I would just skip the introduction because Dr. Satish has already introduced myself as well as our strategic advisor, Mr. Hirobumi Kaneko, on behalf of whom I am presenting these guidelines which have been developed for a reduction of underwater noise generated by ships and the background information regarding the IMO requirements on the same. So broadly, we will be following the flow of the presentation would be the impact of marine life, why the underwater noise generated by commercial ships, how it matters, what are the environmental impacts. Then we'll get into the physics of how the ship noise is generated and the IMO framework, which has been evolving over almost the past 2 decades now, since it was first introduced by US back in 2008 about these concerns. Then there are class society guidelines which have been developed by Class NK, and also because this has already evolved into a guideline by the IMO, the other classification societies have also come up with their relevant guidelines about the same. Then there are global research and incentives, initiatives by various countries across the world, what they have been doing individually in this direction, the research initiatives as well as the implementations. And the last, which will be tying down all the 5 aspects, would be the Class NK response based on all the above aspects, which are going to, in the near future, they're going to impact the way we are designing ships or the way we are operating them. So, ship noise, how it is a recognized ocean pollutant since the early 2000s. This has gathered considerable concern. Most of the noise produced by the ship is a low frequency noise. So this noise will not attenuate, scatter, rather it would travel tens of kilometers. It would continue propagating through ocean sound channels. So this leads to a behavioral change which leads to communication disruption, disruption of foraging by the marine species, which get directly impacted. And in the worst cases, this also leads to damage of the auditory organs of the marine species. So this also causes, there have been cases we keep coming across, whales beaching themselves, dolphins leaving the seas and coming onto the beach sides, abandoning. So now The figure on the right, it's basically the low frequency hearing ranges of the species which get affected. Of course, the names are scientific. And if you see the last one, the large ships, so basically it refers to the blunt ships, which are merchant ships. The frequency of noise generated by them, the golden one, it also overlaps with their hearing ranges, and that's how the marine life gets impacted. So basically the noise generated by ships, these are the propeller noise and the structural noise. Propeller is caused by the cavitation as the bubbles grow and then collapse. And then there is also tonal peaks when the blades pass through the top. So there is a broadbide noise and the collapsing of the cavitation bubbles. And this is the worst on the large hulls. Most of the Japanese vessels are blunt ships, large merchant vessels. So, and otherwise also cargo ships across the world. So, and then there is also structural noise, which is caused by engine vibration and also auxiliary machinery's vibrations as they run. So in case of warships or research vessels, usually the structural noise and even the propeller noise, they mitigate it by various measures. And let's say one of the things how they mitigate structural noises by putting flexible mounts, dampeners, or using electrical drives. So in those areas, the structural noise gets mitigated. But in case of merchant vessels, even that, the placement of the equipments, relevant equipments and main engine, that is on the hull, and it leads to hull vibration and noise generation. So one key nuance is if you reduce the speed of the propeller, you might reduce the propeller noise, but then the structural noise starts becoming evident. So overall, the effect is not so positive. So the regulatory history goes as 2008, US proposed these URN guidelines, but they were not made mandatory. 2014, the first IMO guideline came up, Circular 833. So this was not voluntary, this was voluntary, sorry. Very few large merchant vessels actually looked at implementing it. Then there was a review launched at IMO, MEPC 76/2021, plus there was a glow noise partnership which began with 6 lead pilot countries, India also being among them. So thereafter, upon the review during MEPC 2023, a revised guideline, Circular 906 was introduced, which was applicable for all ships, and the stress was on URN management plans, and that is underwater radiated noise management plans. So presently we are in the experience building phase, which was supposed to stop at December 2026, but it has been, more feedback is required. So this, collecting of data and feedback and experience building phase, it has been recently extended till the end of 2028. So between 2014 guideline, that is Circular 833 and Circular 906, basically there has been, previously it was a voluntary guideline, so we're just comparing this. So now the new one, the 906, it applies to all commercial ships, new as well as existing, introduces the URN management plan. Previously this was confined only to designers, makers and operators. Now IMO wants to bring this into also the flag states and class societies into the picture to how to implement this. So previously this was about, there is an ISO standard for the measurements which are based in deep water, but then there is a cost aspect involved. So 833 that deals with ISO 17208 1 and 2 standards, and now shallow water management based on ISO 17208 3 standards have been brought into picture during the 2023 guidelines. So the approach is baseline, target, approach, monitor. So it's an iterative process. So URN management plan, it's a 4-step cycle. Step 1 is baseline, determine the ship's URN baseline. Step 2, set the reduction target, then choose the reduction actions as step 3, monitor and evaluate, if required, improvise. So role of class societies now, it is to assist owners, builders through the entire, every single step. Prediction, trials, URN notations and certification, participation in every step. So this is excerpt from the guidelines developed by class NK. So standard basis based on ISO 17208. And basically we can refer to the figures on the right. Figure 2, it shows a caustic center would be the popular location. And this is in deep water, so the length for the water depth is 150 meter or 1.5 times the ship length, whichever is greater. And there is an error course, hydrophones at a particular distance, 100 meter or overall ship length, whichever is greater, and then 3 hydrophones arranged at specific angles. And the next figure shows how it is measured. So from this forms an angle like a ship, it is measured twice. Twice on the port side, twice on the starboard side as the ship passes. So it is measured between -30 to +30 degrees. And then the ship makes a Wilhelmsen turn, comes back again. So the other side is again based, and then like experimentally it is evaluated, it is measured. It's not just prediction, it is actual measurement. So reference noise levels, and the figure on the right, basically it shows SUN is silent underwater noise. It's a short form, it's basically a class notation, controlled and advanced. So controlled is a bit lenient, advanced is more stricter by 15 decibels. And you can see the measurements are being done over 1/3 octave bands. This is primarily because we are not just concerned about the decibels, we are concerned about the frequencies, the narrow frequency bands of the low frequency noise which is affecting the mammals, marine mammals or the other marine species. So we break those octaves down into parts of 3, and then accordingly we carry out the measurements. So now these plots, basically this is the requirement. If you want to be, if a ship is required to be holding sun advanced notation, so the measured noise experimentally in the previous slide, they have to be below this curve. And in case a vessel is to have sun controlled installation character, then it has to be below the sun controlled curve. And now the good part is how NK comes into this picture, or how Japan comes into this picture is this data is actually fed into the guidelines by the reference levels were actually measured in real time for around 500 ships at around 300 meter depths of Izu Oshima. Over AIS correct, this was all data was AIS corrected and seawater temperature adjusted as well. So the data is real, and the entire research, it was in this regard for development of these guidelines was carried out at Japan. So worldwide also we had several initiatives, like the European Union, they had 2, Saturn and Piacchio. You can find out more about these online. And Canada, Vancouver, they have one initiative, Eco Action. So they provide for silent vessels almost a 75% reduction in harbor fee. And interestingly, Japanese made gear also qualifies here. And the Japanese initiative, JSTRA, Nippon Foundation project, have been being done since 2015. I already informed you about this on the previous slide. So basically, NK developed a toolkit, and the thing is, these are, if you look at submarines or anti-submarine warfare, so this noise mitigation, underwater noise mitigation, it overlaps into that zone when it comes to commercial shipping. And we do, where commercial shipping is involved, we do not need that level of strict requirements. We are more concerned about a specific frequency band, and it's the environmental impact. So a simplified flow estimation method and a technical toolkit was developed by class NK. So it basically, the flow characteristics, because for the propeller part, they are carried out using CFD analysis. There is the structural noise aspect, which is estimated through FEM, BEM, SEA methods. And then there is this propagation in water, how it reaches the marine ecolife. So there is the ray theory and the normal mode. Using those methods, it is estimated. So regarding the class NK response, so basically there is this flow prediction tool, and then now the first edition, what was developed about the guideline, it was based on ISO 17208 1 and 2. So for the deep sea measurement, which I discussed in the previous slides, and now a newer version will come wherein the shallow water measurement will be brought into picture. So that is how they will be evolving. And then the reduction values, references as per class rules, those are being targeted. Then there is the future approach wherever there are novel changes in designs and operations. So some new notations are being considered for that. And then there is the monitoring part, basically the certification of the onboard URN monitoring systems and the standardized hull cleaning solutions. So final shape of URN rules is still unclear because there is no fixed regulations adopted for it yet. So Class NK is trying their best to keep the tools reasonable, practicable, so as to reduce the uncertainty for the owners and help them be prepared for this. So the key takeaways: low frequency, the noise travels far. There is this IMO framework. Class societies are now actively involved and central to every step. And measurement is going the shallow way, which is more cost effective also and practical also. And now we are in the experience building phase, which is still ongoing till 2028. So now is the time to, whatever we need to do actively about this, it needs to be done now. These are the references. If it interests you, please have a look. And there are two more. There is Class NK Technical Journal number 11. So the research paper on which this presentation is based was based on the first research paper. There are two more. One is for the technical prediction tool. Another one is for the shallow water measurement. So if it interests you, you can have a look at those two papers as well. And that's all for my side. Thank you. Thank you for your time and attention.
Thank you, Pranav, for the excellent presentation. I think you have clearly brought out the class guidelines for underwater noise from ships and the trends in IMO. And it's very clear the noise source, various sources, both structure and hydrodynamic noises, and the pathway to effectively reducing the underwater radiated noise. So we had the presentation of all four papers have been done. And the first paper was pathways to decarbonization. Second one was on regulatory pluralism in global shipping. Third one talks about developing a fouling exposure index. And the fourth one was the class guidelines on underwater noise. So we are well on time. We can take a few questions from the audience. So please specify it is addressed to which author.
Yeah, sure.
Yes.
I think maybe start with the last one, Mr. Pranav. Regarding the noise, as you mentioned that the noise generation coming from propeller cavitation, from the machinery side, from the hull vibration. I think is it not looking to the flow-induced noise? Is it considered in this study or not? I mean,
Thank you for your interest, Dr. Krishnan Kotti.
Krishnan Kotti.
Yes. Basically, there are two aspects of the noise, if we look at the guidelines also developed, and primarily the noise which is being spoken of is flow-induced because of the cavitation around the propeller. But there is a certain cavitation inception speed. So if we reduce that speed, of course, we are able to cut down on that noise, but in that scenario, the structural noise, which is caused because of the vibration of the hull, because of the various machineries mounted, that becomes more prominent. So these are the two aspects. If we try to mitigate one, the other one becomes prominent. But among these two, mostly the cavitation induced, the noise is more prominent. And that is what the guidelines are also actively trying to, if we look at the guidelines which have been developed, these are available free to download for all interested naval architects and other senior members of the fraternity, shipping fraternity. So basically, if we look at those guidelines, we can see that the various, like Dr. Rahim was mentioning regarding several energy saving devices, so to say. So again, when we speak of energy saving devices or any such methods, they are also aimed at saving the energy, but these also have a combined effect of reducing the relevant underwater noise generated. Most of them, but a few of them, like using smaller propellers, that actually sometimes leads to more cavitation, so it does not provide us the desired results. But others, especially improved propeller designs and these airstrip, air injection devices, these are actually also actively helping in reducing the underwater radiated noise. So it's primarily around the fluid dynamics aspect. But there is a secondary aspect also because of the structural noise, which is more prominent in the commercial ships, because there is no dampening provided at the time of construction or the design stages. I hope I have answered.
So when you said rightly that the frequency is low and naturally its attenuation is going to be low and it's going to propagate a longer distance and it's going to have maybe a strong influence on the biological systems. And what is the expected frequency from these type of vibrations, since you said it's low frequency?
Basically, the graph that I shared, it peaks at around 50 hertz. So, and after 100 hertz, it starts falling rapidly. So it's basically 20 to 100 hertz in that frequency band where we are in the most critical zone. And that is also the similar band where the, as you can see, the propeller RPM and all these things are also associated. So that's how the noise gets generated in the same frequency bands.
Can I ask a question to Dr. Rahim?
Okay, sir.
Yeah, Dr. Rahim, it's nicely presented that new fuel systems and been getting popular with marine engines. And you said about LNG has picked up. Already it's going to nearly, already applied to about 800 ships, that's what I understand. And methanol at a lower, maybe 100 or so. I find that both methanol and LNG, the energy density is almost half of heavy fuel, which requires for the same fuel consumption or same range, you have to double the bunkering capacity, the fuel capacity. And how is it managed for the existing ship? Is it that easy to achieve that if you increase the fuel capacity, carrying capacity for the same range of operation, for the same power?
Thank you, good question. For existing vessels, it will be very difficult because you have to have extra fuel tanks to do that. For LNG carriers, which use LNG as the fuel, then it is easy because you can get the fuel from the burned off gas from the tanks. Whereas for methanol carriers, can also use methanol as a fuel because it's a cargo, so part of the cargo can be used. Whereas for other type of existing vessels to convert them, it will be very difficult. So it's mainly meant for new building vessels. So at the new building stage, you are keeping either LNG ready or methanol ready or make it dual fuel. Perfect. So that is the only way possible, I think.
Okay, then here between methanol and LNG, LNG is a cryogenic fuel. It's about minus 160 degree Celsius, I think it's kept. What is the challenge in keeping it, handling a fuel, a liquid at that stage as a fuel?
I think LNG has been used as a fuel for maybe for the past 20 years. So that risk is already calculated and mitigated. So that is perfectly okay because LNG temperature is only minus 162 degrees. Whereas the challenge is with the hydrogen, that engine that is newly developed. So that is minus 253 degrees. So for that one, we are reducing the risk level to that of LNG because LNG risk is already mitigated. LNG vessels are running. So plus all the components are cryogenic, special stainless steel. So that is already there. So I don't think there is any serious problems with that.
One more thing to you, I'm sorry. Okay. So you said about energy saving devices, one of the things is the air lubrication. And which basically injecting air into the bottom of a ship to reduce the friction and so basically this air bubbles are expected to migrate to the propeller. So what would be the effect if such a thing is used on the performance of the propeller?
Yeah, air lubrication system, if you say the history, it is not new. The first air lubricated ship was built in Europe maybe more than 20 years ago. But they abandoned the concept because the main problem was rather than the propeller, the air bubbles gets into the sea chest, to the suction line. So that was creating the problem. So what Mitsubishi done was they have done a series of analysis and modified the hull shape so that the bubbles were diverted away from the sea chest. So it actually escapes to the top. So most of them won't actually come to the propeller. So and for some air that goes into the sea chest, what they have done is they have did some extraction system in the sea chest so that whatever air gets inside will be extracted out. So this won't be a major problem with the propeller.
Okay, last question to Mr. Amit. On the fouling side, you have already projected that the biofouling on ships can lead to about 30% increase in the fuel consumption. That is what you have projected. That is true also over the period. And what is the chance of chipping off the biofouling more periodically instead of dry docking and using ROVs? Maybe when the ship is in the outer sea waiting to enter the port, or when it's in the port, which obviously can chip off the bio growth on the hull and reduce the resistance and hence save the fuel.
Yeah. So you are right. I mean, so that's one of the method we follow in the industry. That when we find that there is a growth of biofouling, then we have to clean it. But we have to clean it smartly, and it also depends on what type of coating is there. So there has been a significant improvement in the coating quality also, right? The silicone paint, which actually for first 3 years means technically means I have seen it practically that you don't have to touch it. The biofouling growth starts from the 3rd year onwards, So yeah, that's if we clean it, do a hard cleaning, then the inspection cycle and cleaning cycle will be very frequent till the next docking. If we do ROB and all, then actually that's a good way of cleaning, and you can still have the every yearly inspection and see how the fouling is happening, But this model will tell you once your FEI starts increasing, depending upon which area the vessel is traveling, then the operator will then they can plan and do the hull cleaning, So this also saves the cost of inspection. Once you start using this model and you build your own trust, then instead of having a hull inspection, you can directly go and arrange the hull cleaning. So that inspection cost is saved. But that is what the operator has to use this system, build that trust, and if it gives the confidence, then from the next time they can save a lot of inspection cost as well. Yeah.
Sir, Dr. Rahim also would like to comment on that.
Yeah, I would like to chip in from the practical aspects. So when a charterer charters a ship, in the charter party agreement, there's a clause for how long the ship can be stationary in warm waters. If it is more than, say, 28 days, in certain countries like Bangladesh, if you want to unload, sometimes the vessel has to wait for a longer time. In that case, the charter party says you have to clean the hull so that the fouling can be minimized, because charterers' only aim is to reduce the fuel consumption. So for that one, they have to use this particular clause. So again, one another thing, during the recent war in Gulf, a lot of ships were entrapped there 3 months, 4 months. And when they were taken to the dry dock, some 10 to 15 millimeter thickness barnacles were found on the hull. So then again, it depends on the coating, as you mentioned clearly, silicone coating. But silicone coating, the problem is, if there's a damage, it is very difficult to repair. So silicone coating is normally applied for fast container ships. So it is okay. But slow-moving bulk carriers and tankers, silicone coating is not that effective. So they normally go for low friction coating, which is very cost effective. It is quality maybe about 70% of that of silicone coating. So it all depends on the parameters of type of ship, which trade route they go, and what is the port time. Thank you.
Can I? Excuse me.
And also,
Sir,
just one
last
point.
question. Okay.
Just one point, sir. So also practically what it has been seen that if your ship is standing idle for let's say 7-8 days, then the growth starts, the falling growth. So that is why we advise the operator that after 8 days, they should actually travel at 10 knots, 12 knots, for few hours, just to make sure that those falling which has started growing on the hull, it does just detach from it, So it will prevent the growth.
Okay, Captain Jaishankar.
Sir, my question is to Mr. Sunil Kumar. Sir, you had said that we need to have a decisive shift towards risk-based, data-supported rule-making that treats safety as something to be engineered rather than engineered towards and rather than quantified, something that is checked off list. That's precisely what you said. My question, sir, is that since I handle safety in Indian Navy right now, it is the data-supported part. Who is collating this data? How are you collecting this data? Is IMO doing that? Is the classification societies doing that? Is the class authorities, or is the state doing that, sir? And how it is done?
Hello. Thank you, sir. I was hoping to escape this because I was looking at the clock. Anyway, that is what I mentioned in one of the slides, that the data is being collected and collated, but they are in like a vertical silos. And primary agencies who are doing that in a scientific way are the class societies. But when there is a casualty or a major casualty or involving life or the vessel or pollution, the flag state, they call it interested party. It can be flag state, port state, or even the country whose crew are there. So they can conduct independent or joint investigations, and these data obviously has to be passed on to IMO because there is a casualty investigation code in IMO and which mandates it. But what is missing is, at the same time, because of the safety management system, most of the shipping companies, ship management companies also collect data related to near misses, incidents, and accidents also. But again, as I said, because of to avoid a blame or to keep their records clean, they tend not to share this data on a global basis. IMO has a database called GISIS, but there it's again whatever is, I mean, for data it is whatever is input, the output is as good as the input. So it is very, very limited. Whereas in aviation, it's almost on a real-time basis and being shared universally among the players. So root cause analysis and corrective actions becomes much easier. Krishnagurti, sorry, is this okay? On Krishnagurti sir's question, there is also a practical problem with the hull cleaning because most of the ports and anchorage area, you're not allowed to clean the hull within their port limits. So it's actually you have to go to an outer anchorage to do it.
Okay, I think with the permission of everybody, we have to close the session. So thank you very much, Dr. Abdul Rahim sir, Mr. Sunil Kumar, Mr. Amit Kumar, Mr. Pranav Sharma for the excellent presentations. And of course, the good discussion we had at the end for the good questions and the clarification given by all the speakers. Okay, so thank you very much. Thank you very much. Okay, let's conclude.
Thank you to our moderators and other presenters for an informative and engaging technical session. We will now proceed with the presentation of mementos. May I request our moderator, Dr. Sadish Babu PK, Associate Professor, Department of Ship Technology, CUSAT, to kindly present mementos to our distinguished presenters as a token of appreciation. I shall now invite each of our presenters to receive the memento as I announce their names. Dr. Abdul Rahim, Commercial Director, Executive Ship Management, Dubai. Mr. Sunil Kumar K, Naval Architect and Advisor to the Board, Capital Register of Shipping. Mr. Amit Kumar, Co-Founder and Chief Technology Officer, Syracuse Solutions, BV. Mr. Pranav Sharma, Senior Surveyor, Class NK. Thank you, sir. May I now request Mr. E.V. Murugan, Sales Manager, Marine Business Sales, South Asia, to kindly present a memento to our moderator, Dr. Sadish Babu PK, Associate Professor, Department of Ship Technology, CUSAT, as a token of our appreciation for his valuable contribution in moderating this session. Thank you, sir. commemorate this technical session, I invite everyone to please come forward for a group photograph. Once again, thank you all. Ladies and gentlemen, while DIMS 2026 comes to a close, the spirit of vision to action continues to guide us. The conversations we had, the ideas we shared, and the connections we built over the past 2 days will continue to shape the future of the shipbuilding industry. As we look to the future of the maritime industry, creating opportunities for students, researchers, and industry professionals to connect and learn from one another remains an important part of that journey. With that spirit, it gives me great pleasure to invite the Society of Naval Architecture students from CUSAT to make a special announcement. May I invite the SNAS representatives to kindly come forward to the dais and make the announcement.
Good evening, everyone. Respected dignitaries, distinguished alumni, esteemed industry professionals, faculty members, ladies and gentlemen. On behalf of the Department of Ship Technology, I would first like to extend our heartful gratitude to our beloved alumni. Your constant encouragement, mentorship, and unwavering support have been instrumental in every milestone we achieve. Whether it is mentoring students through interactive sessions, supporting department development, and or standing with us during our initiatives. Your contribution continues to inspire every generation of ship technology students. I'm here to introduce SNAS, the Society of Naval Architecture Students. Established in 1979, SNAS has proudly carried forward a legacy of nearly 5 decades. Throughout these years, SNAS has served a bridge between students and the maritime industry through the technical seminars, workshops, industrial interactions, alumni networking sessions, expert talks, software training, and various professional development initiatives. Every initiative we undertake have one common objective: to prepare students for the rapidly evolving maritime world. And today, we are proud to present the biggest initiative of SNAS, Anchorage 2026.
Ladies and gentlemen, India today stands at the threshold of an exciting new maritime era. Through the Maritime Amritkal Vision 2047, our nation has set an ambitious course towards becoming a global maritime leader by strengthening shipbuilding, modernizing ports, embracing green shipping, fostering innovation, and developing world-class maritime infrastructure. With over 10,000 kilometers of coastline, a strategic location on global trade routes, and immense opportunities within the blue economy, India possesses every ingredient to become a maritime powerhouse. But no vision can become reality without skilled people. Tomorrow's maritime industry requires engineers, naval architects, innovators, researchers, and leaders who are ready to solve real-world challenges. That is precisely why Anchorage 26 was envisioned. Anchorage is not just another college fest. It is a national level techno-cultural platform that brings together academia, industry, researchers, innovators, and future professionals to learn, collaborate, network, and shape the future of India's maritime ecosystem. And today, it gives us immense pleasure to officially unveil the identity of this year's edition. Well, it is my privilege to invite Mr. Madhu S. Nair, former CMD of Cochin Shipyard Limited, to officially unveil the logo of Anchorage 26. Thank you very much, sir. We would now be honored if you could kindly share a few words with us.
Thanks, and seeing that introductory part, I thought the Shiptech guys were giving Christopher Nolan a run for his money. And well done. I go back to the times in Cochin University, and when we had Talent Time, the event, and then came Anchorage from the department. And I can see that Anchorage is coming out in an entirely different avatar. I know that there's been a little bit of gap in Anchorage, but then the way it's coming back, I think you can count on the entire fraternity here to support Anchorage, do well. I'm very happy to see, like, while sitting there, and the way the two youngsters were presenting Anchorage, the kind of confidence on your face and the tone and the appeal, well done, keep it up. All the best for Anchorage.
Thank you, sir, for your kind words. Now that you've seen what Anchorage stands for, let me now take you through what awaits this October. One of our flagship experiences is the IMO Chamber. This event recreates the functioning of the International Maritime Organization, where participating institutions represent different countries, they present policy papers, and negotiate maritime regulations, debate global shipping challenges, and experience international maritime diplomacy firsthand. Another signature event is the Captain's Table, CEO session. Designed to identify tomorrow's maritime leaders, participants undergo multiple stages, including a Maritime Amritkal Vision 2047 quiz, leadership discussions, and group assessments. The best 3 performers get a chance to sit along with real shipbuilding CEOs in a panel discussion. For researchers and innovators, we proudly present Naval Frontiers, our paper presentation competition, where participants showcase original research, engineering innovations, and technical excellence before eminent academicians and industry experts. Engineering takes center stage in Hydroclash, the RC boat battle. Teams design and build their own radio-controlled boats before competing in challenging maneuvering courses, towing operations, obstacle navigation, and precision handling tasks, which really put their understanding of stability, propulsion, and maneuverability to the ultimate test. Creativity also finds its place in Anchorage 26. Voyage in Frames. People with exceptional photography skills can take part in this competition where they capture compelling stories through a single frame. And this Visionet, our videography competition. This challenges participants to create impactful visual narratives through cinematic storytelling and creativity. And that's only the beginning. Anchorage also features expert talks by renowned maritime professionals, technical workshops, software training sessions, motivational interactions, networking opportunities, mentalism performances, cultural evenings, and anti-drug awareness football tournament, and many more engaging experiences over the course of 3 days. Before Anchorage itself, we are delighted to invite all of you to a kayaking experience at Kadamakudi, taking place on this Saturday, the 8th of August. It promises to be a wonderful opportunity to explore Kerala's beautiful backwaters while connecting with fellow members of the maritime community.
We are truly grateful to the many organizations that have already partnered with us as sponsors and supporting partners. The confidence in Anchorage motivates us to make this edition larger and more impactful than even before. At the same time, we warmly welcome organizations, institutions, and industry leaders who wish to collaborate with us, whether through partnerships, sponsorship, technical engagement, or knowledge sharing. We would be delighted to work together with building a platform that strengthens India's maritime ecosystem. As India sails toward its Maritime Vision 2047, the future will not be shaped by infrastructure alone. It will be shaped by the collaboration, innovation, and the people who drive them. This is what Anchorage strives to create, a platform where academia meets industry, where ideas become innovation, where future maritime professionals begin their journey. We sincerely invite each one of you to be part of Anchorage 2026 from 10, 11, 12 of October 2026. Thank you so much.
Thank you, SNAS members, for that wonderful announcement. Before we proceed with the valedictory session, I would like to invite Dr. Abdul Rahim, Senior Representative of Middle East Alumni Association of Ship Technology, for another announcement.
Good evening, everyone. I take this opportunity to invite all maritime professionals and delegates here to MASTEC 2027, the International Marine, Offshore and Shipping Conference organized by the Middle East Alumni of Ship Technology, or MAST, UAE. The conference is planned for the first quarter of 2027. So MASTEC 2027 will be the 7th edition of this flagship event, which was first launched in 2008. Across its previous editions, the conference has welcomed over 1,500 delegates and featured more than 75 technical papers, making it one of the region's premier maritime knowledge sharing platforms. The final venue and program structure are currently being finalized. I hope you will definitely participate either as a speaker, delegate, sponsor, or partner. For any information, please feel free to contact me or any of the MAST alumni present here. Our previous edition was hosted at the iconic Burj Khalifa, making the first alumni-led conference to be held at this prestigious venue. So with this, we are going to show you a teaser. So please enjoy the teaser video of MASTEC 2027.
motto of providing unrivaled environment to exchange information, interesting topics have been lined up for this year's conference, some of which include renewable energy, technical innovations in shipbuilding and marine engineering, marine heavy lift and transport, marine operations and safety, and many more. Bringing together the global market leaders under a single roof, Mastic invites you to become a part of this prestigious event where industry comes together to learn and grow together.
Thank you very much for watching the teaser. Hope to see you next year in Dubai. Thank you.
Thank you, Dr. Abdul Rahim. As we bring DIMS 2026 to a close and look ahead to the future of our maritime community, it is my privilege to invite Mr. Mohanlal Pillai, Dostas President, to deliver the closing remarks.
Good evening, everybody. What an incredible 2 days we had. And this has surpassed all our expectations, not only in quantity, but then the quality of discussions and the interactions we had. So it is truly commendable. So as I stand here to close this DIMS 2026, I come out with my gratitude to the sponsors, to the attendees who has added value to this thing, and the support we had from all the alumni, the students, and everybody associated with that. So thank you all. So till we meet again for DIMS 2028, that's a goodbye from us. Thank you all. This cannot go close without acknowledging the role of, I'm only a figurehead. The real work was done by the DIMS committee. Their continuous toll for the last so many months, planning, execution, everything. So I would request all of them to come on the dais and take a photo. Come. They need a standing ovation. Please come on. You also come. Hey, Deepak. One more thing. Just there was a silent group which was supported this, our students. There is a big army of students who are supported in the background. They are not very visible. That was a tremendous help. So please give them an applause for them also. Thank you. Thank you.
Thank you, Mohanlal sir. As we bring DIMS 2026 to a close, I hope you live with knowledge, fresh perspectives, meaningful connections, and renewed inspiration after these 2 enriching days. This year's theme, Vision to Action, shaping the future of shipbuilding industry, has guided us through thought-provoking panel discussions, insightful keynote addresses, engaging technical paper presentations, and emerging technology showcases. Together, these sessions have demonstrated our collective commitment to shaping the future of the maritime industry through innovation, collaboration, and shared expertise. We extend our sincere gratitude to everyone who have contributed to the success of seminar. Our distinguished speakers, session chairs, moderators, panelists, presenters, delegates, exhibitors, and all our participants. A sincere appreciation goes to all our sponsors and partners for the invaluable support. We extend our special thanks to our platinum sponsor Aviva, gold sponsors Mazagon Dock Shipbuilders Limited and Dassault Systems, silver sponsors Catmatic and Chowgle Shipbuilding Division, registration area sponsor Aries Energy, delegate kit sponsor Samudra Shipyard, delegate badge sponsor Sea Delta Marine and Offshore, associate sponsors NAPA, Class NK, Ocean Opt, ABB, Capital Register of Shipping, Navsys Marine, Wind Constructions, and Siemens Energy. And our supporting sponsors, Hindustan Shipyard Limited, Sea Marine, a division of Concepcia, Cochin Shipyard Limited, Admiral, Indian Register of Shipping, and Garden Reach Shipbuilders and Engineers Limited. We also thank our event management partners, BIS Event Management and Intiwood Entertainment, whose dedication ensured the smooth execution of DIMS 2026. A heartfelt appreciation also goes to Dostas Executive Committee, the DIMS 2026 organizing team, and our volunteers whose tireless efforts behind the scenes made this event possible. Thank you all for your enthusiastic participation and support. We look forward to welcoming you again at DIMS 28 as we continue to strengthen this platform for collaboration, innovation, and excellence in the maritime industry. Until then, we wish you a safe journey home and every success in your future endeavors. Thank you and have a wonderful evening.